Hi, good morning everyone. Welcome to ACCon 2022-2021 Day 2. Hi Praveen, can you hear me?
Yeah, I can hear you, Shiva. Good
Okay,
morning.
good morning. Welcome everyone. Hope you have a wonderful day ahead. The session is going to be by Praveen Raghuvanshi. The session is on serverless deep neural networks (DNN) using Azure Functions and ML.NET. Praveen is an cloud architect at Samsung and he has got a vast experience in AI and ML. We want to discuss the same about on this topic. Thanks, Praveen. The stage is all yours. Thanks for joining.
Uh, Thank you, Shiva, for the great intro. Uh, welcome everyone for the session today. I hope you have been enjoying the conference till now, and I see that the conference has a lot of great talks that has happened in the past, and we got to learn so many things. So with that, I'll also start with something that you may take up today and may try out something out of that one. So let me just share my screen. Okay. Okay. So welcome again. Good morning, good afternoon, good evening, wherever the time zone you are in. And like it's a totally a global conference. Uh, a round of applause for the team that is behind and who worked tirelessly on making it a great success. So today I'm going to talk about serverless deep neural network with Azure Functions and ML.NET. A brief introduction about myself. I'm a cloud architect at Harman. It's a Samsung company. The domain I work is in professional audio, video, and control. Area of expertise is cloud and distributed computing, and I'm quite interested in AI, ML, and IoT space. I'm based out of Bangalore, India, and a member of a .NET Foundation. Also, I'm a Microsoft Azure certified. So this is going to be the agenda for my today's talk. I'll be touching briefly on the serverless, then the serverless offering from the Azure side. Then I'll talk a little bit on the deep neural network and how we can leverage the deep neural network for image classification problem. And the framework that I'm going to use today is the ML.NET for image classification, followed by a small demo. What is serverless? So, when we say serverless, it doesn't mean that you don't have any compute resources or the infrastructure that is required for it to run. It just means that you don't own those things. It's already taken care by different cloud providers as of now. So, when you talk about the traditional way, so you have front end logic, security, back end logic, database, so all these things plus the infrastructure, the networking, storage, all have to be managed by the enterprises itself, and we don't have access to that. The enterprises uh, need are bound to use those things irrespective of their usage. So that is like sometimes they are underutilized, sometimes you run out of resources and you suffer your business suffers a lot. So with all those challenges, the scalability was the main challenge that used to be there. But with serverless, all those things are managed by the cloud providers, and you don't own the infrastructure, the networking, the storage. Everything is managed by them, and you just focus on the business logic that has to be run within your within your cloud infrastructure. So with that comes the flexibility of utilizing the resources in the sense that you can scale up or scale down any of the resources based on your needs. So you're not the resources are not kind of underutilized at any point of time. You just pay for the usage and you don't pay for something running 24 by 7, for example, your VMs and other things. So it becomes a really great point or a great thing for the startups. Plus, if you want to do some POC, then you can just quickly spin off the things and start writing your business logic and see how it comes out of that one. And once you are confident on that, then you can easily deploy those things onto your cloud provider serverless infrastructure. So the management part is all taken care by the cloud providers. You only focus on your business logic. Now coming to Azure Functions. So this is a serverless offering from Microsoft for running your business logic. So basically, it includes two things. You have your own code, which needs to be run. Plus, it requires a event. So based on what event the code has to run, and the third part is the data. So if you have some data which you can pull from the database that is required for your business logic to execute, you can add that as well. So it all these all components comprise to make a Azure function. It's very much similar to what we have a Lambda from AWS. Now, coming to the Azure functions, so there are multiple connectors available within Azure functions, so with a lot of flexibility within them. So some of them are like Notification Hub, Event Grid, Event Hub, Cosmos DB for your NoSQL offering, then Twilio for sending your SMS and emails, then Service Bus for your messaging infrastructure, then storage wherein you store your structured or unstructured data. For example, you can upload an image or a video file. So whenever any of these activity happens, a trigger will be raised and that will be listened by your Azure functions. So it really provides a very plug and play kind of a mechanism. You need not to worry how to listen to those events. It's already provided by Azure functions. Now, coming to the deep neural network, um, so we'll see how it lies within the AI ecosystem. You have artificial intelligence at the top, and under that you have machine learning. Under that you have neural network, and under that you have deep learning. So this is like one of the sub component of the artificial intelligence, and it is being used in many places for performing a lot of AI and ML tasks. Now, before I jump into the details of deep neural networks, let's try to find what is the basic difference between a machine learning and a deep learning. So, when you talk about the machine learning, we feed in the input. Input is your data, and there is something called as a feature extraction. So, which is a manual activity, maybe performed by a data scientist to check what all features are present in that input data, and based on that they categorize and define, okay, well, these are the features present in the data set, and they feed in the data to the machine learning algorithm, which learns and gives you an output out of that one. So the cumbersome part here is the feature extraction. So it requires a lot of domain knowledge. It requires a lot of a good data scientist who can extract based who can label the data set and see what is present in the data set. And to overcome these things, we have the deep learning, wherein this part of feature extraction is automatically done by the machine learning algorithm. So we need not to look into what all features are present within the data set. It takes the data set and based on some patterns that is present in the data set, the algorithm comes up with the features that is present within the data set. So once it has extracted the features, it feeds it into the neural network, which learns those features, and based on the it's learning, it gives you an output out of that one. What are the classes or the labels that are present within your data set? Now coming to image classification. So image classification is one of the subset of is one of the problem statement within your AI ML space, wherein you feed an image to your neural network, and once the image has been fed, it gets processed by the neural network, and ultimately in the end it gives you a probability of the objects present within the image. For example, if you look at this figure, you have a car that is present in the image, so that is being fed to the convolution neural network. And once it is being fed, the neural network starts learning the things present within the image, and based on the probability that it finds, okay, this is like 95% this is a car, whereas 3% it is a truck, then 2% it is a bicycle. So it tries to visualize and it tries to see the patterns that is present in the object in the image. For example, here you have a image with a car which is having two tires, two headlamps, and the shape of the car. So these all things contribute to the algorithm, to the learning of the algorithm, which predicts the image object present within the image. So this is just a brief example or a visual representation of how the neural network learns image objects within an image. So when it's a deep neural network, how the deep neural network is different from a normal artificial neural network is a deep neural network has multiple layers within it. So, whereas in an artificial neural network, there's only one layer that is present. If anything is more than one layer, that means it's a deep neural network. So, if you see here, this is your first layer, or before to that, there will be some more layers that. So, in this layer, we can see that what the neural network is trying to learn is the edges. So there are some edges within the image. It is trying to learn those things, and as we move further down in the neural network or the deeper layers, it will try to learn further things with present within the image or the for the image within the image. For example, you can see here it can started to learn the curves along with the edges here, and it started to form the curves or the small parts of the object here. Whereas if you see this one here, it's very much at the end of the neural network, wherein it tries to reconstruct all the things that it has learned out of the previous layers, and try to form an object within that, out of that one. You can see here it started to have the full set of images of a human being, whereas in the second one you can see it has started to see the images of a car, third one the elephants, and fourth one is the chairs. So this is how the learning takes place within a deep neural network. The initial layer are more mainly focused on learning the small things such as edges and gradients, whereas the last few layers is used for categorizing it or for labeling it, like what is the type of a thing that is present within the image. And in between layers it tries to combine all those patterns that it has learned in the previous layers to form some set of patterns out of within that one. Now so today I'm going to use the transfer learning. I'm not going to train any model from scratch. So this is the benefit if you have a problem statement that is already being solved by someone, and with lot of data set that he has used, then in that case it's better to go with the transfer learning rather than training something from scratch. So today I'm going to solve the problem of identifying a dog within an image. that is already being solved using a ImageNet dataset. ImageNet dataset is comprises of like 1,000 classes, in which you can see a lot of different breeds of dog. So it is already trained on different breeds of dog, uh, and plus it is being trained for around like 1 million images. So if my problem statement is just to have something very much similar to what is already trained for ImageNet, I'll definitely go with that one. The reason being, I need not to have that much of data set of 1 million images, and just for prediction or inferencing, and the time that it takes to train those things, it's very high, is very much. So we can avoid all those things by leveraging the already trained models that is present. So this is how what basic difference between training from scratch and transfer learning. So you feed in the data set. In training from scratch, every image is being scanned, and it gets learned by the model itself, by the algorithm, by the neural network. Whereas in transfer learning, we take the existing model which is already trained on a data set and for a certain set of classes or labels, and we just load that model, retrained model, and apply it to our new task. So for example, if you have a model that is already trained on something and you want to use it for a new task, then you just use that model, and maybe in for the inferencing part you can remove the last couple of layers, and use that one to make the inference for the new type of objects. So suppose it is being trained for 10 classes and you just want it for 2, so you can reduce the number of classes in the last layer itself. Instead of having the 10 here, you can have just 2 layers out of here, and that way you can customize your neural network for your problem statement, instead of going any things, instead of training it from scratch. So this will reduce, or this will help you in uh, moving fast and experimenting your things, coming up or developing some POCs. So this is really a good way of developing things very fast. So this is a basic overview of transfer learning. So whereas in a normal um, neural network, when you are training anything from scratch, you take the convolution base. So these are the different terms that is used within your neural network. So you train different layers from scratch, you define the classifier, and you make a prediction. So this is for already trained model, and you want to classify something from that class only. Suppose it is being trained on 1,000 classes, and you the thing that you are going to predict is belongs to those 1,000 classes. In that case, you need not to modify anything. You can just use the pre-trained model and make a prediction just by using the pre-trained model. Whereas if you want to make some changes in the new classifier, in the new set of classes that you are going to predict, so in that case you can use the load the pre-trained model and just strip off the last layer wherein you have the classification part. So that classification part can be changed or updated with the new classifiers. Whereas if you need some more control within the system, then you can start uh, utilizing the last few layers also, so that you can make those changes in the last few layers based on the problem statement that you have. So in all these cases, you are leveraging the transfer learning. That means you are leveraging the pre-trained models, and you are not training anything from scratch. Whereas if you are using a new classifier, you need to train it on your new data set for whether it can be a small data set, because already the things have been learned by the neural network. So this block is very common to everything. In the initial layers, as I told you, it only learns about the edges and gradients, and further down the line it starts connecting the things, and it creates a object out of that one. So initial learning is common to all the models. So it can be easily checked. So if you see here, the white one is the frozen. That means we are not going to make any changes within these things, and we are only going to make changes here. So that means we are going to utilize the weights that is already present within the neural network. Now coming to ML.NET, so this is a very good framework developed by Microsoft, and it's been there for a while. For example, I think it's been around in the Microsoft has been using it for the past 10 to 20 years. This framework for its products such as Bing, PowerPoint, Power BI. So those are the different products where it is being used within Microsoft. But couple of years back, they decided to open source and give it to the community to use. So it's very much similar to what you see as a PyTorch, a Keras, or Scikit-learn. So, but this is an offering from the Microsoft for .NET developers. So till now, if a developer wants to move into the AI ML space, then he has to learn either Python or R or some other language. Then that will become really challenging for them. But with the introduction of ML.NET, that thing has been overcome. So still it is growing. It has not achieved to the level of other frameworks, but there is a huge amount of investment that is going within this framework, and we see a lot of features rolling out every week within the ML.NET space. So it's like some of the features of this framework is you can build your own. That means you can for example, if you are doing sentiment analysis, so those kind of things can be easily done using ML.NET by writing the code in C sharp. You can train the model, you can feed in the data set, you can predict out of that one. Everything can be done for such kind of problem statements, but still it's evolving. So there are some limitations for in the framework. That means you cannot train it on images as of now. You have to use the pre-trained models as of now. Then it is developer focused. So till now, for Azure people, they have to use the Azure credits for they were using Azure Machine Learning Studio and other things present within the Azure. Those comes with a cost, but with the introduction of ML.NET, you don't need anything of that to try few things. You can run this framework locally as a nugget package, and you are good to go with that thing. So this is extensible in the sense you can export these the models generated out of this one as a Onyx runtime format, which is being added by many of the other frameworks, just PyTorch or Keras. So same way, anything that is being developed by within those frameworks and has been exported into Onyx format can be easily used or utilized within this ML.NET ecosystem. It is proven. That means it has been used within Microsoft products. So one of the recent thing that I saw was design ideas within your PowerPoint. As soon as you create a slide and add a content to it, it starts suggesting you some slides for that one. So this is really great, and it's proven. It's a proven framework. It's not a very new framework, but and it can scale to any extent. And it work. It's a open source and cross platform, means you can use it on any of the platform, being Mac OS, Windows, or Linux. So today I'm going to demo a image classification, wherein I'll be uploading a image which is being uploaded to a Azure function. So Azure function exposes a endpoint wherein I'll upload an image. So the image, when the Azure function gets the image, it loads a model from the Azure blob. So this is your Azure Blob storage where I have saved my model. So this is the model file name. MobileNet 27.onyx is this is a 2.7 version of MobileNet. MobileNet is a stripped down version of other models, and the reason being it's very lightweight. It's around like 14 MB only, whereas if you go with the ResNet or some other model that is around like 300 MB, and which impacts the loading of those things within your Azure functions. So Azure functions has a limitation of execution time and the memory it is going to use for that. So if you try to load a big file such as 300 MB, it won't allow you to do that one. So we have to use the some lightweight models only. So with MobileNet, the accuracy is around 65%, whereas with ResNet, which is trained on larger data set, or so in that case, the accuracy is around 88%. So you take a hit back on the accuracy, but if you are not much concerned about those things, this is a very good way of implementing the things in a very efficient way. So once you load a model from the storage blob storage, it returns some model to the Azure function. Then ML.NET takes the model and makes a prediction out of that one, which is being returned to the Azure functions back, and it is being returned to the user as a predicted class or a label. Now, there are some customer success stories within ML.NET. For example, you have Asgard system, scan. So these are other than the one that is being used within the Microsoft. So it's not like the framework is being used within the Microsoft only. Now as it has been open sourced and it has been made public to a couple of years back, so it has been continuously being added by the different set of customers for their different problem statements. To give you an example, maybe one of the example is there was a company in US where they wanted to see visualize the theft happening within the petrol stations, so or the stations. So within that, they have installed the cameras and they have the computer vision thing running on their cloud, wherein the ML.NET framework was detecting the objects within that one, and based on some activity that is happening, if there is an abnormal activity that is happening, and then it used to send a trigger for that one. So this was just one of the use case of a computer vision leveraging the micro ML.NET. With that, I'll go back to the demo. Okay. So this is my small Azure function, and maybe I can start from, yeah. So this is a HTTP event trigger only Azure function. So if you see here, I have the HTTP trigger here, and this is the function name that I have the classify image. So maybe I can create a new project from scratch. So I already have the setup ready, but I wanted to showcase how we can create this a simple application within half an hour or so. Okay. So I'll use the Azure function. Okay, easy. So I'll be selecting the HTTP trigger here, and I'll be using a storage emulator for persisting my model file. So if you see here, this is the storage emulator that is already running in my system. I'll not give any authorization as of now. Let it be anonymous. So in the meantime, if it loads, I'll show you how the model file looks like. Okay. So the model file you can get it from here. So I got it from here. This is your mobile net Onyx file. Okay, and the way there is a utility or a tool that is through which you can visualize this one. So if I go and open that file, I can see what is present within my model. So this is called as a netron. I think I have already opened. Yeah, this is already open to me. So this is how the structure that is present within your model. So if you click here, you can see that the input is this is the batch size. This is your number of channels. So this is a RGB image, and this is the size of the image that it expects. So it expects an image of size 224 by 224, and this is the name of your input thing, and this is the name of your output layer. So, and these are the number of classes on which it has been already trained. So we can see it has already trained on 1,000 classes, and we can see it here as well, like this is the one. And so what happens is, if you want to leverage only two classes or certain number of classes, you need to make a modification to the last layer out of this. So instead of using 1,000, you can use 2 layers or 10 layers based on your need. So then it will work for those many classes only, or it will predict the probability for those classes only, not from the 1,000 classes. This is how you can tweak the last layer for as per your requirement. Okay. Yeah. So this is your default Azure function that is present. Now I'm going to add some dependencies to this. Okay. So for retrieving the files from the blob, I'll use azure.storage.blobs. Yeah, this is the one. And I'll be using something little older. Then, for leveraging the ML.NET framework. I'll use the Microsoft ML. Also, I need Onyx runtime. Also, I need image analytics. It is being used for identifying the objects. Onyx runtime is used for loading the model, which is present in the Onyx format. So, sorry, the image analytics is used for transforming the images. Suppose you have an image which is more than 224 by 224 pixels, then you have to transform it into the dimensions which the model expect, which is 224 by 224. And another thing is vision. Yeah, this. So this is like a main API for doing the computer vision task within ML.NET. Okay, I think we are good with that. I'll rename this one. Okay, yeah. So these are the basic activities I'll be performing within this function. App settings is yeah, local settings as of now. So So here I have defined the things that allows me to connect to my blob storage plus my Azure Functions runtime. So if you see here, this is the container name I am providing, and this is the model file present within the container. And I can show you that as well. So this is emulator running locally. So this is your Microsoft Storage Explorer, where we can see the blob or the container, sorry, and it has a file within that one that is mobilenet2-7.onx. So we are going to load this file into our Azure function. So this is the code for that, for specifying the settings or reading the things from your local.settings.json. So if container name I'm trying to get, then I'm using the use development storage, that means the local one. If it is deployed on Azure, and it will use the information from there. Otherwise, this is from the local part. Same thing is being present in the Azure as well. Azure portal, we can specify those things. Now coming to the load model part. So this is the one. So what I'm doing, I'm just creating a temp directory here where within my Azure function, I'm reading the file from the blob and saving it within the model and saving the model to the temp path. So Go ahead. So this is for creating the temp directory. This is the place where it is reading it from the blob, Azure blob. So it can be your local also. It can be within your Azure also. And it is what it is doing. It is just reading the file and giving us back the model stream. Then ultimately we are taking that stream and saving it to our path, the temp path that we have specified. And we need to add couple of references here. So we need using ML, then transform.image, then blob specific things. Yeah. Okay. So once we have loaded the model, we need to leverage our ml.net for mm, loading the model within your ml.net framework. So this is the code for that. So what we are doing is this is our ML model input name. So this you can get it from this file. So when you select the input, you need to check what is the name given to that one. The same name has to be present there, and the output name has to match with this only. So that this is for the last layer, the output. So this is how, if you select this one, this you will get this model name. So these two things have to be matched. Now ML context, this is the main thing that is present within your ML.NET framework. This is the entry point, and it's very much similar to what you have a DB context. It takes care of all the things that is present within your model. So be it the different randomness that is present within the ML.NET context, such as parameters, such as how to split the data. So those things are present. It makes a record of those things. Seed is to have is defined to make your predictions reliable, or you can say if you are training or making a prediction every time on the same thing, it will give you the same data set. If you don't specify the seed, there will be some randomness that will be applied, and you may get a different outcomes because of that one. So seed is to maintain the consistency across all the execution that are going to happen. Now coming to the model input. So let me, maybe I'll explain it from here only. So this is nothing but your input. So in our case, the input is a image which is having a specific height. So suppose we saw that our model accepts image of size 224 by 224. So I have defined these one as 224 by 224. So this variable input holds only one property, that is a image and of type bitmap. So we will load the image that we received by uploading from the client and transform it into a bit and load it into a bitmap. So our model expects a bitmap file only, whereas our output is a score. That means what is the probability of that class. So it gives you an array of those probabilities. And so once we loaded the we defined what is the, so empty data is here required. The reason being, we are not training the model, we are just inferencing the model. Okay, and that means we are just making a prediction. So but the mm, ML context need to understand what is the type of input that it has to take into account. So for that, we have to provide the empty data. This is for reference only. This has nothing to do with the actual training of the model. So we know this is the data, and it is of type iData view, which is something coming from ML context only. Now this is where we set up our pipeline. So the first thing that we are doing is we are resizing the image. So suppose we got an image which is having dimensions other than 224 by 224. In that case, this transformation, what it will do, it will resize those images. Once the image has been resized, then we need to extract the pixels out of that one. That we need to know what is the value of the pixels within that image. So this transformation is done by extract pixels. The last thing, once the transformation is done, then we will apply the Onyx model. So we already here we will specify the model file, so which we are going to load from the Azure blob. So this file will get utilized here, as we are specifying the path of the file, and it will be applied on the input that we have specified, or the image that we have specified. So once this pipeline is over, then we will just train it. So this is the thing for training. So pipeline.fit, the data is an empty data. So what it will give you, it will tell us, okay, what is the model, what is the structure for that particular image. Once we have the model, we'll make the prediction. So before making the prediction, we have to load the file image. So this is how the request that we got as part of the Azure function. We'll take the body out of that one and create a bitmap image, and we'll create an instance of model input, specifying the test image as a bitmap, which we just saw. And how the this is a prediction engine is something that takes the input, not the input, that where we need to specify the type of input and the type of output. So we are specifying the type of input it takes, the type of output it gives, and it takes the model as an input. So we specified the model which we got it from here. So this is just creating a prediction. Till now we haven't done any prediction. Now for prediction, there is something called as a predict API, which is used to make a prediction for a single image. So the single image that we have is we already specified an object for that one. So now we are passing in the actual image, which the prediction engine will utilize and make a prediction out of that one. So it will give a prediction out of that. So prediction is a uh, output type. So it holds a array of values which are nothing but the probabilities for different classes. We are going to take the max out of that one, and once we get the max score, we are just formulating the uh, output of that one and giving it back to the client. So this is something like class to ID2 level. So as i'm using a as I'm using the MobileNet V2 that is being trained on ImageNet. So this is a ImageNet 1000 classes, IDs and its label. So you have each ID and a corresponding label to that one. So I also have this one for the time being in my local here itself. And it is just reading that content and giving me the label out of that class. So suppose the model detected 10. So in that case, 10 will be ostrich. Sorry, not ostrich, but brambling. So it will convert that number 10 to its label. So this is all we need to make this one working. Very simple code, very easy to set up. And once we have all these things, we can just run this. Okay, now my function is running. Yeah. I'll hit the API, the local one. So my local one is localhost 7071 API is classify image. I am providing in the body the image of a dog, this one, and I just hit send. It is saying executing, loading model saved to this. Oops. Yeah, you can see it has predicted 212. That is a English setter. And when we say English setter, it is one type of a dog. So the model has predicted quite well. It may not be very accurate, but we got a proper class that it's a dog. Now, the same thing I have deployed on Azure. Uh, So this is my Azure function where it is already deployed. I have serverless DNN function. Yeah. So this is the endpoint of it. And I have the same thing here. Serverless DNN function, Azure website, API classes. So same thing is deployed there. So no change is required from the local to the Azure. You just need to right click and it is also predicting you 212. So the benefit here is I need not to do anything here. I just right click and deploy to Azure. So for example, you have this. If I want to deploy it to Azure, I'll just go and publish. So it gives you a wizard which you need to follow, and once it is done, your model will get deployed. Already you are using the local blob, so no need to make the changes there. You just need to add some things within your settings. Yeah. So you can see what platform you are using, everything is there. So no changes are required at present. You can make those changes within your local and utilize it. So it's very simple to push it to Azure as well. And I have provided everything. I have written a blog for that one. This is the blog wherein it tells you step by step things how you can create the leverage transfer learning or load the mobile net model and how you can push it to Azure also. So it has a step-by-step instructions available within this. So you can see I have provided the screenshots of the wizard as well, the code, how to navigate and till the end, even for Netron. And any error that comes, even I have given something for that as well, how to overcome those things. So till now it was deployed on a local host. Now we are going to deploy it on Azure. So for that also everything is there. So you can just follow these things and you are good to go to create your own image classification application using ML.NET. So with that, I conclude my demo and I'm open for any questions that you have. And all the code and everything is available here. Yeah,
Hi Praveen, thanks for a
I
great session. As
thank
of
you.
now, I don't see any questions. If there are any questions, we can take that offline. Um,
Sure, sure.
People, if you have any questions, you can post them on YouTube. Praveen will answer them there.
Yeah, please.
And if you
Thank you,
want to share
everyone.
your, if you want to share your URL of the blog post, you can do that on YouTube itself directly. Like the
Okay.
last. Okay. Okay,
Okay. I
you've
have just
given me the
made.
GitHub link. Yes, yes.
Yeah,
I'll
you
I'll
can
post
just
that. I'll
share
post
this.
that. I'll do
Thank
that.
you.
I'll do that. Thanks for a
Thank
great
you,
session,
everyone,
Praveen.
and thanks for
Thanks.
the organizers for having such a great meetup. Thank you, and have a good day. Enjoy your
Thank you.
conference.
Thank you. Thank you so much.
Hi, organizers. Thanks a
Hi.
lot
Hi,
for having me
Abhishek.
on the conference.
Hi, Abhishek. Hi, Abhishek. Can you hear me?
Yeah, I can hear you. Is my voice loud and clear?
Yes, it's loud and clear. Perfect.
Okay, perfect.
Hello, everyone. Thanks for joining in. Hope you have a wonderful session. The next session is going to be by Abhishek Gupta. It is on containers. Basically, Abhishek is a principal engineer at Citrix. He has worked on, he has a wide experience. He has worked on microservices, Kubernetes, distributed systems, and probably all the technologies. So the next session is going to be fully on containers. Enjoy the session. Post all your queries on the YouTube chat window, and the feedback URL will be provided. Please provide the session feedback on the URL. Thank you. Abhishek, the stage is all yours. You can take it.
All right. Hello, everyone. We are going to start now. All right. So this discussion, this tech talk is going to be a marathon talk because I have to cover a lot, and I'll make sure you should not feel sleepy, right? So the title is little weird, and there is a reason why it is so. I'll be covering 50 recipes, 50 best practices, 50 shades while working with containers. And even if you are a beginner, you are a pro, you are an expert, you will be able to relate with, if not all, then at least some of them. And it will be after this session ends, you will be having some good knowledge related to all varieties of aspects related to scaling, making clusters highly available, how to take care of loads, or all variety of things, right? So I have categorized things into 10 categories. We will see those things later. Right. So my name is Abhishek Gupta. I am working as a principal engineer in a company named Citrix. Citrix is very famous for virtual desktops as a service. We partner with all the major cloud providers, Azure, AWS, Google Cloud. Here in this session, you will see 50 shades of containers, basically 50 recipes, or you can say 50 guidelines to run highly available containerized workloads. We will see some general Kubernetes guidelines, and since it's Azure conference, we'll see some flavor of Azure Kubernetes service, which is also known as AKS. All right. So what I did, I categorized these 50 shades, 50 recipes into 10 broad categories. Here are these categories. What best practices a developer should follow, or during the development process, a team should follow. How to pick or choose a right type of storage, scalability, networking, security, cost efficiency, how to take care of governance. It's a big concern these days. How to take care of updates, rolling updates, updating your master node, your control plane, and the client nodes, updating your pods. What is the concept of operators? How operators makes your life easier if you have to run a Kubernetes workload. And in the last, we'll also cover monitoring, how monitoring can make our life easier, why we need not to work on weekend to keep an eye that whether our system is up and running, right? If we can have a right monitoring tools in place, we can outsource that task of waking up on weekends to those right tools. So we'll cover a lot of these things in probably next 50 minutes or so. This is going to be a session packed with lot of knowledge, all varieties of knowledge, and recipes, best practices, and I'll try my level best to make it understandable to you in a very easy words, in a very easy way. Okay. All right. Let's start with the first category, which is developer, right? Before we talk about highly available things, application goes on production, how to enable monitoring. First, we will be developing. And before developing, we need to be aware about what are the various development tools. So here we'll talk about defined pod resource request limits, at the time of development, right, in your YAML file. What is the concept of CPU and memory request, pod CPU and memory limits, and what are some very good IDEs through which we can develop it, and how you can debug a Kubernetes cluster which is running not on your local machine but on your production instance or probably test instance or any instance running on Azure. So we'll also talk about some of the plugins which will make your life easier. You need not to, update a patch and then deploy and then see by opening up portal whether you are able to deploy that update in a expected way or not. Through this plugin, you can simply put a debug pointer while your workload, your pods are not on your local machine. They are running on Azure, and you will still be able to debug your machine, debug your application. Okay. All right. Let's start with the first one. First thing is define pod resource, request, and limits. So let's say you need to always set pod request and limits on all pods in your YAML. You should not leave your YAML without mentioning limits. If, let's say, the AKS cluster uses resource quotas and you do not define these values, then your deployment may be rejected. Use pod request and limits to manage the compute resources within an AKS cluster. Pod request and limits inform the Kubernetes scheduler at which compute resource to assign to a pod, right? Next thing is pod CPU memory request. So let's say if your pod requests a defined set of CPU and memory that your pod needs regularly. In your pod specification, it's a best practice and it's very important to define these request and limits based on the business knowledge you are having, that I may need this many replicas, okay, or these many CPU and memory requests I may need. If you don't include these values, the Kubernetes scheduler cannot take into account the resources your application require to aid in scheduling decisions at a later stage. Third thing is pod CPU memory limits. Yeah, basically pod limits define when a pod has lost control of resource consumption. When it exceeds the limit, the pod is marked for killing, right? And this behavior maintains node health and minimizes impact to pod sharing the load. So if let's say you are not setting a pod limit, then the default and you are leaving it default, then you are actually making it little vulnerable. Avoid setting a pod limit higher than your nodes can support, right? I should not support ideally 4 cores if my node is not supporting 4 core, or 16 core if my node is at all not supporting 16 cores. In fact, the best practice is use define your limits in the form of single core. And if you need multiple cores, deploy multiple pods. If you need 4 cores, you just replicate same pod 4 times, 1 core each. So this is even better. All right. The fourth thing, much more related to tools and extensions. So let's say you need to develop and debug applications again in AKS cluster. AKS is Azure Kubernetes Service. There is an extension called as bridge to Kubernetes, and it redirects traffic between your connected Kubernetes cluster and your development cluster. And how the internally it works, I'm not sure, but I think it established some sort of tunnel between your dev box and the deployed Kubernetes cluster. Bridge to Kubernetes, this extension actually allows you to run and debug code on your development machine without repetitively deploying, packaging it, creating an image, pushing an image, and then pushing it to actual pods. You can save a huge amount of time by doing this directly from your VS Code. Next thing is the VS Code itself. There is a Kubernetes extension for VS Code built by Microsoft. Both of these extensions are built by Microsoft. Just install and use the VS Code extension for Kubernetes when you write YAML manifest. Now, what will happen? It not only gives you a good IntelliSense, but it helps you browse, deploy, and edit capabilities of Kubernetes resource within VS Code itself. And IntelliSense is so smart that it can check the resource request or limits being set in the pod specifications. It's not just simple text-based IntelliSense. It also analyzing your resources, and it will suggest you with the help of tooltip that, hey, this might supersedes the limits. So these two extensions are one of my favorite extensions, and they help me personally a lot while writing production-ready Kubernetes-based distributed applications. All right, let's switching the gears a little bit. Every application use some sort of storage, right? Definitely, it can be NoSQL, it can be relational, it can be graph-based database. Obviously, there are ways you can have stateless and stateful containers, but you need to be very mindful about choosing the right storage type when you are planning your Kubernetes workloads. Okay, so the first thing is you should clearly understand the needs of your application to pick the right storage. You can use high performance SSD backed storage for production workloads, which Microsoft offers. And you can also plan for network based storage when you need multiple concurrent connections. And applications often require different type of speeds of storage. And you need to determine which specific storage is serving your purpose by asking these questions on the screen. Do your application need storage that connects to individual pods? Does your application need storage shared across multiple pods? Or is the storage for read-only access, or you also need write access? Will the storage be used to write large amount of structured data, or semi-structured data, or completely unstructured data? These questions actually help you to choose right type of storage with respect to Kubernetes-based workloads. Next thing is create and use classes to define application needs. So let's say each node supports a maximum number of disks, but that maximum number is a defined number, it's not unlimited. And different node sizes also provides different amount of local storage and network bandwidth. So you need to plan appropriately for your application demands to deploy the right size of nodes. Uh, if uh, if your application, let's say, require Azure disk as your storage solution, then strategize an appropriate node VM size makes much more sense. Storage capabilities, CPU, memory, these three things plays a major role, a vital role when you need to decide the VM size, which will work as a node in your Kubernetes workloads. Okay. Next thing is dynamically provision volumes. This is very important to reduce management overhead at later stage of time. Right? You should enable scaling, and you should avoid statically create and assign persistent volumes. You can create persistent volumes if you are already aware about something like persistent volume claim (PVC). You can do that, but in order to reduce overhead at later stage, just enable scaling and use dynamic provisioning in your storage classes in your manifests. Just define the appropriate reclaim policies to minimize unneeded storage cost once pods are deleted, right? You should be able to figure out a way to reclaim those storages which were earlier in use. A persistent volume claim, also called as PVC, it lets you dynamically create storage as needed. Underlying Azure disks are created as pod request them. So Azure actually takes care of it, and Azure takes care of it using Kubernetes master plane. Next thing is secure and backup your data. If you are, I think security is vital, especially in these days. You should have a clear-cut strategy to back up your data using an appropriate tool for your storage type, such as a famous one is Valero, or you can also use Azure Backup, which is a offering by Azure. All you need to do is, after backup, you need to verify the integrity and security of those backups. When your applications stores and consume data persisted on disks for you, you need to take regular backups, and you can schedule them. And either take regular backups or just take snapshots, right? Similar things. Basically, Azure Disk can use built-in snapshot technology. So you just need to configure them. And it will be taken care by Azure. Your application may need to flush write to disk before you perform the snapshot operation. All right. Next shade or the next recipe is create a storage migration plan. Why on the earth I need to create a storage migration plan, that too with respect to Kubernetes-based workloads or Azure Kubernetes workload? Let's say if you use Azure storage, just prepare and test how to migrate your storage from the primary regions to the backup region if need be, right? In future, your application might use Azure storage for their data. Okay, if so, your applications are spread across multiple AKS clusters in different regions. In one in Australian region, one in Indian region, one probably in European region or US region. You need to keep the storage synchronized, right? And there are two common ways to replicate the storage. One is infrastructure based asynchronous replication, and another is application based asynchronous replication. Either your infrastructure will take care of that replication of data across multiple geographies, or your application should take care of that. Choose one of them depending upon your use case. Okay. All right. Now again switching the gear a little bit with respect to scalability. You are, let's say, working in a startup. It just started from garage, and your idea went viral like anything. If you started your workloads through Kubernetes, or to be specific, Azure Kubernetes service, taking care of scalability is no longer an issue at all. I'll tell you a few tips how, with the help of, let's say, cluster autoscaler, horizontal pod autoscaler, you can achieve scaling easily, very easily. So the first thing is autoscale your AKS pods, Kubernetes pods using application gateway metrics, right? So as incoming traffic increases, it becomes crucial to scale up application based on the demands. You can use application gateways, this metrics, average request count per healthy host and average request count. I think I wrote it twice. The same thing. One is average request count per healthy host, and a similar one is a different. Through this, through these metrics, you will be able to gather information with the help of app gateway, and through that Kubernetes master plane will decide how scaling should work, right? There are a few other things which we'll see in this slide itself in next few minutes, which will actually take care of scaling, which is horizontal autoscaler and cluster autoscaler. So let's see them one by one. Using the new metrics to scale up deployment. So let's say once we can expose app gateway request count metric, which is highlighted in yellow, this is the name of the exact metric, and through this metric server we can use horizontal pod autoscaler. Horizontal pod autoscaler utilize this metric to scale up our target deployment. For example, we can easily scale up to we can scale up pods whenever this metrics value goes, let's say, more than 200 per pod, or probably to a max of 10 pods. Those type of things we can define. Next thing is exploring pod autoscaling lead time. What is this and why we should worry about it? Let's understand. So the time it takes to create a new pod on a new node is determined by three or four factors. Four factors basically. The first is horizontal pod autoscaler reaction time. Second is cluster autoscaler reaction time, node provisioning time, and pod creation time. So you need to be little bit ahead of time to take care of these four variables in picture while figuring out how much time actually your application will take to scale, because how much time horizontal pod autoscaler will take, then how much time cluster autoscaler will take, how much time node provisioning will take. Let's say currently you are serving your application to, let's say, 10,000 users, and you are using 3 nodes in your Kubernetes cluster. Now 3 nodes are full. You cannot provision additional pods in these existing pods. Then Kubernetes will provision a new node, and provisioning a new node will itself take some time. If, let's say, there is already a node, then provisioning a new pod in that already available node will be considerably of lesser time. So you need to be thoughtful about these things as well. Okay, next thing is choosing the optimal instance size. This is a matter of debate upon depending upon a lot of factors. How to choose optimal instance size for a Kubernetes node. You may be tempted to assume that the more nodes you can add to your cluster, better it will be. But that's not the case all the time. Right? In some cases, some nodes are more likely to remain available than others. So if some of the microservices are deployed on a specific nodes and where your specific microservices are not getting enough load, then they'll quickly die. Their replica sets will be reduced to the minimum number which you have configured in your YAML files. A physical server sitting in your local data center or with no backup, let's say if you are not using Azure Kubernetes Survey, is a very less reliable measure or less reliable node than a virtual machine sitting in a cloud, and in this case, let's say Azure cloud. Thus, node count is not an exact measure of cluster availability. Let's say you are having a cluster with 5 nodes in Azure, and you are having cluster with maybe more than 5 nodes in on-premise. Then availability of nodes in cloud are always better than your on-premise data center or your on-premise servers or the servers you have placed in your garage because you just started working on a viral idea. Right? So reliability with respect to your cloud provider is always much higher, and you have to take care in the equation when you think about scaling. Okay. Next thing is right sizing your Kubernetes cluster, the entire cluster. So how you find a sweet spot? How do you make sure that you have enough nodes, but not too many? Too many nodes will make a dent on your pocket, right? And a good mix of physical and virtual machine is right. I'm just asking. It may be, maybe not, but we'll understand this but with the help of few questions. If let's say you want to say that I'll be having few nodes in on-premise, few nodes in cloud, then you have to think about these questions. How reliable is your physical infrastructure? How many resources does each node have? How many master node do you want to have? And how many workload does your cluster host? These kind of things will serve the answer to the question, what should be the right size of your Kubernetes cluster? Basically, in a summary of scalability, there is a complex mix of factors at play, ranging from what type of infrastructure is hosting your nodes to how many master nodes you want to set up, and what's the ratio of physical to virtual nodes you want to have in your Kubernetes cluster. Defining and implementing a successful scaling strategy in Kubernetes requires you to master several subjects actually. One is how to allocate resources in Kubernetes nodes, how to fine tune refresh intervals for a metric server, horizontal pod autoscaler or a cluster autoscaler, how to architect cluster and node instance sizes, what should be the right size, depending upon the application workload or depending upon that particular microservice. Container image caching, right? Application benchmarking and profiling. If is your application too much memory hungry or is it too much CPU intensive? That is also needs to be taken care into consideration. And with the help of proper monitoring tool, this becomes little bit easier and you can easily figure out the right size. But yes, you have to take care of, you have to get answers of some of the questions which I just asked. And just we'll cover in monitoring section how monitoring tool will make your life much more easier with respect to figuring out the right size of your Kubernetes cluster. Okay. Networking, a very important topic, and Kubernetes provides two types of networking: Azure CNI networking and Kubernetes networking. If let's say you use Azure CNI, which is Container Network Interface, based networking in AKS, Azure Community Service, then this network model allows greater separation of resources and controls in an enterprise environment. Let's say you are building a B2B applications where multiple companies are your clients. They have something in their own virtual network. You have something in your VNet. In rarest of the rare case, you may want to peer those VNets. Then Azure CNI will be much better approach in those scenarios, according to me. But based upon scenario to scenario, whether to choose Azure CNI or Kubernetes networking, this may little bit differ. We will see this as well in this category. All right. So we'll start with distribute ingress traffic. Uh, why one should distribute an ingress traffic? Let's say you want to distribute HTTP or HTTPS based traffic on your application, and you use some ingress resource and controllers. Compared to an Azure load balancer, ingress controller provide uh, extra features, and they can be managed as native Kubernetes resource. While an Azure load balancer can distribute customer traffic to applications in your AKS cluster, it's limited in understanding that traffic. A load balancer resource works at layer 4 and it distributes traffic based on the protocol or ports. So a right combination of load balancer and the traffic manager will serve the purpose. Okay. Next thing is securing traffic with a web application firewall. Uh, to scan incoming traffic for potential attacks, to avoid DDoS attacks, use a web application firewall, such as a good example is Barracuda Web for Azure or Azure Application Gateway itself. These more advanced network resources can also route traffic beyond just HTTP and HTTPS connections, or probably basic TLS termination, or what we call as HTTPS offloading or TLS offloading. Typically, an ingress controller is a Kubernetes resource in your AKS, Azure Kubernetes cluster, that distributes traffic to services and applications. Uh, the controller runs as a daemon on AKS node, and it consumes some of the node's resource like CPU, memory, little bit of network bandwidth, and this serves the purpose of web application firewall. Okay, next thing is how you will control traffic flow with network policies. Can you define network policies? If let's say you are part of, like me, if let's say you are part of a platform team of your company where other developers of your company need not to worry about a lot of network policies, you are just defining those network policies, and multiple teams which are your clients, they need to adhere with those network policies. So you can have a generalized network policies, or you can have a team specific, workload specific network policy as well. So just use network policies to basically allow or deny traffic to pods. By default, all traffic is allowed between pods and a cluster. For improved security, define rules that limit pod communication. And network policy is a Kubernetes feature which is available in AKS that can let you control the traffic flow between pods. Multiple pods can have multiple microservices. So if let's say one microservice or one pod got compromised, at least you should be able to safeguard remaining of the pods. So by default, each pod should not be able to communicate with rest of the pods, and this you can very easily control through network policy. You should allow or deny traffic to the pods based on the settings such as labels, namespaces, traffic pod. You can say that, hey, all the pods inside this namespace should have this network policy, or all the pods having this type of labels should have this specific network policies. Applying network policies is fairly easy. And you can reap its benefits later by reduced overhead cost. You need not to manage those things at all the time, right? If a right network policy is in place. Next thing is do you, if let's say you are a developer, there are some people of those belongs to testing team in your team, some belongs to DevOps, some belongs to SRE skill set. Should all of them have access to your Kubernetes cluster, your nodes? Obviously, no. If no, then how will take care of debugging, troubleshooting an issue? There is then again the old concept of jump box, which nowadays you can call it as Bastion or Bastion as a service. So do not expose. I should not be able to talk to my production ready in my prod environment or my stage environment, those Kubernetes cluster by this laptop, right? I should connect my laptop to a jump box, and jump box should have access, or you can say just-in-time access to those real Kubernetes workloads, which meant to be safeguarded by any intruder attack or these type of attacks. That's why Jumpbox or Bastion as a service serves this purpose. Just do not expose remote connectivity to your AKS nodes. Just simply create Bastion host, which is nothing, just a jump box, and in a managed virtual network, use the Bastion host to securely route traffic into your AKS cluster to remote management tasks. Let's say you want to clean up something, or you want to see why your pod is stuck in a crash loop state, right? Why it is always crashing. Those kind of things you can easily figure out. First, try to figure out through the monitoring, Grafana, Prometheus, or Azure Monitor, whatever monitoring tool you have used to set up. If you still not able to figure out, then only just never log into Kubernetes cluster or those nodes through your main laptop. From your machine, log into Jumpbox, and from Jumpbox, log into Kubernetes cluster. Uh, in order to connect to those nodes and provide maintenance work or support work, just simply route your connection through Bastion, which is also called as Jumpbox. You need to verify at any given point of time that the host should live in a separate, securely peered virtual network to the AKS cluster virtual network. So VNet of Bastion, which is Jumpbox as a service, and the VNet of your Kubernetes cluster can be paired, but they should be separate. Your Bastion should not be in the same VNet in which your Kubernetes cluster is running. So that also needs to be taken care of. This is also some of the good guidelines practice which we take care of. All right. So we reached till 20th shade or 20th recipe, and we have covered almost half of the time. So I need to little bit speed up. Next category is security. So you need to regularly update to the latest version of Kubernetes to basically to stay current on new features or bug fixes. Just simply regularly upgrade your Kubernetes version to the latest stable AKS cluster, right? Whenever a new update is available. So basically, Kubernetes updates include new features and bug or security fixes. So you should not have policy like that. No, I will only upgrade once in a quarter. So if a bug fix or a security patch comes little early, then you should upgrade it without any doubt. Okay. Uh, Next thing is secure access to the API server or the cluster nodes. How we can do this? One of the most important ways to secure your cluster is to secure access to the Kubernetes API server. Uh, the same API server which we connect through kubectl, right? To control access to API server, just simply integrates Kubernetes RBAC with Azure Active Directory. If you are running your Kubernetes cluster in Azure, simply just leverage the offerings of Azure AD, Azure Active Directory. With these controls, you can simply secure AKS the same way you secure access to your any other resources in your Azure subscriptions. Okay. Next thing is secure container access to resources. Let's say in any ideal world, you should limit access to actions that containers can perform, provide the least number of permissions, which is, and this concept is true in a lot of other sense as well, not just with respect to Kubernetes. Provide the least number of permissions and avoid the use of root access, right, or privileged escalations. In the same way, you should grant users or groups the minimum privileges required. You should also limit containers to only necessary actions and processes which are very much required to do a specific task, and just revoke the root access by default. Okay. There is something called as app armor. What is this? Basically, to limit container actions, you can use app armor. It's a Linux kernel security module. App armor is available as part of underlying AKS node OS, and it is by default enabled. You just need to use it. You create an app armor profile, and that restricts read access, write access, execute access, or system functions like mounting file system. Those things can easily be controlled with the help of app armor. You just need to use it, right? It's by default enabled. Next thing is, and the last in this category of security is use Kubernetes role-based access control, which we also call as RBAC, right? While AppArmor works on any Linux application, there's something called a seccomp, which I highlighted in yellow, which is nothing, just secure computing, seccomp. It works at the process level, not at the resource level. Seccomp is also a Linux kernel security module, and it is natively supported by Docker runtime used by Azure Kubernetes nodes. So with seccomp, you can limit container process calls, right? So seccomp will also available in order to secure your Kubernetes-based workloads. All right, so this was related to security. Each of these categories, which I discussed earlier as well, and I'll be discussing in future, I have tried to group 5 recipes or guidelines in these categories, and we have 10 categories, and each one of them have 5 recipes or 5 shades to do justice with the title of this talk. All right, the next category is governance. We are some specific team in a big enterprise are dedicated for the governance work. That okay, this team will take care of the governance of Kubernetes-based workloads, non-Kubernetes-based workloads. What are the best security guidelines? What are the things they should worry about? What are the things they should take into consideration in order to secure their workloads? So what should be the right way of doing governance if you are doing if you are using Kubernetes based workloads or containers based workloads? Okay, so here in the governance category we'll see some aspects of Azure Kubernetes service security governance to think about before implementing any solution, right? So okay, let's start with the first one, which is build security. How to build security? Build security is about the proper use of DevSecOps with container images. Poor image configuration can lead to security vulnerabilities down the pipeline. Just use your golden images, hardened images. For example, having containers, those are built running with greater privileges than the needed ones, are a strong contender for having a intruder-based attacks at a later point of time. Rogue containers. Have you heard about this term? Rogue containers. Rogue containers are those containers which are unplanned containers in any environment, and they can be the result of developers doing some testing. Developers are testing their code in a test environment, and these containers might not have gone through vigorous security scans for vulnerabilities. They may become rogue at a later point of time. These vulnerabilities might open an entry of point for attackers. So we consider generally these type of containers which a developer forget to remove as a rogue container, okay, which they spin up just for doing some testing. These containers are basically considered as a rogue container. And our security guidelines should take care of these containers. Registry security, having stale images that might have vulnerable out of date versions, let's say uh, using any out of life support. Let's say the latest version is .NET Core 5 and .NET Core, I guess 3.1 is also still support, but still if let's say you are using .NET Core 2.2 based Docker image, then you are vulnerable. And companies do that effort to migrate their workloads to any supported image. So registry security is about drift control from build, prevention of push-pull of contaminated images, and image scanning. There are tools like Aqua. Through those tools, you can take care of scanning your images or any possible vulnerability in your images. Next thing is cluster security. Cluster security is about authentication and authorization. It's about network security as well, and figuring out the vulnerabilities and taking care of proper compliance management with respect to your cluster and entire cluster. Then it comes the node security. Node security is about runtime protection, vulnerability and compliance management, but you should restrict node access by limiting SSH access to any given node, right? And in the last, it comes the application security. Application security is about runtime protection again, and vulnerability and compliance management. It is also applicable in case of application security. Never store, let's say, secrets in application code or file system, right? Secrets should be stored in keywords like Azure keyword, HashiCorp vault, and they should be provided to the containers at runtime as and when needed, whenever needed. So these type of practices should be taken care while taking care of application security. Azure Community Service can ensure that only containers that need access to a certain keys connection string, they can request with the help of provisioning Azure keyword. You should provision Azure keyword, and you should establish the connection between Azure keyword and your pods, and your pods should be able to access them in a more secure way. It's also simple to ensure that these secrets are encrypted both in storage and in transit. So encryption at rest and encryption in transit, that also needs to be taken care of. Okay. So next category, operators. Operators are also one of my favorite topic. These operators gives a good control over Kubernetes-based workloads. What is basically an operator basically in a robotics world or in an automation world, there is something called as control loop, right? As you can see in the image, it's basically a non-terminating loop that regulates the state of system. How Kubernetes is using it, that is very interesting. So in Kubernetes, controllers are called as control loops, and they keep an eye on your cluster and then make a request regarding the changes as and when needed. So each controller tries to move the current cluster state close to the desired state. So matching the desired state and the current state, this will be taken care by a control loop or a controller. Desired state and current state, let's say you want 5 replicas and there are 3, then your controller immediately will ensure that there should be five replicas. Kubernetes take a cloud native view of systems, and it can handle constant change. Your cluster should be changing at any point as work happens, and control loop automatically fix failures. This means your cluster can never reaches a stable state if the controller for your clusters are running and able to make useful changes, which let's say, what should be the right example? Let's say one pod is stuck in a loop state. It is crashing and crashing. So this controller loop will always be busy because a container pod is crashing, then it is starting, then it is crashing, then it is starting. So you should be keep an eye if any such thing is happening. So if a right monitoring is in place, then you can very easily, at a very early stage, you can figure out if pod is stuck in a crashback loop state. All right. The next thing is how you can leverage the operator framework for automation. Simply just extend it. There's a full framework, and couple of days back I was reading there is a .NET based fork of a framework. I'm forgetting the name, but there is a .NET based framework as well, not just the standard Golang based operator framework. There is something called as ASO, Azure Service Operator, and it helps you provision Azure resources and it connects your application to those resources from within the Kubernetes. If you want to use Azure resources but would prefer to manage those resources using Kubernetes tooling and primitive, simply use kubectl apply. And behind the scenes, it is actually using Azure Service Operator, ASO. Then Azure Service Operator will serve the right purpose for you. Okay, what should be the example of operators? What should be the most famous operators, right? RBAC manager operator, MongoDB operator built by MongoDB team, HPA Kubernetes operator, site manager operator. There is a company, there's a product called as Argo CD that is also having their own dedicated operator. Istio operator, which I guess some of you might have used. A etcd operator to take care of etcd based key value pair database, Elastic Cloud based operator, and Grafana based operator. So there are some of the most common operators which you might or might not have used in your journey of Kubernetes based workloads. Okay. All right. The next category is updates. You need to update nodes. You need to update your application. You need to update your Kubernetes cluster, the main master plane. And there are varieties of ways and guidelines why, how you should update these specific things. In any AKS cluster to be specific, your nodes run as an Azure virtual machine, right? This we all are aware. And these Linux-based virtual machines use a Ubuntu image. And with the OS configured to automatically check for updates, I guess, every night. If security or kernel updates are available, then they are automatically downloaded and installed. You need not to worry about it, right? That's why you are using cloud. And this will be the headache, not of you, but of your cloud provider, which in this case, Azure. And Azure takes care of this thing. Uh, what if we think about node image upgrade? Let's say some unattended upgrades apply and to Linux node, but the image used it creates some unchanged or rightly say as unexpected changes. If a new Linux node is added to your cluster, then the original image is used to create that node. This new node will receive all the security and kernel updates which will be available at that time. Or what you can do alternatively you can use node image upgrade to check for and update node images used by your cluster. So either you keep an eye what security patches, upgrades, feature changes are available, or otherwise your cloud provider can also take care of it. Okay. Node upgrades. There is an additional process in AKS which lets you upgrade a cluster. An upgrade is typically to move to a newer version of, let's say, from 1.18 to 1.19. Not just it applies node security updates, and AKS upgrade performs the basically four actions which are very important. A new node is deployed with the latest security updates and Kubernetes version applied. A old node is cordoned and drained. Pods are scheduled on the new node, and the old node finally gets deleted, and you will no longer be charged for that finally deleted node. Okay. There is a great tool called as Cured, Kured. you can use this tool to deploy the cured demo set, and you can install the official cured Helm chart, and it will take care of upgrades as well. This creates a role and a cluster role, basically bindings, as a service account, and then it deploys the demo set using cured. Some security updates, such as kernel updates, require a node reboot, which you can't do, right? Then this, with the help of cured, it takes care of rebooting the nodes automatically without taking your application down. Um, Next thing is update cluster node. How you can update a cluster node? By default, Linux nodes in AKS checks for updates every evening or every night. And if you don't want to wait, you can manually perform an update to check whether curl is running correctly or not. First, you need to make SSH, but making an SSH connection to your AKS node is not at all recommended. You should avoid it. And if, let's say, it is not at all a production workload, it is not at all your stage environment, it is just a test or a dev environment, then simply you can run the sudo apt-get update or sudo apt-get upgrade command the way you run on your Linux desktop or Linux laptop. Same thing you can run, and you can update your nodes there manually all by yourself. Last thing, monitor and review reboot process. When one of the replicas in the demo sets has detected that a node reboot is required, then a lock is placed on that node through the Kubernetes API. This locks, what it does, it actually prevents additional pods being scheduled to this node. If this node, Kubernetes just decided that, hey, let me delete this node, or let me reboot this node, then, right? Then ideally no new pod should be scheduled on this node, right? So this can be achieved using mechanism called as locking. And you can monitor the status of nodes very easily by the simple command kubectl cat nodes, and you can see the status of all the nodes. Okay. All right, this is done. The second last category of our talk is cost efficiency. We should do this, but everything comes with a cost. What all things you should keep in mind in order to reduce the cost of your containerized workloads? Basically, use Kubernetes horizontal pod autoscaler or even cluster autoscaler to just scale, do the right scaling at the right time. There is something called as spot node or spot VMs, if you are aware of, which also help you in saving some of the cost. What is a spot node? Basically, a spot node pool is a node pool which is backed by a spot virtual machine skill sets. Using spot VMs for nodes for your Kubernetes cluster, it simply takes advantage of any unutilized capacity in Azure at a significant I think discounted cost. The amount of available unutilized capacity will vary depending upon various factors, including node size, region where you want to figuring out a spot instance, and a specific time of the day. When you deploy a spot node pool, Azure will allocate all the spot nodes if there is capacity available, but there is no SLA for the spot nodes, right? So just be aware of it. Best cases use dev environment, test environment where you need not to have any SLA. Then spot nodes can save a lot of money for you. Okay. Next thing is you can use this scale down mode. It's a switch which is useful to deallocate nodes when they are getting scaled down, right? So you will not be having unutilized nodes, and for which you have to charge. Nodes need to be immediately deallocated via this scale down switch, so that you need not to pay for those nodes. Okay? And you also need to worry about deleting previously deallocated nodes. If, let's say, nodes gets deallocated and they are not deleted, right? So to delete your deallocated node, there is again a switch, and it is called scale down mode, and this will delete any deallocated node from the cluster. So basically, changing your scale down mode from deallocated to delete, then back to deallocated, it will delete all deallocated nodes from time to time basis. And next thing is using a scale down mode to delete nodes on whenever a scale down is happening. Right? These things look similar, but they are not actually. The default behavior of Kubernetes cluster is that without using a scale down mode, it it's going to delete your nodes, right? When you scale down your cluster, right, from let's say 5 nodes to 4 nodes, from 10 nodes to 8 nodes, just use scale down mode, scale hyphen down mode, and this can be explicitly achieved by setting hyphen hyphen scale hyphen down hyphen mode space delete, and through this you will be able to save your cost. The final thing with respect to cost efficiency, configure multiple nodes and enable scale to 0. Uh, let's say Azure Kubernetes service allows you to create different node pools to match specific workloads to the nodes running in each node pool, and the process of matching workloads to those nodes enables you to plan, to commute consumption and optimize cost. So you lose the ability to scale the node count to 0 whenever you enable the cluster autoscaler on a node pool. So this is also something which you need to be aware about, that as soon as you enable the autoscaler on node pool, you lose the ability to scale the node count to 0. Okay. Next, final category, and we have 4 minutes left, and we have monitoring. So this category suggests that at what levels you should implement monitoring. The level 1 is cluster level components. So at all, the cluster view gives you a very quick view of the performance of the nodes in your Kubernetes cluster, including your CPU count, memory utilization, those things. Second is managed AKS components. So let's say API server, kubelet. You can use metrics explorer in Azure Monitor, and you can do the in-flight request counter. And through this, you can figure out whether everything seems okay or not. Next is Kubernetes objects and workloads like deployments, Kubernetes pods, Kubernetes containers. You can have your monitor set up on these resources as well. Fourth thing is your applications, the actual applications which you are building. Simply monitor microservice application deployments to identify are there any failures or any latency issues. It includes information such as request state, response times, and exceptions you have seen in your applications. So application insights is also another PaaS offering, and it provides complete monitoring of your application running on AKS and other non-AKS environments, in fact. Both AKS and non-AKS, both application through application insights, you can monitor your applications in both containerized and non-containerized based applications. And the final thing is some external components like service mesh, ingress, egress, databases, and queues. You should also monitor components like your service mesh basically, and you can do this with the help of Prometheus and Grafana or any other proprietary tool. You should also monitor your databases and other Azure resources using other features of Azure Monitor itself. Okay, so these were the 50 recipes, 50 shades of running a containerized workloads, and categorized into 10 categories. I hope you enjoyed this session, this talk, and we have covered a lot in previous 60 minutes. Feel free to ask questions, share your feedback. I will be making these slides available on this website acecloud.com in some time, and you can ask questions right now, or you can tweet me. This is my Twitter handle. Thanks a lot. Thank you very much. And a big thanks to the organizers of this conference.
Hi Abhishek.
Hi,
Thanks
Abhishek.
for the great session.
For a great session.
It was very informative and exhaustive. Like almost everything that was possible within 60 minutes you have quoted. It was very informative. People who want to ask any questions, you can reach out to Abhishek on his social media. Since we, in the interest of time, let's complete the session now. As of now, there are no questions.
Okay.
If you want to ask questions, you can reach out to Abhishek on YouTube comments or on his social media channels. Thanks, Abhishek. Thanks for the great session.
Thank you.
Hi, Shakti. Can you hear me? Hello.
Yeah, I can hear you, Shri Bharat.
Hi, everyone. Welcome to the session.
Yeah,
The session is going to be on orchestration via Terraform. Terraform,
right.
as we all know, is very hot on the market. Thanks for joining in, Shakti. The stage is yours. You can take it over.
Sure, thank you. Are we live now?
Yes, you can start. I'm just
Okay,
adding your content. You can start.
right. And I just started sharing the screen. So,
Yes, your content is live, Shakti. You can start. Shakti, your content was live. I think you've removed it. Probably you can add it again.
okay, how about now?
Um, uh, yes, your slides are visible now. Yes.
Okay, thank you very much. Thank you, Shri. And yep. Hello, everyone. And since this is a one way, I'm just going to keep discussing my slide decks and then we'll see if there are any comments coming up. Okay, and for today, I just made this small agenda, like very small and simple agenda to discuss about the Terraform orchestration, end-to-end orchestration. So some background about me. I'm a Microsoft Azure MVP for the past 5 years, and I run two communities in Singapore. I'm based out of Singapore, and the Azure Data Office is about 7,000 users, and Microsoft AI community is about 2,300 users. So we have a large user interaction, and this is one of the biggest groups in Singapore. Apart from that, I got certifications from Microsoft as an Azure solutions architect and a security engineer. And day to day, I use Azure in a day to day basis for various clients of ours. And I run my own consulting company based out of Singapore called Consult Systems. And you can reach out to me in Twitter at Saktish. So having said that, my journey originally started as a infrastructure engineer about 16, 17 years ago, 18 years ago. So most of my journey is about an infrastructure engineer building up the networks, servers, commissioning, all those things. And then last 6, 7 years, the cloud has been the way of life and the way of moving forward. So this presentation is mainly from an infra engineer who transformed into an cloud solution architect, and from mostly my learnings and mostly my from my day-to-day work and my projects, I'm trying to share my experiences. So primarily, if you look at the way that infrastructure engineers will be doing is, the biggest program that they wrote is the AutoXE.bat, like the batch file for scripting automation when a server or a laptop boots up. And that's the biggest, few years ago, about 10 years ago, probably, that would be the biggest script that you wrote. And in today's world, it become like it's exactly opposite of it, and you should need to know more of a Terraform and more of a orchestration layer softwares so that the infra orchestration happens in an automatic way. So, so let's dive into this. Having set this context, my learnings are my primary sharing in this session. I'm going to the next slide. So essentially, this is a pep talk. If any of the DevOps engineers are already listening, probably this is going to be a known factor. So what happens with the Azure DevOps? I primarily did not do any other DevOps, but being in Microsoft MVP and other things, Azure DevOps is the most advanced DevOps platform that is available. So everything I'm discussing here is going to be confined with DevOps. So when I started looking at DevOps, the DevOps became more of a okay, there are boards. Oh, okay, the boards are primarily used for tracking, and then the pipelines are the pipelines. So you have two type of pipelines, primarily the build pipeline and then a deployment pipeline. We will talk about that a little later in the one. And Azure repos, as you are already aware, the repos or GitHub is the popular example, but Azure has its own. Azure DevOps can work with the GitHub or GitLab or any other repo provider. Okay, and the test plans are some of the test plans that the testing folks can take advantage of. And artifacts are something like an npm package or some other packages that you can actually store it in inside the DevOps, where it don't need to be included in all the modules. It can just be pointed out. So the code becomes leaner. The code structure or the code capacity becomes leaner when you use the artifacts commonly. So that is a little bit of introduction about DevOps and Terraform. We'll go to the Terraform next. Why it is important is because anyone who is going to do an infrastructure orchestration is going to be working with these two parameters, these two platforms primarily. So you must know something about the DevOps, in a way how DevOps is going to work. And then you have to have knowledge of Terraforms so that you can do an orchestration in automatic way. So let me touch base a bit of Terraform basics. So Terraform is a declarative language that you can do. It's very powerful and you can do quite a lot of things using Terraform. And mainly main.tf is one of the files that you will do all the layers of declaration or all the parameters that you want to specify. So essentially, Terraform maintains a state for the subscription for your cloud subscription, and any update you make using the Terraform code, it updates the Terraform state. You must know Terraform state is the key thing for orchestration and the upgrade of the infrastructure or change to the infrastructure. The TF state is the single most important thing that you need to understand. So whenever there is a change made by Terraform in any of the cloud, the Terraform state is updated. So it is essential to capture that state and save it somewhere. We will see how we capture that and save it in the next slides, in the next few slides. So coming back to essentially the init and plan and apply, destroy are the four functionalities that are mainly used for orchestration capabilities into any of the cloud. As you already know, Terraform supports AWS or Azure or GCP. We probably more focusing towards Azure, Terraform and Azure in our scenario. So essentially, you should know, I want to emphasize again that essentially you should know the DevOps. Azure DevOps or some other DevOps also is possible, but a DevOps platform plus Terraform is a must for you to understand how you can do an orchestration. Having said that, I will move to what we call it as end-to-end orchestration. So in recent times, what we evolved was, I evolved at least, was part of the infrastructure will be done using Terraform, and the remaining will be using the Azure portal.azure.com UI. So from there, as of today, the evolving part is that you can completely do the orchestration from end to end, involving every single part of the design that you have without touching the GUI. So that gives you the flexibility to actually sit and plan your whole infrastructure and then do a coding based on that particular design and model. And then you can make use of Azure DevOps and Terraform language to deploy it in a much more manageable way. Like, you can do it in minutes. The deployment takes, it's very fast, and it's the most efficient way to do cloud orchestration today. So I'll walk you through a small use case of, for example, we want to do a 3-tier architecture, essentially web tier, app tier, and database tier. So imagine that we are trying to deploy it today, and the planning process starts with something like your diagram, like how my servers are going to be sitting up, or how my compartments or the subnets are going to be there. So essentially, this is a diagram which we are going to use it for our rest of the session. So you look at it. If you're going to have a web tier, app tier, and DB tier, very simple, flat. We haven't used many of the proper functionalities. For example, I avoided using an application gateway, which is the most essential thing for you to put in the DB layer to secure your web. So we didn't use the proper, we didn't go in a full-blown mode for the purpose of simplicity and easy understanding. We're just using the 3-tier architecture in the bare minimum way. So once we do, I would essentially advise you to create an Excel sheet, like something like this, where you actually can do a planning part, which essentially says, okay, what are your production? What is your production, and what is your subnet? And in a way that you even assign IP addresses to your nodes, and all those planning essentially will be done in a simple Excel sheet like this. So why you need to do this is because one of the advantages Terraform gives is the ability to parameterize all these things. You don't need to code all of these parameters. So today you want to change the size of a virtual machine, right? After you deploy, it's much easier if you do a parameterization. You just need to go and change a particular parameter to just scale up the server or scale down the server or change the configuration and so on. So essentially, this toolkit will help you to form your Terraform files, and based on that, these parameters, you will build your Terraform codes also. Okay. Having said that, this imagine that we have this two apps, web apps, and then two SQL node in front of LB. Okay. So if you look at the IP addresses, we already assign certain IP addresses, and then you look at the name db_subnet and app_subnet. All those are the names that you're going to deploy, and we're going to use those things as a parameter in the next subsequent ones. So essentially, we created this package, and now we are ready for the deployment of your Terraform scripts. Okay. So before going to Terraform scripts, I want you to understand that this particular diagram shows what exactly happens at the DevOps layer. Okay, so you typically write your code, and then you commit the code and push it to the repository, where the Azure repo gets that code update and actually and builds and triggers the build pipeline. The build pipeline, you essentially configure the repo to work with the build pipeline, and then the build pipeline will actually create and give you an Terraform deployable packages. Once you get the Terraform deployable packages, it can be pushed into a release pipeline, where the release pipeline is the one which actually go and deploy the devices for the resources in the cloud. So essentially, you imagine the way that step one, you do code. Step two, you push the code to your repos. The repo will be associated, must be associated with the build pipeline, where the build happens, and then Terraform deployable package comes out. From there, you push her to a release pipeline, and then your resources getting deployed in the Azure platform or in the whichever platform is specified in the pipeline, in the release pipeline. So what happens after the deployment is that you must capture the deployment, successful deployment or failure deployment, and do one state update into the Terraform. So the state is actually maintained in the Terraform itself. For various practical purposes, security reasons and everything, I would recommend use the repo, not any storages for the state, because the storage has to be secured, etc., etc. But by default, Terraform repo is one of the most secure available option for you today. So essentially, this is the crux of how your code getting into the deployed as a resource in the cloud platform, right? So after this, I'll move to the next one. So you can create your DevOps structure based on your requirements also. For example, you may have more than one environment, and you can actually have individual environments built in the DevOps structure, so that any changes that you make in the code is affecting only one environment, or you have a control on where it is getting deployed. So for example, we have here the three environments here. Typically a production, typically UAT or dev and dev. So these are the three environments you will have. And if you have a granular build pipeline and then release pipeline in this way, you can always have an individual capability to individually control the orchestration in each layers. For example, I want to just upgrade my server only in production. So you don't need to do a whole chunk of code to do in the build pipeline if you have individual pipelines associated with the environment. And to an extent, your pipeline, even not just for the environment, even you can build it down into your security layer also. For example, what I mean by security layer is, for example, in one of the projects, we have pipelines specifically for VNets alone. And then there is a specifically one for NSG, and then specifically one for the DB, and specifically one for the app layer and one for the web layer. Why we do this is because if tomorrow there is a new NSG rule that you need to implement, you don't need to touch any other pipelines except the NSG only. So so that your changes are so minimal, and you're much more efficient in the way of orchestrating your infrastructure. So the errors are a lot of errors can be avoided much easier. Right? That is the reason you can go to that granular level. So typically, at least you need to have at the environment level. One of the we talked about the parameters earlier. So if you remember my earlier diagram, the diagram has a database with two nodes. So typically, what we will we want to do is that in the variables, you can specify the parameters in a way that you can control what is the username, what is the password. These are the parameters that is needed for VM to be deployed. There are bare minimum. There are others, but this is the bare minimum that we need to take care. Say, for example, one of the things I want to highlight is the DB node zone 1. So you build a cluster in a infrastructure as a service. It's always better to have the node sitting on it, the different zones, availability zones in the Azure platform. So node 2 will be on the zone 2. So it gives you avoids the single point of failure and gives you a higher availability, right? So the parameterization is so powerful that you can actually change, IP addresses. You can change, the preferences of the node size. For example, this typical node size is a D2 V3. You can actually go in and edit this particular parameter to say D4 V3 or D4 VS D4S V3. The build pipeline will pick up the change, and then it will deploy only the update that is supposed to be happening through this pipeline. So that is the key. That's the advantage we're talking about for the parameterization. The other point is, one of the main things you must be aware of is that you need certain kind of rights to do this orchestration, and then the preferred way is then create an SPN, and then the SPN should be the service principal that can have the control on the deployment, and you will go into the DevOps project settings, and from service connections you actually do the configuration in a way that the SPN is in place, and then the pipelines will use the service connection to do the deployment. So that's one of the main things that you should be aware of. And after this, we come to the main.tf, which is the key file that we already discussed. And on your left side, if you look at it, there's a initial declaration where we specify the version, new version required, or the version of the Terraform provider that must be handled, because each version has a different set of cores and code snippets or modules available. So typically, on the main, you will define your deployment resource deployments. So if you look at the top of the on the right side, the black screen, this defines the database node LB, what it should be as the name, the subnet ID, and then the private IP address, and then the type is static. So if you look at it, you don't specify anything here, because we started parameterizing everything outside of Terraform script. So if you look at a little bit down, you will see that the virtual machine for one of the nodes is being already set as what is the computer value. The computer value is actually tied to the parameter. The username password is tied to the parameter. Zone is also tied to the parameter. So it's easier to control this way, rather than you don't need to change any of the scripts. When we do the parameterization, that gives you the flexibility to focus on efficiently writing the Terraform scripts. Right. So this is another screen that I want to show or explain. Remember, we had the 4 stages, plan and any plan destroy. So one of the scenarios that you actually come here is when during the planning phase, Azure DevOps has a very nice UI to show you what is happening in there. So essentially, when you go and click on the Terraform plan, you can see what is happening, what is being, what changes are going to be done. It's a very elaborative screen. You can see every single change that is being happening there. And the most important thing, if you look at the black strip downstairs, you will see that 0 to add, 1 to change, and 0 to destroy. So the destroy is the one you should be really careful about, because if there is any count, you must really make sure that whatever is destroying is what your intended result that you want to do. Once you do, once the plan is completed, before apply, we actually you can do an wait gate, like you gives you before deploying, it gives DevOps gives you an option to introduce the manual introversion, which means that until you go, if you go and approve, it will never apply. The Terraform scripts, even though it is ready for a deployment, it will never apply until you go and approve the wait gate. So it gives you the flexibility to go and check back your plans. Okay, everything is fine, and then you go and do a manual approval, and you know for sure that the application, the apply is not going to destroy any of your deployments. So that's a very useful tool. We always use this for the production environments. So coming back to this same screen that we already highlighted, the code changes you do, as an infra engineer, you will do the code changes, and you will make this Terraform scripts, which will be pushed to the repo, and then there's a build pipeline which will create the Terraform deployable scripts, and then that will be pushed into the release, and so on. So the very recent one, we managed to implement this without touching any of the GUI. Is a very big, complex environment involving quite a lot of code systems with 40 plus virtual machines and multiple web apps and storage, Azure Key Vault, everything in one package. So even the next generation firewall clusters, which don't belong to, which are not provided by Microsoft, but by third parties into the Azure marketplace, you can use Terraform to do a deployment from them all, from the Azure marketplace also, based on the licensing that is available in the market, and it will tie to your subscription costing and so on. So that brings my last slide, and I'm not sure if there is anyone who can say that there's any questions, anything. Shay, are you available?
Hi, Shakti. Thanks for a great session. There's one question. I'll pop it up.
Sure.
What is the extra thing that Terraform can do, which ARM, Bicep, or PowerShell cannot do?
Okay. So the Terraform is much more granular than the ARM. ARM template is a lot of cumbersome to maintain, and to do the state management and so on. And even I will answer it in a little bit different way. Whoever is asking the question, you should actually look into Bicep also. ARM Bicep. Oh yeah, it's not just ARM. It's a Bicep. Yeah, Bicep is the one we are moving towards. Actually, our projects also are moving towards Biceps, and Bicep, and we are not looking at Terraform at this point of time. So Bicep is a lot more powerful, but it's still nascent and it's native. I am sure that my next project will be on Bicep only, not on Terraform.
Thanks for the answer, Shakti.
Yeah.
I hope it answers your question, Amar. Let's wait for a few minutes, a few seconds.
Sure.
I don't think there's any questions as of now.
No.
People, if you have any questions, you can post it on the YouTube chat. This time we can take it. We can take more questions.
Yeah.
Okay, Shakti, I don't
All right.
see any more questions.
Thank you.
Thanks for the session. It was very informative.
Thank you. Thank you for hosting, Sri, and thanks to the organizers to organize this event successfully. Thank you.
Thank you so much. Hi, Dennis. Can you hear me? Hello? Dennis, can you hear me? You're on mute, Dennis. Can you please unmute yourself? Dennis, you're on mute, Dennis. Can you unmute yourself? Can you talk now? I think you. No, you just unmuted yourself, but you didn't talk. Can you
Hello?
talk now? Yes, all good now.
Oh, good.
All good. All good now. Thanks for joining. Hello, everyone. Good morning, good afternoon, good evening, wherever you're joining from the world. The next session is going to be by Dennis. Hello.
Hello.
Yes,
Good
better
afternoon,
now.
everyone.
Just a second. The next session is going to be by Dennis. It is on securing your applications to Azure SQL. Please provide the feedback for the session on the chat window. URL will be shared. Please provide your session feedback on the chat window, and you can post all your questions to Dennis on the chat window. We'll take it up at the end. Thanks. The stage is all yours, Dennis. You can take it further.
Thank you. So, good afternoon. My name is Dennis Torres. I'll talk about cloud security, how to secure access from your applications to Azure SQL. I'm sorry in advance for any problem with my voice. I'm recovering from a strong flu, but let's move ahead and hope everything goes well. This is me. You can see my contacts on the screen. This will be a session full of demos very fast, but it will be a pleasure to keep in touch. If I miss any question during the session, please send me the questions on my social networks by mail, any means you would like. So, we'll talk about some security problems and how these security problems affect our applications and how to solve these security problems. Let's go directly to demonstrations. So, I have here a set of Azure functions and two SQL Server database that we will access during this session. Azure Conf demo and Azure Summit demo. Let's start with this Azure Summit demo. I will access it from my SSMS. Azure Summit demo. And I use SQL Server authentication. Let's do it in the basic way. It's usual. It's the first time I'm accessing this database from my machine. So SSMS makes me a favor of noticing that my IP is not open in the firewall and giving me the option to open my IP in the firewall of the Azure Summit database. And that's what I'm doing. I'm including my IP on the file of this database. It's working now, but if I go to the firewall, probably my IP is not here yet. And when I click OK, my IP will appear there and I'm connected to the server. So the firewall controls who can access the server. Is like a security front door for the Azure SQL. That's great. let's make a small refresh here and take a look on the IP that is already configured here. Thank you to SSMS, that is very nice to help us make this configuration, but I could do directly the configuration on the portal, of course. But let's go to our first function. Our first function makes access to that database. This is our first function, cloud security demo. Cloud security demo. And on the configurations of this first function, here on configuration, I have the connection string to that database. Everything appears fine, but I can already show you the problem this have. Let's take a look on the connection string, and the connection string contains my user ID and password. That's a terrible practice. But okay, let's test the function first. ADV works. Get function URL. And I open here a new window and test cloud security function 1. See, it provides me a list of products on Adventure Works. So I'm seeing all the products in the Adventure Works database. That's what the function is doing. So that's an interesting point. Many developers would be satisfied that the function works. The function is deployed, is a serverless function, serverless development, and the function works and returns the result. Many developers would be satisfied with that. However, this function has a huge problem. The connection string is located in the configurations of the function itself, and it contains my password, my username and password. How can we manage this scenario? First, let's visualize this scenario. This is scenario that we have now. We can from the internet call the function, and the function is calling the Azure SQL database. That's it. What's happening? And I can from internet call the Azure SQL database. That's what I did here from my SSMS to manage the server. Okay, that scenario that we have. Now, let's start fixing this problem, fixing this scenario. What we need to fix this scenario? We need an Azure feature, an Azure object called key vault. The first thing that we need to do is to move that connection string to the key vault. That connection string is a secret. Let's keep secret inside key vault. So key vaults can contain keys, secrets, and certificates. In our situation, we are using a secret, a connection string. So I have a secret here. Yes, I have many secrets. We'll study them later. But the first one is com string. I have this secret, and that's the secret that I will be using, com string. But my function needs permission to access this secret. How do I control the permission of my function to access this secret inside another feature of Azure, which is the key vault? Well, let's move ahead. I'm not working anymore with function 1. Let's work with function 2, solving this problem. The first point, identity. The function needs to become an identity in face of Azure Active Directory. The function becomes like a user in face of Azure Active Directory. I'm using system assigned identity. It means the system created the user for me. If I would like to use user assigned identity, I create the user, I could as well. That's possible. But I'm using a system assigned identity. Okay, what this allows me to do? Let's move a bit ahead, and here, sorry, let me locate the correct window. I have the uh, Azure Active Directory, and as I have a set of groups inside my Active Directory. Okay, my function has an identity. I could start giving permission directly to the identity of my function, but it's not a good practice. Let's group identities and give permissions to groups so I can add and remove identities from these groups to define the permissions these identities will have. For example, I have here a group called Adventure Works Reading. This group contains identities that at some moment will read Adventure Works. Cloud Security Demo 2 is here. See, the identity created by the system access principal is the name of my function. So my function become an identity that can receive a permission inside Azure environment. So my function receives a permission inside the Azure environment. Let's go back to the key vault. Key vault here. And here on key vault, I can take a look on access policies. In the access policies of the key vault, we see that I gave permission to Adventure Works Reading to access the secrets of the key vault. Without these access policies in the key vault, my function would not be able to access the connection string located in the key vault. It would not be possible to my function to access the connection string. Okay, but one most interesting part is that the access to the connection string, the authentication to access the connection string, is being made by using Azure Active Directory identities. So Azure identify my function as an identity and gives permission to access the key vault. That's great. So an identity exchange. And here on my function, let's go to functions. Get function URL. Okay. And I can test my Azure Security Cloud Security Function 2, and I see absolutely the same result. That's what expected. The difference is that now our function is reading the connection string from the key vault and not from the function itself. Let's take a look about these connection strings. and how the function reads the connection string from the key vault. The first connection string that I'm using is a connection string that has my ID and password. That's a bad connection string. But now I'm saving this connection string on the key vault. It means that in the function configuration, I'm uh, not storing the connection string anymore. The connection string is safe in the key vault. In the function configuration, I'm storing a reference to the key vault. Let's get back to the function. Take a look on configurations on my function 2. And now on constrings, see, my function now is making a reference to the key vault to read the connection string from the key vault, making the connection string way safer. Besides many other features that you can achieve with that, you can achieve a point where the developer doesn't know the production connection string by manipulating these configurations. Okay, great. Let's see an image of the second scenario. The second scenario, I have a web making calls to the function, but now the function make a call to the key vault to get the key. The function needs to authenticate to Azure Active Directory, and the key vault checks the authentication with Azure Active Directory to deliver the key to the function. The function has a managed identity. And finally, when the function has the identity, it makes the access to Azure SQL. That's our second scenario. And it's become safer. It's become safer, but it's far from good. You may remember that when I connected to this Azure SQL, Azure Summit demo, I used SQL Server Authentication. Doesn't mind the amount of security involved on SQL Server Authentication. It will not be the same as an Azure Active Directory authentication. So the perfect solution here is to activate Azure Active Directory authentication in my Azure SQL. How we do that? How do we activate Azure Active Directory authentication on our Azure SQL? Simple. We have on Azure SQL an item here called Azure Active Directory. Azure Active Directory. And here it's in fact already activated. The authentication, the possibility to authenticate with Azure Active Directory is created when I define an admin to the server. An Active Directory admin to the server. And I define the group SQL admins as an Active Directory admin to the server. If I would like so, I could force a bit more and support only Active Directory authentication. Reject any authentication that is not coming from Active Directory. That's an option. But I'm not doing this now at the moment. Let's take a look on the Active Directory groups. ADV works reading. Let's take a look on other groups. I have here the SQL admins group, the administrators group on the Azure SQL. Okay. It means that I can disconnect here and connect using Active Directory Authentication, Universal MFA. So I just input my login, which is my email, and SQL Server will delegate to Azure Active Directory the authentication process. It didn't ask my password because I had made a test before. SSMS still had my token valid, so it went directly without asking my password. Just because before the session I made a test with that. So I'm authenticated with Azure Active Directory. Okay. So am I giving to my function administration permission? No. I have many users here as SQL admins, but my function is not here. My function is on AdventureWorks reading, which is another group. Is not the administrator of the database. So, how my function will access the database? Simple. I created my function. I created the group where my function is AdventureWorks reading as a user in the Azure SQL. So this group became a user in Azure SQL. How I did that? Simple. It's not difficult to do. We just create user from external provider and included the user in the DB data reader role. Just that. And now this user has reading permissions on AdventureWorks. Okay, that's great. That's great. But I can't continue using the same connection string. The connection string needs to change. Yes, the connection string needs to change. And this is the new connection string that we'll be using for our third function. Mind the authentication part of the connection string. Active Directory Manage Authentication. It's interesting to note that in on-premise environment, we have two kinds of authentications. I'm sorry. In on-premise environment, we have two kinds of authentications. Standard authentication or integrated authentication. Only these two kinds of authentication. But when we deal with Azure Active Directory, we have many kinds of authentication. For example, this one is using the managed identity of the process making the authentication, in this case, the function. I have here a page explaining all these kinds of Active Directory authentication using SQL Client. Many situations that I would like to use different kinds of authentication with different kinds of identities to authenticate to Azure SQL. So here I'm using the manage identity. Well, we are talking now about a third function. We already used Cloud Demo 2. I skipped some numbers sorry for that, I skipped some numbers and went directly to Cloud Demo 6. And on configuration of Cloud Demo 6, we have here the connection string reading a different connection string com string ID integrated 6. That is a connection string making an integrated authentication with Azure SQL. Again, we have the identity enable, system assigned identity enable. Let's get the function, get function URL. And again, I have my list of products. It continues working in the same way it was working before. What changed? The security of the environment. What changed was the security of the environment. Now I have a third scenario where my function checks Active Directory not only to access key vault, but also to access Azure SQL. So first function, second function, third function. My function checks the Active Directory not only for the key vault, but also to make the access to Azure SQL. Okay. We made examples with Azure functions until now. Let's make one example with a virtual machine. I have a virtual machine here using SSMS. This virtual machine is inside Azure, inside own its own virtual network. I have a virtual network especially for this virtual machine. Okay, so I'll try to access my Azure Summit demo. Database engine, Azure Summit demo. We already know it allows me to use integrated authentication. Here is the first time I'm using integrated authentication, so it's asking for my login. That's not exactly what I was expecting. Let's take a look on the IP of this machine, 20107. Oh yes, of course. This is happening. This is happening because the Azure Summit demo is committing a mortal sin. This database is committing a mortal sin. On the first view, you will notice, oh, the IP of the virtual machine is not here. The virtual machine is not open on the file. Yes, it's not open on the file. But this database, this server is committing a mortal sin. allow Azure services and resources to access the server. This is a mortal security thing. Why? Many developers, many people will confuse this option with saying, oh, it's just to allow my service to access the server. No, that's what the developer wants to think. But the option is clear. Allow Azure services and resources to access this server. It's about any Azure service. Even if another person in another Azure subscription create a virtual machine or create an Azure service, these yes settings here will allow that guy to bypass the firewall security. Of course, there are other levels of security in SQL Server, but the firewall security will be bypassed. The firewall security will be bypassed. Let's make a different test to illustrate this better. So instead of using the Azure Summit, I use the AZ Conf demo. Let me double check the configuration that I did here. Yes, SQL admin, so I can authenticate with Active Directory. And mind what's happening here. It's asking for a firewall permission for this virtual machine. This virtual machine is inside Azure. The Azure SQL is inside Azure. We would like the communication between the virtual machine and the Azure SQL to happen inside Azure. But the fact that it's asking me a firewall permission, it's a clue that that's not what will happen. The communication will not happen inside Azure. The communication will use the public internet to make the communication. So, even when everything appears to be correct, it's not. Things may be bad underneath, because if a virtual machine inside Azure uses the public internet to communicate to an Azure SQL, I have a security problem. I have a security problem. How do we solve this problem? Let's go to our virtual network. I have the virtual network. I know the name of the virtual network. Cloud Security Net. Okay, we know the name. And here on azconf demo on firewall, instead of opening the file for an IP, I can open the file for a virtual network. VNet rule. And what virtual network? Let's choose the Cloud Security Net. So I can open the file for this virtual network. The virtual machine is on subnet 1. And mind this, ignore missing SQL service endpoint. I'm not checking this box. It will not ignore that. Because there is a need to configure the virtual network to access this Azure SQL. Okay, let's wait some moments and it will work. Uh, Meanwhile, I can check on CFC endpoints, and the Azure SQL is included here. It's updating. That's why I received an error there. Once it's okay and not updating, I'll be able to proceed on the other screen. Succeed. The CFC endpoint creates a directly route between the virtual network and the Azure SQL. So here on Azure SQL, I click OK to add the virtual network on the firewalls. And that's it. So I have a virtual network rule here. So this Azure SQL will allow the connection of this virtual network. So I can try again from the virtual machine, and it went directly. No questions asked because my authentication was checked, is valid, and the virtual network is open to access Azure SQL. And now that this happened directly with the permission of the virtual network, now we know the packages are running inside Azure and not from the public internet. Sorry. Uh, do you notice that your application can be working and can have terrible security flaws? Exactly because small details like these ones. So now, this AZConf demo is accessible inside this virtual network. Let's take a look on another security function, Cloud Security Demo 7. This one, I have a special configuration here, which is a network integration configuration for outbound traffic. It means that it will use the configuration of a virtual network for the outbound traffic. Which virtual network? Cloud Security Net. So this configuration made on the Azure function will ensure that the communication between the Azure function and the Azure SQL will happen inside the Azure environment without crossing the public internet. Let's see some images to illustrate what I'm talking about. First, included a virtual machine here, and the virtual machine is connecting to Azure SQL through a SaaS link. This virtual machine is making the connection to Azure SQL through the SaaS link. Sorry, this slide is garbage. This is the correct slide. So the virtual machine is connecting to Azure SQL through a SaaS link. Suppose that I were not using the SaaS link, and especially in the case of my functions, what's happening? What do I think is happening? I think I'm calling a function, and my function is going to Azure SQL, and everything is good. But what is truly happening? I'm calling my function, and my function is calling Azure SQL through a public address. And since it's a public address, it uses internet routing to reach Azure SQL when it could use Azure routing to reach Azure SQL. And this is a security flaw. This is a security problem. And how do we solve this security problem? By including my function is now the function 7 inside the virtual network. The outbound connection of this function is configured to happen inside the virtual network. So it's configured to happen using the virtual network integration. The function has an identity as expected. Let me double check the configuration of the function. I'm using comString as the configuration of the function, and it's reading the comString integrated 7, although the value ends up being it's not the same because now I'm connecting to a different server. Now I'm connecting to the AZ conf demo and not to the Azure Summit. Now I'm connecting to the AZ conf demo. So let's take a look on this function 7. Get function URL. I'm sorry, this was unexpected. Oh yeah, let me take a look here. Let me show why it's happening. Why it's happening. Where is my function? My function. ADV works, Cloud Security Demo 7, network configuration, networking. And when I make the VNet integration with Cloud Security Net, this integration forced me to create a subnet inside my virtual network. So I created a subnet especially for my function, a subnet called functionnet. And if I go to the database, the virtual network that I'm allowing here is the subnet 1. It's not the functionnet, it's the subnet 1, the subnet of the virtual machine, subnet 1, not the functionnet. So I need to add a new permission now to the cloud security net and the function net. Okay, and enable. Okay, So now I'm allowing two virtual networks, two subnets, not virtual networks, two subnets to access this Azure SQL Server, the functionnet and the subnet 1. Now let's try again. And that's it. That's it. My function is accessing the Azure SQL directly from inside the Azure environment using a SASE endpoint. Let's take a look on another image now. First, the virtual machine using accessing through SASE link, and now the function making access through a SASE link. The virtual machine through SASE endpoint, and the function for through a SASE endpoint. Just fixing the slide. So my function is like part of the virtual network and is accessing the Azure SQL through this SASE endpoint. So all the access to this Azure SQL is happening through this SASE endpoint from inside the virtual network. Why I don't put Azure SQL directly inside the virtual network and that's it? Let's do that. Let's do that. Let's put our Azure SQL directly inside the virtual network. How we do that? Creating what's called a private endpoint. A private endpoint is a bit more complex than a SASE endpoint because a private endpoint deals with DNS configuration. But this allows me to put one SASE that in other ways would be public directly inside a virtual network. Name of my private endpoint is the confidemo private region North Europe. North Europe. Next, resource. It's a bit strange the screen to create a private endpoint because the resource should already be known. I started from Azure SQL. But anyway, it asks me the resource and I need to point to Azure SQL. Microsoft SQL Server. What SQL Server I'm creating this private endpoint to? Azure Conf Demo. So I'm creating private endpoint to Azure Conf Demo. Target SQL Server. On which virtual network I would like to put this private endpoint? I will include this private endpoint on my cloud security net. It can be subnet 1, doesn't mind. The name resolution will happen on the entire network, on the entire virtual network. Okay, resource group. Let's put the private endpoint on the resource group Cloud Security Central Demo. Next text, review and create. Create. So it's deploying a private endpoint inside my virtual network. Let's wait just some moments for the private endpoint to be totally created. It takes some moments. As I said, the private endpoint is related to a DNS configuration. So it's creating a DNS zone and a link with the virtual network. We can take a look on the slide of the private endpoint. The only thing that changed is the object being used to access this Azure SQL. Now I'm accessing this Azure SQL through a private endpoint. But since I'm using a private endpoint, this brings some new possibilities. Let's navigate a bit and discover what was created. I can see the private endpoint created here. The private endpoint receives a network interface because the private endpoint needs an IP. It's like I'm creating an IP. I create a point of presence for my Azure SQL inside the virtual network. I'm creating an IP inside the virtual network. So a network interface was created. Now let's take a look on the virtual network. On the virtual network, I can take a look on the private endpoint. Here, private endpoint created inside the virtual network. The fact is on the subnet one doesn't mind, is not a problem at all, because inside the virtual network the name resolution is automatically done by Azure. So this is not a problem at all. Let me take a look here on security demo. I think it was missing one object. Yes, it was missing one object. Here, the private endpoint DNS zone. This guy is responsible to redirect the calls from this to this Azure SQL by using a private connection to this Azure SQL. But we did all this. We had all this work for what? We changed one object for another. What do we get from this? What do we get from this? Central security demo. Let's go to our AZConf demo. From the moment that I have a private network, from the moment that I have that private network, the option to deny public network access becomes enabled. so I can completely block the public access to my Azure SQL. Why in hell would I leave my Azure SQL with a public endpoint? And the firewall will not be used. The firewall will not be used. I can remove these two network configurations. The network configurations, they are used for SASE endpoints, but not for private endpoints. I can remove them. So I can remove the two network endpoints. And they can completely deny public access to this Azure SQL. What this means, deny public access to Azure SQL? This means that I'm creating an even deeper blocking on that Azure SQL. This means that if I try to access that Azure SQL,
Hi, Dennis. Sorry to interrupt. You
yes,
have
4 minutes, right?
yes, yes.
Yes,
Thank you.
okay, I'm finishing. I'm finishing.
Thanks.
So if I try to access that Azure SQL, it advises me the public access is denied. I can't access the Azure SQL from a public environment. I can only access that Azure SQL from inside the virtual network where I created the private endpoint. So the access to my Azure SQL is extremely limited. Extremely limited. And my Cloud Security Demo 7 function is inside that network. It's configured to be inside that network. So if I make a refresh, it still works. It still access that Azure SQL, but now using a private endpoint that if I get to SSMS to access that Azure SQL, I can't. I need. How do I manage that Azure SQL? I would need to use a jump machine. Using a jump machine inside the virtual network would be a way to manage that Azure SQL. Or I could use a VPN gateway. A VPN gateway connected to the virtual network, and then I would manage that Azure SQL. But the point is, our database would in no way be exposed with a public endpoint to the internet. So, what the security problems that we solved? What the solutions that we apply to our security problems? We used Key Vault. We used Manage Identity. I skipped one detail about database file rules because we had no time for that. We used SAFS link. We integrated the SAFS on the virtual network using SAFS link and using private endpoints. So we started from an application that was already working and that most developers would be satisfied with an application that is working. It's enough for the developer, but it's not enough for a security purpose. For a security purpose, the database should not even have a public endpoint. The authentication should be using Active Directory, and you can use Manage Identity, use Key Vault for the keys, and so on. So we started
Hi,
from
hi,
uh,
Dennis. Sorry to
yes,
interrupt. We are
I'm
short on
finishing.
time.
I'm
If you don't
finishing.
mind, can you please go to your closing notes?
Yes. So as I was concluding, um, we used all these features to ensure that our Azure SQL will not be available to the public. It will be available only to our application, ensuring the security of our Azure SQL. And here my contacts again. Feel free to get in touch. It will be a pleasure to keep in touch. Feel free to connect and send any questions you would
Th-
like. Are
Thanks,
there
Dennis.
any
Thanks for the
questions?
session. Thanks for the session. In the interest of time, let's take the questions offline on YouTube private chat, YouTube chat. Thank you.
Okay, thank you.
Hi, Annie. Can you hear me?
Yes, I can hear you very well.
Thank you. Thanks for joining. Hello, everyone. The next session is going to be on our Kubernetes cost optimization, which we are all very eager to learn on. It is going to be by Annie Talosto. She is a Azure MVP and a Kubernetes specialist. She has worked on Microsoft Stack, and she is also an international conference speaker. Annie, the stage is all yours, so you can take it forward. And
Perfect.
please post your questions on the YouTube chat window, and there will be a feedback URL for the session, which will be shared. Please provide the session feedback on the URL. Thanks. Annie, the stage is all yours. You can take it.
Perfect. Thank you so much. Very excited to be here talking to you about AKS cost optimization. Very dear topic to my heart, as Kubernetes is in general. So super excited. But let's get to it. So AKS cost optimization, how to actually do it. So what are the best practices? What are the best ways to do it? So this is exactly what this talk is about. So what value do you get attending this talk? What are the kind of learning goals for this talk? It really is to learn different best practices for cost optimization, to understand what tooling you can use to do cost optimization. And I will also cover a bit about how cost in the cloud works as well. So this is kind of like a 1 hour, I guess, zero to hero cost optimization session for everyone interested in Kubernetes and particularly AKS cost optimization. Then, who am I? Thank you for the brief intro in the beginning. Very lovely. Just a bit elaborate on that further. So I'm Annie. Nice to meet you all through this virtual lens, as you do in conferences nowadays. And I am a product marketing manager at Cast AI, which is a Kubernetes cost optimization company. So I do this quite a lot. Love the topic as well. And then I'm also a CNCF ambassador as well as an Azure MVP. So I do a lot of public speaking on these topics as well, both from Kubernetes as well as from Azure angles as well. So I am also a Kubernetes and CNCF meetup co-organizer for over 4 years now. And then I'm also startup coach. So I coach early stage startups, as well as I co-host the Cloud Gossip podcast that you can find at cloudgossip.net. So very happy to be here talking to you today. So you might be wondering, well, I don't know, maybe if you're attending this session, the question, probably is in your mind, and you probably have arrived to the conclusion that yes, it matters. But I think cost optimization itself isn't maybe always as prevalent or hasn't been in the top of mind of practitioners for as long as, let's say, performance optimization has been. So why does cost optimization matter? Well, I think historically, particularly, you know, well, first of all, on a very kind of personal and a company level, I think everyone has been usually in a situation where they've received a surprisingly large cloud bill. Not fun. So then this might be a personal push for you to, to try to lower your cloud bill because it's wise for the financials. But I think in the big picture, really, I think, for example, back in the day when we, purchasing physical servers ahead of time, You had to kind of plan on how much capacity would you need in the future and over provision. And that was obviously de facto standard for sure, and even nowadays in some places, of course. But at the same time, when now we are using AKS, we're using Kubernetes, we're using the cloud in general, we actually have quite a better of a flexibility that we can do as far as scaling goes, for example. So we don't have to plan so much in ahead. We don't have to over provision anymore as much. We can actually tailor our kind of performance, our clusters, our VM amount to the amount that are actually needed. So we can actually start cost optimizing because it's no longer about only guaranteeing the uptime only as well. So this has been, I think, a big shift that has made possible for cost optimization to be really on top of mind for everyone. And I think in after that also cost optimization really usually brings a lot of other benefits as well. So if you cost optimize your Kubernetes clusters and your cloud, you usually end up in a situation as well where your performance gets better, which is always a bonus, which is a goal in itself. So it's kind of the cost optimization usually does not happen in a vacuum. You also usually gain better visibility and governance into and better DevOps practices to your organization, which also really improves on productivity as well as one thing that's very important. I think a lot of people, as well as, for example, for me personally, you also stop producing as much cloud waste. So you are being also good as far as your use of natural resources go. So that's always a nice, either a bonus or a goal in it itself, of course, for some people as well. So why is cost optimization then so complex if we have all of these benefits that can come with cost optimizing your cluster? Why does it then get so difficult to actually do it quite often? Or at least what I'm hearing usually from people. So here's a snapshot of actually from AWS pricing, but the same pricing applies to Azure and AKS and all of these things. So it really is, there's a lot of details, so many different VM types, so many different pricing models and everything. It gets quite difficult to actually navigate through your cloud bill and understand, how does it work? So it can get kind of tricky. And as far as Kubernetes goes, really truly understanding also how many machines or, nodes do you need and what size should they be? How many pods, containers do you need? How big they should be? So, and obviously you cannot just kind of set up a one optimal environment and then, move on. You have to actually keep on working on it. So it's not during deployment. The application requires change as well because different amount of users are using it, every specs change and whatnot. So no wonder it's rather hard actually to approach it. And as far as Kubernetes goes, it's actually rather cost inefficient out of the box. So half of the Kubernetes applications utilize less than 30% of the CPU resources available. And this is actually not a survey. This is actually a look into from Datadog from 2020 report by them. Look into how things are utilized. So it is actually less than 30% of the CPU is used. Resources are used. So that really tells you that, okay, de facto, out of the box experience doesn't really optimize for any of these things that are benefits that I talked to you about. Obviously, you can use that and there is some benefits, but if you want to take it a step further, you really have to start thinking about these things. Really, in general, over provisioning and all of these things lead to quite a lot of cloud waste as well. So how does cloud pricing then work? This is not like a comprehensive guide because it's a quick guide because this is more about cost optimization on the other hand. But then there usually are a few types of ways the cloud pricing works for AKS in Azure, and also they are very similar in other cloud providers as well. So you have on-demand instances, you have reserved instances, and you have spot VMs in Azure, and then you have dedicated host options as well. So the on-demand instance is kind of like how we've get to know cloud as is. So it's the pay-as-you-go model. You only pay for the resources that you actually use. So, for example, you might be billed on the hour, you might be billed on the minute and whatnot, and you face no long-term binding contracts or upfront payments, and you're not overcommitting to any budgets. And you get to increase or reduce your usage just, in time whenever you want to. And then, but on the other hand, on-demand instances are actually rather extensive. So, overrunning your budget is a real risk here. So the most flexible on-demand instances work great for unpredictable workflows that experience fluctuating traffic spikes. And otherwise, there are other alternatives that you can do, and you can use it. But as I said, it's not the most cost-optimal solution at the same time. So you have reserved instances, and they're called saving plans, for example, in AWS. On the other hand, so on here, this is something you can buy capacity upfront and give availability zone or for a really low price when compared to the on-demand instances. So you're kind of planning your usage up ahead, so you get savings on that. But then at the same time, it's usually a long-term commitment, so you have to be committed for the long term. And what if your needs change, either scaling up or scaling down and whatnot? Within obviously you can scale up and down within your clusters, but for that time allocated, you might have more needs or less needs, and then it's obviously a bit trickier if you're in a kind of booked plan. So you are really committed to one thing as well there. And then spot instances, they are a very, very cost-effective pricing model, or the spot VMs. So you bid resources that the cloud providers aren't using at the moment, and you get up to even 90% off from the demand on-demand pricing. But it really comes with a limited availability, so a lot of people shy away from using them. So for example, Azure and Google Cloud give you a 30-second warning before you're switched to give you a plug. So it really needs kind of it's really amazing if you know what you're doing. You can either use tooling to manage this, or you can do a lot of the things, kind of set up things manually. But at the same time, it is trickier, but it is very cheap than if you are using them. I will go into detail a bit about how to manage spots later on. And then dedicated hosts are a physical server with an instance capacity that is exclusive for you. And these are usually used by if you have to have really important and really specific governance requirements and hardware requirements and these kind of things. So they're commonly used, but I will not be focusing too much on that in this session, more on the ATS and the cloud side as well in general. So then a quick look into how to forecast cloud cost at the same time then. So obviously it starts from analyzing your usage reports. So understanding first, you need to have clear visibility of your cloud expenses. So you have to have a capability to monitor the resources usage that you're having, and you can have email alerts, whatnot alerts, all of these things in place, because before you want to start optimizing, you really have to start also understanding how does your cloud bill look like, and what should it look like in the future as well. You can also model your cloud expenses. So you can try to calculate total cost of ownership of your cloud resources. You can analyze pricing models and plan capacity requirements over time. So you really kind of take it to a next level and try to think about, okay, what will it look like in the future as well. So then you have the detect peak resource usage scenarios, which means that you can use periodic analytics and run reports of your usage data to identify these scenarios. So you can use other data sources, for example, seasonal customer demand patterns. Okay, if you're running a Christmas, or like if you're running a Halloween shop or a Christmas shop, you will probably have a seasonality there that increases the demand there during those peak times and whatnot, as far as also during the time of the day and everything like these goes. So this is kind of a quick intro to, this is how cloud pricing works, how to forecast cloud cost, and then we're going to go through a bit of best practices to use, and then I'm going to introduce some tooling that you can use to actually do these things in a really smart way, which is the how to actually do it then part of this session. And really, here is if you start looking into this and researching these topics, there's so many different options that you can really start doing. It is actually even kind of crazy how many things you can do. A lot of times, some of these things might be a bit, you can, goal setting is important. So it might be like, okay, that's a bit of a no-brainer. But at the same time, if you really want to be successful in your cloud cost optimization journey, in your ATS cost optimization journey, it's really important to understand what do you want to do, what do you need to do, and what are your goals that you're having. And you can obviously use a lot of different, very inbuilt services from Azure as well to set up policies, to set up good alerts, and use these kind of things, set budget limitations, all of these things, and you can get to a certain good point as well already by that. But when you want to go deeper, I will talk you through like how to use Spot instances, how to use a lot of different other things, and then also like if you go from there, you can start using multi-cloud to get to the which cloud has the cheapest options and whatnot. But this session will obviously be focused on AKS. So best practices there, as well as you can use obviously a lot of tooling as well. But yeah, there's a lot of options, can get a bit confusing at first. But then if you start diving deeper, you will notice that there are things that you can try out already. So just to get to the easier part of this. So I have 8 best practices for cost optimization in AKS. So this is going to be 8 great ones that you can start using immediately already, or then we can wait until the tooling part of the session to find out, okay, what tooling can help you with these best practices as well. So you have to first start by defining your requirements. So you should only order what your workload needs across all the compute dimensions. So CPU count and architecture, memory, storage, network. And an affordable instance might look really tempting, but what happens if you start running a memory-intensive application and end up with the performance issues affecting your brand and your customers? Not really great. So you can pay attention when you choosing between CPU and GPU instances, dense instances. So if you're developing a machine learning application, for example, you probably need a GPU dense instance type because training models is much faster on that as well. So you really have to think about this, and this goes to the goal setting and to the kind of forecasting part as well. Then the second one is choose the right instance types. So, and there is a gazillion of types of instances that you can actually choose from. So it can get quite overwhelming sometimes. So really, there's no denying that compute resources are the biggest line item on your bill. So picking the right VM instance types can save you quite a lot on your bill already. So cloud providers offer many types of instance types, matching a wide range of use cases with entirely different combinations of CPU, memory, storage, and networking capacity as well. And every type comes in 1 or more sizes, and you can scale those resources easily as well. But you have to also know the cloud providers roll out different computers for their VMs, and the chips in those computers have different performance characteristics. So you might pick an instance type with a strong performance that you don't actually need. So you might end up with, kind of having too much power for your own good, which then becomes expensive, of course. So, and understanding and calculating all of this is hard because there's so many different VMs and instance types to choose from. So you can obviously benchmark this, but that takes a lot of time. But there are guides online that can show you the exact machine type and performance as well. So there is resources online on that. Then the third one is verify storage transfer limitations. So data storage is another cost optimization aspect that's really worth your time. And each application out there comes with the unique storage needs. So make sure that the VM that you pick has storage throughout what your workloads needs. So I also recommend avoiding expensive drive options like premium SSD unless you're planning to use them to the fullest as well. And then you should check if your workload is spot ready. I have like a 2 or 3 spot VM tips here, but we're gonna walk through them. So while checking these things, so since they are a great way to use spot VMs to do this, so you should think about it. How much time does your workload need to finish the job? Is it mission or time critical? Can it handle interruptions? Is it tightly coupled between instance nodes? And what tools are you going to use to move your workload when the cloud provider pulls the plug? So really valid questions that you really have to think about before you're determined is your workload spot ready or not. So then cherry pick your spot instances or VMs. So when choosing spot VMs, pick the slightly less popular instances because they're less likely to get interrupted. And once you pick a VM, check its frequency of interruption, so the rate at which the instance will claim capacity during the trailing month as well. So like knowledge is your best helper here. You can also use cloud services have, for example, Azure Advisor has some data on how should you be using the spot VMs and how to really take the best kind of advantage of them as far as these go. So native tooling really helps you here as well. It is sometimes avoided to use them for important workloads, but you can, if you are managing them very well, you should not run into any issues there. And then you should bid your price on the spot. So, once you find the right instance or the right VM, it's time to then set the maximum price that you are ready to pay for it. So it will only, run in the marketplace for that price. So set the maximum price to the one that equals the on-demand price. So you never actually end up paying too much at least. And you can use a lot of different tricks to try to get to snatch post-spot VMs as well. But as I said, Azure Advisor helps you here as well. And then this is something that's exclusively really great for Kubernetes, and it's a new thing as well. So using a mixed instance strategy. So a mixed instance strategy gets you the great availability and performance at a reasonable cost. So you basically pick different instance types, since some are cheaper and just good enough, but might not be suitable for high throughput, low latency workload. So depending on your workloads, you can often pick the cheapest machine and make it all work. Or you could have a smaller number of machines with higher specs. So this can really help you do it. So mixed instances do present some scaling challenges. So in a mixed instance scenario, each instance uses a different type of resource. So while you can scale up the instances on your auto scaling groups using CPU network utilization, you'll really get inconsistent metrics. But cluster autoscaler help you here by allowing you to mix instance types in node group. However, your instance must have the same capacity in terms of CPU and memory as well. And then last but not the least, make multiple regions work for you. So instances spanning across several availability zones increase your availability. So you should, make sure that you think about these, scope them, each one of them to a single cloud region, automate your deployments to take advantage of price fluctuations between regions as well. And then this was the 8 best practices that I was sharing in the beginning of the thing. And then now let's look into other tooling and other tips and tricks that you can use to do cost optimization, kind of take it to the next level from these kind of best practices as well. And to think about that, we have to actually think about, okay, so these are best practices that are publicly available, everyone could use them. So what's actually holding teams back from actually doing these things? What's holding them back from actually doing cost optimization in the optimal way as here? So state of FinOps 2021. So FinOps Foundation is a really great foundation that's under Linux Foundation that helps you, that's trying to understand and standardize the use of FinOps, cost optimization, all of these things. And this is, they do a great survey into how does the FinOps space, the cost optimization space look like at any given time in a year. And it really kind of dives deeper into there. But also, obviously, since it's a FinOps Foundation itself, and it's relatively new, actually, the people who replied to the survey are actually relatively not deep into the FinOps space necessarily, obviously, but at least they are aware of these things already. So keep that in mind when we are reading the stats as well. So what challenges do FinOps teams face in general, according to the survey, the report? 39% say getting engineers to take action. So that's actually an organizational, that's a team mechanic as well, not a technical challenge. That's the biggest challenge there. 33% dealing with shared cost. Again, a bit more to the team dynamic as well. 36, accurate forecasting. Well, this is a thing that can truly help with technical solutions as well. And 24, reducing waste or unused resources. So this goes to, kind of how to get these things actually optimized really well. And then what tools do FinOps practitioners use? So they are really experiencing culture change needs, but then what tools they actually use? 26%, for example, use native tooling, 4% third-party vendor platforms, and then 32% use spreadsheets. So actually, I think it's very interesting that we have a situation where one of the biggest challenges that are facing these teams as far as like when trying to go into cost optimization is the cultural change, the action change, but then at the same time, the teams and the companies are not quite often using very complicated tooling, so they're using spreadsheets, for example. And nearly half the respondents say that they have little to no automation. So I would imagine that if there would be automation, if there would be really simple and easy to use services to manage your cost optimization, I think it would be easier to take action as well, rather than if it's a complicated setup and whatnot. So I think this is something that really, that's why I really want to also talk through a lot of tooling options, because this is clearly, and FinOps Foundation actually says it themselves, the situation is that more tooling and kind of automation tooling particularly is needed more, because that's when you can kind of take it to the next level and get started on the deeper meaning of these things. So then let's kick it off with the tooling recommendations, and I will have a demos as well on these tooling options as well. So you have CNCF, which is the Cloud Native Computing Foundation, which is the foundation that's actually home to Kubernetes and a lot of other cool projects. So as Prometheus, all of these things, and they have a lot of good solutions that are perfectly fit for Kubernetes as well. They're all open source solutions and all very nice and really good communities around them. So here are a few solutions that I highly recommend you to think about while you're thinking about cost optimization for Kubernetes and AKS. Because one of the best parts about AKS compared to, for example, ACI is that you can actually use all of these open source tooling. So unlike other Azure Kubernetes services, you can actually use these things and take full advantage of the community around Kubernetes and cloud native communities as well. So we have event-driven autoscaling and Kata, application management Helm, monitoring with Prometheus, container workflow with Flux, and then I highly recommend using Service Mesh as well. So you can use Linkerd and Kumar CNCF project as well as Mesher, and Mesher is actually service mesh management. So if you end up in a situation where we have more than one service mesh running in your cluster, then Mesher is a great option for that. So, and I think in here, event-driven autoscaling really helps obviously with kind of meeting the demand, so you don't need to over-provision, you're scaling and downscaling whenever needed, and so forth. So then now let's take a bit of a closer look at the CNCF projects, and I will give some commercial vendor solutions in the end as well that you can utilize. But a bit of a closer look at Kata first. So then, what is Kata, if you might be wondering? Well, I said event-driven autoscaling, but how does it look like then closer? So default Kubernetes scaling is not really well suited for event-driven applications, and Kubernetes is more for resource-based scaling, so CPU and memory. But Kata is event-driven scale controlling that can run inside any Kubernetes cluster, so it can monitor the rate of the events to preemptively act before CPU is affected. And you can install it into new or existing clusters, and it has extensible and pluggable scalers to grab metrics from multiple sources. And so this is truly where, you know, a lot of the power lies, because if you are auto-scaling to the need, you are not using the resources when you don't need them, aka you are not wasting any cost either. So this is truly really nice for that. So what are the Kata principles then? Is to not rebuild anything that Kubernetes offers out of the box. It's single purpose, simple and non-intrusive, and it works with any container and any workload. Then I have a quick Kata demo here in the middle as well, which is scaling .NET Core Worker with Azure Service Bus. And in here you can also see how the kind of demo, the Kata demo, thank you so much to the Kata team, by the way, for building it. The Kata demo abstract in an abstract way, how it looks like and how it's built. So you have the order processor here, orders queue and whatnot. But if this seems a bit like that, this is essentially a simplistic abstract representation, for example, of a web shop. So if you are running a, let's say, Christmas web shop, Halloween web shop, or any kind of seasonal or anything, you might face a lot of sudden amount of orders very fast, and then you really need to auto scale up and down your order processor amount to really handle that order queue when that's necessary. So let's get to the demo itself. We have here a bunch of different great looking terminals. So let's get started. So before we get to the kind of the actionable, super action-packed part of the demo, we're going to do kubectl get services namespace kata.net sample. So we get the external IP that is actually here. We opened it up before, but now we're going to do it again. So we actually making sure that everything's working as is. So then we see the order queue length. So we have the order queue amount and the number of messages here. So we will start the orders coming in with that will give us visibility there. So then if we do kubectl get deployments namespace kata.net sample, we will start saying, okay, how many order processors we have ready and how much are we using at any given time. And then for the last visibility things, we will get to kubectl, get pods namespace kata.example to kind of have a look into the history of what's happening here. So in here we see that, okay, there's not too much stuff happening because the demo hasn't started yet, but we will get to there soon. So then we will take here this .NET Run project KubeCon, since I've done this demo at KubeCon as well. So when we click through this, we will start to get, let's queue some orders. How many do you want? So this is when it starts to get super action-packed. It's going to come very fast, but that's the best part. So this is where Kata really shows its power by auto-scaling up very fast. So we have only 0 out of 0 order processor ready at the moment. But then when we say how many do we want 100. We click yes, queuing orders. There's a keyboard going. There's a bike, ball, gloves, shirt, so many happening. Then we see the order queue rising up as well. And then now we see these happening here. So we see pending and it's starting to create container, and then it's creating order processors. The order queue is rising closer and closer to the 100 because that's how many we put in. And then we see already that, okay, 4 out of 4 order processors are working. And this is moving from pending and continuing creating to running. And then we went to 100 and now we're actually starting to go down because we are processing all of those orders very well. And it's all going as we have planned. It's going down, and we are now at 8 out of 8, which should be the maximum amount of order processors that we should have. And now it's simply running and running. Now we're getting through all of those orders, and the order queue is getting shorter as well. And then actually we're at 10 out of 10, so we've got a few more order processors as well to help us. So that went very smoothly. So that's a lot of action in a very short amount of time, but that's a lot of the stuff that happened. So this is exactly the power. So you're only scaling up when you need the resources. So when the orders come in at once. Now Kata will also scale down, but that's going to take a few minutes. So we're not going to wait until then. We're going to push forward in the presentation and continue to more tooling options. But at the same time, this is where it happens. So it's going to eventually we start saying terminating, and then we would get to a situation where all of the resources would go back down to 0, and the order processor amount would go back to 0 as well. So that's exactly where the things can be. Let's terminate these so that we actually have, because I'm going to do a few other demos as well. Let's create just one window here in preparation for our future demos as well. But we're going to continue soon with that. But first, we're going to continue with the presentation so that we get to more tooling examples that everyone can get started on using. Let me find the presentation. So there we go. We have Helm. So I mentioned Helm in the beginning, which is the package manager for Kubernetes. So it helps you with, so as far as cost goes, package management really helps you with, for example, if you are installing a lot of tooling or you need to remove a lot of tooling, so you're kind of like fixing, needing tooling and retiring the tooling, package management helps you with that because it helps you actually properly get rid of it. It doesn't leave anything hanging there, so you're keeping your system lean and managed the whole time. So because having a good DevOps space really helps you with cost management as well. So what is package management as well, if you're wondering? So Helm is a package manager for Kubernetes. So it's similar to Homebrew, Snap, or Chocolatey for Kubernetes. And I think one of the Helm maintainers really puts it really well. So package management is tooling that enables someone who has knowledge of an application and platform to package up an application so that someone else who has neither extensive knowledge of the application or the way that it needs to run on the platform so that they can use it as well. So this is really the power of package management and the power of Helm. And as I mentioned in this context, in the cost context, obviously, if you are really well managing all of your tooling, you are well managing your cost well as well. So Helm really helps you manage complexity. So charts describe even the most complex apps, provide repeatable application installation, and serve as a single point of authority. It has easy updates, so it takes the pain out of updates with in-place upgrades and custom hoops. It has simple sharing, so you can Charts are easy to version, share, and host on public or private servers, and you can use rollbacks to use Helm to roll back to an older version of a release with ease. And now, since all CNCF projects might be at different levels, so CADA is an incubating project and Helm is a graduated project, so Helm is quite a far in their journey. So Helm also takes security very seriously. There's multiple maintainers, multiple companies packing it, and it has a lot of great features such as power user email, it's release candidates, it supports Mac, Linux, Windows, and it's been a household name for a while already. So how to use Helm then? You use it by using charts, and the prerequisites are having a Kubernetes cluster and deciding what security configurations to apply to your installation, if any, and then installing and configuring Helm after that. And as a fun tip here as well, we have Artifact Hub, which is an easy way to find Helm charts. So you can find and install and publish Kubernetes packages as well. It's a CNCF sandbox project, and Artifact Hub has the goal to provide a single experience for consumers any CNCF project can leverage, as well as Helm as well. So now, as advertised a bit before, we're going to go to the Helm demo. So the Helm demo is going to be easily deploy complex application, which is in this case WordPress, to Kubernetes using a Helm chart. So let's jump back to the terminal area again. Let's make this maybe a bit bigger. Now it's properly big. And let's find my Helm demo notes, because I will make too many typos if I don't copy paste these things. So we're gonna switch the context a bit so that we actually get to our Helm area as well. So that we get to the Helm demo part from the CADA demo part. So let's kick it off. So easy account show to show you that I am logged into Azure and it's all working very nice on that front. Then we can do kubectl get services. So we can see that there is a empty Kubernetes cluster running in Azure that I've created earlier. And it's all looking exactly how it should be. And then we have kubectl get services, all namespaces, to see that there's no kind of Helm releases happening here either, but there is a bit of Linkerd stuff there, because I do have a Linkerd demo as well that I can do. And if we do Helm list, it should show that there's no Helm releases either, so we are starting from scratch. So it all looked good. So if we were to do this for the first time, we would need Bitnami. So Helm repo add Bitnami here. So for me, I've done this before, so it doesn't do it for me, but if you were doing it the first time, it would do it. And then if we do Helm search repo WordPress, we will see what are the options that we can use. And just as a fun fact, in the previous releases of Helm, it was Helm search WordPress, but nowadays there needs to be the Helm search repo WordPress added here. So we're going to be using the Bitnami one. So we're going to do Helm install Bitnami WordPress generate name. And then we're going to get a lot of stuff happening soon. Perfect. There it goes. And here we see, okay, we have gotten a lot of stuff, a lot of things are happening. And then, but we're going to just push forward and we're going to do kubectl get services, because in here we now see the external IP that we wanted to see. So we can actually copy paste this to our browser, and we can in here, then we can see how does the WordPress look like. It will not have run up yet because it takes a few minutes for it to do, but no worries, we have stuff to do while it waits, and it's going to slowly load there a bit. So while we're waiting for that to happen, we can actually see here, because we want to actually access the WordPress as well. So now we're springing it up, but we also want to log in. We want to start our blog. We want to start our website, whatever we want to do with that WordPress. So we here echo username. We see the username there, so it's user. And then if we copy paste this Kubernetes secret and we put this here, we see that. Did I typo something? Okay, let's see. let's do it maybe again, or if I'm missing something completely. It's always the demo effect that might happen. Let's see. Okay, let's see how it goes, but it should spring up anyhow. Let's see. And then in here we see it starting to work, but that's how easy it would be get the password if it was true. If I'm not missing anything and the sun isn't blinding me. But there we have the WordPress working. We have it all working as is very nicely. And then we have everything nicely working here. We're not going to try to put the password in now because it seems to be not working quite exactly as it should be, but we're going to disregard that and let's move on as well. So all in all, what has happened here in the demo, we have installed WordPress and MariaDB to our Kubernetes cluster, configured WordPress, and stored the admin credentials securely as Kubernetes secrets as well. So it's very easy and super quick to get that WordPress block up and running very fast. So that's really great and nice. Then let's move on to the next recommendation that I had. So Linkerd, so using a service mesh. So Linkerd is a really great service mesh to use, and that's why I'm using it as an example here. So Linkerd is actually the first service mesh around for Kubernetes, and then it's ultralight, ultra fast, and security first service mesh for Kubernetes. And the overall goal of Linkerd is to reduce the mental overhead of having a service mesh as well. So what does Linkerd do, and what does it help with cost as well? So it provides you observability and service level important metrics. So it provides you success rate, latencies, and so forth, and reliability, so retries, timeouts, as well as security. So this also goes into the fact that, okay, if you are managing your Kubernetes clusters very well, you're actually understanding what's happening in them, you have visibility, to have good governance. These are the things that service mesh has helped with as well. And then what are the benefits then of Linkerd in general? What are the kind of parts of it? So it has a really good open source community that's always willing to help and get you started as well. It has a very simple and minimalist design, so no complex APIs or configuration needed for most applications. Linkerd will just work out of the box. It has deep runtime diagnostics, so you can get a comprehensive suite of diagnostic tools, including automatic service dependency maps and live traffic samples as well. As mentioned before, it's ultralight and ultra fast, so it's built in Rust, and Linkerd's data plane proxies are very small and very fast. It installs in seconds with 0 configurations. So Linkerd's control plane installs into a single namespace, and services can be safely added to the mesh one at a time. And it has actionable service metrics as well. So it has the best in class observability that allows you to monitor those golden metrics, success rate, request volume, and latency for every service as well. So what are the principles of Linkerd then? It just works. It should be built that way. It's, as mentioned before, it's ultralight. It's simple to reduce operational complexity. It's security first, default, not an extra. And then it has its own proxy actually. So Envoy is another CNCF project that's usually quite often used, but it's in here we have Linkerd 2 proxy, which is makes the foundation more secure and custom. And as far as comparing to other service meshes, it's kind of the bare minimum service mesh, especially comparing to Istio, for example, but it has a very healthy focus on Linkerd, and it has this kind of just work ultralight mentality as well. So what is needed to use Linkerd? You need to have just inject this, and then you're good to go. So that's really how easy using it is. So then I have a quick Linkerd demo, which is easy real-time service metrics. So I'm just going to show you how easy it is to see and use Linkerd to get all of the service metrics here. So let's close this one, and then maybe clear this one, and then let's get to opening up actually another terminal as well. Let's open maybe BitSense. Sounds good, isn't it? Isn't it a fun one to pick? And then we're gonna go to my Linkerd demo. So then we're gonna do kubectl, and we're doing the port forward here. So then we're actually gonna have visibility into the Linkerd demo app that we want to showcase. So this is how it looks like. So this is the app. We will soon see what kind of metrics and success rate, volumes, and all of these things, what we will get from here. So you have the emoji vote. So you can tap your favorite emoji to vote on it. So if I want to vote for the monkey one, you know, I put this, view the leaderboard. Oh, and then we actually see that there is quite a lot more votes happening here than what I've done. Like now, I just voted one, or I can vote for the other monkey, view the leaderboard. We see that there's quite a lot more votes. It's not quite, it's just not 2 votes. So there's a lot of bots voting on the background. So we can then actually have a look into what the bots are doing so that we can see more into what's happening within our clusters. So we can do Linkerd and emoji voto here, and then we start seeing a lot of data coming in as well. We see all the bots voting. They're doing great job as far as voting. You can see here they vote for Santa, they vote for Dancer, they vote for Jack-o'-lantern, sunglasses, vote Joy, and so forth. And then if we open another terminal, because this just needs a bunch of terminals here, we can actually grab to see what's happening inside a single pod. So in here we see a bit more closer here. So there's a lot more action in here as well. And then if we open the final terminal of this demo, close actually this one. And then let's open the final terminal. I promise it's the final terminal of this demo. So we do Linkerd dashboard. And then we have here opening up the more graphical interface into accessing these things. So in here we see, okay, if you want to see some of the same data that I've shown you there before, but in this environment, we go here and we click here. So there we see again the bots voting, and it is happening a lot here as well. And then if we go to namespaces, we see here success rates already, latency, and whatnot. And then we can go to here to Grafana. Then we actually get to the Prometheus as well, where we get to see global success rate, global request volume, deployments monitored, latency, request volume, success rates. So we get a lot of this kind of data just like very easily. So we can actually have more visibility on governance and the things, so we can know how our optimization efforts are faring in the real world. Yeah, let's check on the time. Great, I think we might actually have time for a quick run through of Flux as well. Because I did recommend that one as well. Let's close maybe some of these so that we are not, you know, distracted by all of the moving parts everywhere. So then let's close this one as well, and then let's continue to, and it obviously goes to that. So then we go to Flux, which is the GitOps family of projects. So Flux is great, and Flux is actually, you might be wondering, what is it? What is GitOps? So you have all of these CLI tools. So you have kubectl apply, kubectl set image, Helm upgrade, kubectl upgrade, and so forth. You can actually just use git push. So you can use the most widely known CLI tool, Git, and you can just use git push to kind of replace all of these tools as well. So instead of changing the state of your cluster with multiple things, you can use just one command to modify something and push it to your Git repository, and therefore it will end up in the cluster. So this can be anything from namespace and so forth. Another reason why this is really great, if you use Git, you have a nice history of what's happened to your cluster as well. So GitOps provides you one model for making infrastructure apps and Kubernetes add-on changes, and you have a consistent end-to-end workflow across your entire organization. So what this means in a nutshell is that you have an easy snapshot of your cluster that you can restore to. So if anything happens, if you lose your cluster, you can just plug your new cluster to Flux and you restore everything. So no stateful sets or databases are restored, obviously, but essentially everything that was in the Kubernetes memory is restored. Though to simplify things, it's the desired state that's saved in Git, and it's not the actual thing, but the desired state. So it's kind of like the save point that's saved there. And then why is Flux itself great for GitOps? So a Flux project aims to provide a complete continuous delivery platform on top of Kubernetes, supporting all the common practices and tooling in the field, for example, customize Helm metrics with Prometheus and so on as well. And Flux has seen quite a lot of growth and changes as well. So Flux version 1 was a monolith that you can sync on a single Git repo to a local cluster and automate updates to YAML and Git. But then Flux number 2, version 2, is actually a Kubernetes native microservices, and it was rewritten completely from scratch as well. So what are then the Flux practices and benefits? So you can, it has defined GitOps practices. So to describe your system declaratively, keep configuration under source control, use software agents to reconcile and ensure correctness and alert for drift as well. And then the benefits really are the collaboration on infra, access control, auditable history, drift correction, clear boundaries between dev and team and Kubernetes as well. So there's a lot of benefits to using Flux as well. And then for the last project that we will be covering today from the CNCF arsenal of projects to use to optimize and manage your costs is the measure that I mentioned before. So we went through a Linkerd demo. We went through, okay, how does it look like, how to use service mesh. So what if you end up in a situation where you have multiple service meshes in your cluster and you still want to manage them very efficiently, and you want to actually have all of your applications working nicely. So this is where the service mesh management plane, for example, Meshery comes into handy. So as mentioned before, service mesh is usually a control plane and a data plane, as the Meshery introduces the management plane on the other hand, which is then kind of like another layer that really provides federation, integrates with the backend system, and may help perform chaos engineering, deeper insight into the performance, and long list of things that are possible to do. And Meshery is actually a very new project within CNCF. So Kata is an incubating project, Flux is an incubating as well, Linkerd and Helm are graduated projects, but then Meshery is a sandbox project. So it's relatively new, it's only been a few months in the CNCF, but it's actually very popular. So it has 15 maintainers, it's very community first focused, and it's actually the most popular project in the Linux Foundation mentorship program already as is. So very fast growing for sure. So it also supports over 10 different service meshes, and it has multi-mesh management, so lifecycle workflow, performance configuration, patterns and practices, codes and filters as well. And Meshery is about halfway to a complete architecture, so it's still building up all of those features and getting faster and stronger all the time. And then let's maybe close this. I know it's templating parts there. So we have now gone through quite a few many CNCF projects. We went through Kata, Linkerd, Meshery, Flux. We went through a bit of Prometheus as well within the Linkerd demo and everything. So then there's actually vendor solutions as well, which are obviously paid, so like commercial and paid solutions and all of these things that you can use to maybe do holistically cost management. So it's more of a, fit-for-all solution in a way, but also obviously you can do a lot of these things by using the open source tooling as well. But if you have a situation where you can use vendor and commercial solutions, these are really great ones to try on. KubeCost is really great if you want to do just really great visibility as far as reporting goes. Really good stuff there. And then you have more of automated solutions that are platforms like focusing automation. You have Cast AI, you have Stormforce, you have Spot.io. And some of the differences here are that Cast AI and Stormforge are more Kubernetes focused as well. And well, I'm working for Cast AI, so obviously I'm going to use them as an example and show you a bit on how these kind of vendor solutions work as well. And in my mind, I think the automation really works really great. So obviously it's a great solution to look into, even though obviously using open source project is really great as well. So how does it look like then if you're using this kind of vendor solution managed autonomous Kubernetes solution, for example? So for example, with Cast AI, it looks like this. If you sign in, you start using the service, you have this kind of connected cluster prompt, and then you just give some rights very small read-only lights for the first connection to your cluster, and after that you get this kind of really nice dashboard where you see all of the different savings data. You see all of the different areas that that you can start actually doing. So you see how many pods are spot friendly in there. So it's kind of, you can do all of these manually as well, but if you want to kind of shortcut it, you can use this kind of service to see these things. And then at the same time, you see which spots are spot friendly. You see how many much you could be saving. You see kind of like the current cluster configuration, what would be the more optimized cluster configuration. And if you further move from here and you give the kind of set policies click, and you move on to the next phase, the system will actually start automating all of these things for you as is. So it's really great way to if you kind of want to have a hands-off solution rather than a hands-on solution to cost optimization. So this works really wonderful. And then as a recap, we have gone through a lot of things in this almost coming into an hour. So we have gone through why cost optimization matters, why is it actually complex. We have gone through 8 best practices that you can utilize already as is. We have gone through multiple CNCF projects to leverage. We went through a closer look at CADA as well as Helm, as well as and Linkerd, Meshery, and Flux as well, to look into these different CNCF projects. And then we also went through a few vendor solutions, and I showed a bit about how that kind of automated solution would work as well. I love giving a lot of learn more resources as well, so you can kind of learn more on your own, continue further from this session. FinOps Foundation, as mentioned before, is really great for a lot of great resources into, they are really building a good foundation and principles, and kind of setting the standards for how FinOps and cost optimization would look like. You can find them and check them out. The 8 best practices to reduce Kubernetes cost. You can find it as a Kong article. Well, I was the contributor for the article, but you can find it from Kong website. So that's the link to there. Really easy to remember the URL, by the way, cloud cost optimization. Really nice. And then the FinOps Foundation principles are actually there again, but never mind that. So there's a lot of great resources there. There's a really great actually book as well that you can find from the FinOps Foundation site, or an O'Reilly book on how to manage your cost. And then if you are more of a beginner to Kubernetes and cloud native world, then I highly recommend you to checking out, for example, Tech World with Jana in YouTube, that she goes through a lot of good things and tips on how to get started with Kubernetes and all of these kind of things. LinkedIn Learning also has a lot of great content and resources and courses in Kubernetes as well. And then CNCF, so Cloud Native Computing Foundation, has a really great and very active YouTube channel where you can actually kind of do a lot of deep dive into all of these products. So I showed you quite a few different tooling examples of what you can manage, what you can use things on when on your clusters. But then at the same time, if you want to, watch like a 30-minute, 45-minute deep dive into CADA or Meshery or Flux or any of these other projects, CNCF YouTube actually quite often has those, but obviously you can also access those in the project sites and kind of learn more from there as well. And if you want to learn more about Cast AI, you can hop on to cast.ai to learn more there. And then, as always, I put the links and the slides to my GitHub, so github.com/AnnieTalvasto, and I think it's presentations there. So there you can kind of find these links as well as the slides as well. So no need to panic about scribbling down all of these links or taking an image or anything. You can find them from there for sure. So no worries. And if you are more interested in open source projects in general, learning more about these kind of things, or how does the let's say the normal day of an open source maintainer look like, my podcast called Gossip, we did an interview a while back with Tom Kirkhope from CADA, where we talked about, okay, how does it feel to maintain a CNCF project, open source project, and all of these kind of things. So I highly recommend checking that out. But I am wrapping up this presentation. It's been lovely spending this about an hour with you, everyone. And if you have any questions, concerns, you can always hop on to Twitter. You can find me there with @AnnieTalvasto. I also tweet and retweet as well as all of these kind of things. A lot of Kubernetes, cloud native content, and all of these things. So super happy to see you all there, super happy to chat and all of these things as well. But that's it from my part as far as these things go, and it's been lovely talking to you today.
Thanks a lot, Danny. A wonderful session. And I'm sure we can all save a lot of money through this session. It was a wonderful learning. As of now, I don't see any questions. People, if you have questions, you can reach out to Annie on our social media channels, and you can post your questions on YouTube chat also. She'll answer. Okay. I guess in the
Looking
interest
forward
of
to it.
time, Annie, in the interest of time, let's switch over to the next session. Thanks a lot, Annie. Thank you so much. It was a wonderful
Thank you so
session.
much for having me. Bye.
Hello.
Hello. Hi, Darren. Can you hear me?
Hey, how you doing? I can hear you.
Thanks. You're loud and clear. Good. So, thanks a lot. Thanks a lot for joining in, everyone. The next session is going to be on AutoML. Darren has promised us to make a hero, you see, a ML hero by the end of this session. Okay.
Yep.
So,
I'm gonna be
the
sharing the
stage is-
secret weapon.
Yes. You can start sharing your presentation. You can post all your queries on the YouTube chat, and there will be a feedback session, feedback URL provided. It will be posted on the YouTube chat. Please provide the feedback for Darren's session on the URL. Thank you. Darren, the stage is
Okay.
all yours. You can take it over.
Yes. There we go. I'm gonna share my screen. Bring it. It looks like I can't. I'm gonna need your help to bring it to the screen. Can I do it myself? It looks like I can't. Okay, there you go. Perfect. Thank you. This is looking great. Hey everyone, let me start my timer as well, just to get a sense of the time, because sometimes I kind of finish things a little bit over time, so I don't want to make that happen. Okay, there we go. Azure Community Conference 2021, and we're here in this session. And yeah, first off, our sponsors, right? Thanks for all of them making things happen. This conference, you might have noticed that there's more than 8 or 9. I don't remember the exact. We are on the 8th track. That's what I remember. So there's a lot going on in here. I don't know how many, the total numbers of sessions. I don't know what is that, but that's something crazy. The amount of speakers, the amount of sessions. And who am I? So I work for Microsoft. It's been just 2 months, by the way. I just joined Microsoft 2 months ago. So I am leading Azure application development for Microsoft Middle East and Africa for small and medium and corporate businesses. So that's a lot, I know, but simply interested in Azure application development. That's the long story short type of statement. And before joining Microsoft, I led 2 startups. I did a little bit of a consultancy as well, but during the span of 10 years, so to say, I've spent my time building products on Azure, SaaS products, multi-tenant SaaS products built on Azure platform as a service offerings. Not a single VM has ever been used, and I'm very proud of that. So that's where I'm coming from. And in this session, here's what we're going to do. I wanted to share something. Maybe you've already heard about this, obviously, AutoML. I'm sure you heard. If you didn't, that's just beautiful, because this is just session for you. If you did, still, this is the session for you, because we are going to focus a little bit from the perspective of Azure. And maybe I'm sure I'm going to be able to share some insights that you might not have encountered so far. So the idea that AutoML is the secret weapon, and you're going to get it during the presentation, but it's like, it's an easy way out, not doing a lot of work, because that's essentially the core of being a developer, right? I mean, the reason, most of the time, the reason we write some kind of code is to automate stuff, right? Instead of us doing the manual work, we want a computer, a machine, do the work for us. And AutoML is kind of, as the name suggests, AutoML is kind of automating the process of ML. And when we do that, it helps us obviously, get rid of all of the handwork, essentially. I mean, we'll talk about the details, what I'm referring to. All of the handwork, all of the, that detailed and, time-consuming work, it helps us get rid of that. And on the other hand, it helps us, a little bit not needing to go into the very deep details of machine learning and AI as well, not really required to be an ML expert. I mean, if you are, then it definitely helps. I'm not saying it's for nothing. It definitely helps. I mean, we're not obviously in the span of 1 hour here in this session, we're not going to be covering the full spectrum of things. But if you have some ML background, or if you are willing to go deep into ML and AI, then you should still do, even if you have your secret weapon, because it's going to help you out to fine tune the weapon a little bit and get to the result a little bit faster. With that, so let me jump to the next slide. So I mean, we did actually talk about this. Let me look at the slide. I mean, I'm using the slides in a way that those are notes for myself as well, so that I don't forget mentioning something. So automated machine learning is the process of automating end-to-end process of applying machine learning to create, deploy, develop predictive models so that any enterprise benefits from data. Automation, it's all about automation, being able to automate, because if you got into any ML or AI project, you know that mostly about ML in this case, you know that it's all about experimenting, right? So you got a question, you don't even know if you're going to be able to answer that. You try to find the data, you kind of discover the data, you kind of clean the data and see if you have the data, and then if you have the data that you think can help, then you run some experiments, try to figure out if you're going to be able to come up with the right model that's going to be able to help you answer the question. And in some cases, the experiment fails and you go to the beginning, you either are missing some data, you either need to fine-tune the parameters for the model, and so on and so forth. So you run the experiment again and again, and to be honest, at the end of the day, you might find out that you're not even able to answer the question in hand, even though you've run a lot of experiments at the accuracy levels that you want. And this might be, again, because missing data, but this might be, at the end of the day, there is the chance that you will never be able to answer that question as well. I mean, you should always keep that in mind, because maybe you need some data that's not going to be available at all, that is not possible to gather, or whatever, right? So, and the other thing about AutoML is that it's a little bit of a low code, no code experience. What does that mean? So that means, I mean, there is a coding approach that I will refer to at a point. I will, kind of point out how it's done, but it's not going to be the focus of the session. And overall, AutoML itself, even though you can consume an AutoML pipeline from code, the AutoML process itself is supposed to be a low-code, no-code experience where you don't have to write the code that's going to train the model and, go throughout that process. And the automation is about searching for the right algorithm, because there's a bunch of them, right? Searching for the right algorithm and the right hyperparameters based on the metrics that we define. So we're going to be defining some metrics, and that's where the ML knowledge comes in. I mean, if you're very familiar with the ML concepts, then you're going to be able to find the scope of the automated search, if that makes any sense. But if you're not, then maybe you're going to spend a little bit more compute power to, I mean, in one sense, I can actually call this a brute force approach to ML, because, I mean, yeah, let me stop there, because I got some more slides that can explain this a little bit better visually. And there we go. So this is kind of the first process. I kind of described this process a little bit. We got some data somewhere. We got the data, some SQL DB, relational data, Cosmos DB, non-relational data, NoSQL data there. We might have some data warehouses with a bunch of different types of data. We might have a data lake. Some data might be on the blob storage. So long story short, we gotta get those in. Prepare the data, right? Maybe we can use something like, in this case, I mean, this is not the focus of this presentation, obviously, but maybe we can use something like Azure Synapse to do that, clean the data, transform the data, combine the data from multiple pipelines, and so on and so forth. And then we build and train a model. So we pick an algorithm and we start building and training, and then deploying and experimenting with it, right? So that's kind of the high level look into the big process. And at the end of the day, what we're trying to answer is, again, a simple question. It might be as simple as, how much is this car worth? I just want to predict how much it's going to be. That's the question. I don't know if I'm going to be able to answer this question based on the data that I have. I don't know how accurate that answer will be. And based on the accuracy, I don't know if it's going to be helpful for my business or not. Because at the end of the day, we have to connect this back to the business outcome, right? We have to come up with some value to the business. And with that, let me take a look at, oops, this was too much. I didn't mean to scare you guys. I just wanted to look at the chat to see if there are any questions. And there we go. None so far. Great. Oh, it looks like I forget turning on lights. There we go. Now I'm going to look much better. Okay, cool. Next slide. So getting a little bit into the details here. So in this case, we're talking about, how can we predict the price of a car, right? Let's go back and remember, what was the question? How much is this car worth? And I mean, maybe we need this data to do a prediction because of, we're an insurance company or something. I don't know. So in this case, there are features that we might want to incorporate: the mileage, the condition of the car, the brand of the car, the year of make. But again, we don't know which one of these features will really be helpful to predict, or we don't know the different levels of help they can provide. Maybe the mileage is a more important factor compared to the condition of the car, but we don't know that right now, right? So, and then there's a second question that comes in: which algorithm should we use? I mean, should we use gradient boosted, nearest neighbor? What are we going to do? And this question is where this question is where the knowledge about ML helps out a little bit, right? Because you're going to see that when we run an AutoML experiment, at the end of the day, out of this brute force approach, we can actually, if we want to, we can exclude some of the algorithms, because we have a full set of features, right, that we don't know which one is going to help. I mean, we can, if we know for sure that, hey, the condition isn't going to be helpful for some reason, I know, right, isn't going to be helpful. If that's the case, right, I can definitely exclude that out of my, search. Because during the search, we will be using a brute force approach, applying all of these features and different algorithms, trying all different algorithms. So if we know that a particular algorithm isn't a good fit for what we want to do, then we can definitely exclude that. That's where the ML know-how comes in and plays. And then we decide on which parameters we want to do, how we're going to fine-tune those, and so on and so forth. So in all this work, you got to do it again and again to see the result, experiment to find out the best that gets you the best results, right? With the highest accuracy, hopefully. And this is, okay, this is the slide to scare you off. In case you're not into ML, this is supposed to scare you out. And that's all. That is the only purpose this slide exists. Just scare you off. No, another purpose of this slide is to help you love AutoML, right? Because there are a lot of different decisions, a lot of different things that you should be aware, and it's complex, right? In that complex world, AutoML really saves a lot of time. That's kind of the long story. Either you have a expertise in ML or not, AutoML is an automated approach that you can definitely incorporate into your stack of tools, right? If you don't, that's, again, it really helps you try to see if there is a brute force approach to find an answer to your questions, and we will get there. Okay, here's a different look at this, right? So we did talk about the data set, the training algorithms, and so on and so forth. So how does that all those pieces fit together, right? So this is the repetitive process, and this is manual. We got the data set. We assume that we cleaned that up. It's ready to go. We got the training algorithm, and then we got the hyperparameter values configured for a particular configuration set. And then what we do was we combine those and train the model, and then we test the model and see if it works. If it doesn't, we go back to the beginning of the process. We see, again, with all these boxes, we might be missing stuff, right? We might be missing some data. We might have picked the wrong algorithm, right? We might have configured the values, wrong, or we might need to fine tune a little bit further. So, and this process is the repetitive process that we are trying to automate at the end of the day. And this is kind of the new version. If you implement automated machine learning, you still have the data set, obviously, but then you have optimization metrics, right? You decide how you're going to optimize the whole automated ML process if you want to. And if you don't optimize, what are you going to lose? The third item, we're going to put some constraints for time and cost. Because think about it, you are going with a brute force approach. You can actually go for forever, not necessarily forever. There's going to be a diminishing returns at the end of the day. And to be honest, Azure AutoML does detect that. And I guess we're going to see that. I'm going to be able to show you that. Because at one point, even if, here's how we approach this thing. We say, okay, here's the data. I want to do this. This is the type of question I'm trying to answer. Go. But before I tell you go and do your brute force thing, we're going to tell you, hey, this is the amount of money I'm going to spend with all this, experimentations, or this is the amount of time at the end of the day we're using CPU or GPU power. So we are telling the platform that, hey, I got 12 hours for you to go and do brute force, and out of the 12 hours, come back to me, give me your best result, and let me see what we got. That's the approach. You can definitely give, instead of 12 hours, I'm going to give you, 40 machines with so many hours. But at the end of the day, Azure AutoML can detect that diminishing returns, point, and it's going to tell you, during the last 20 runs, I didn't see, enough increment in the accuracy or whatever goal you decided to hit. So I stopped the experiment for you a little bit earlier than just keep going, because there is no value to go any further from this point down. So even though you tell Azure to go for 10 hours, it might stop in 20 minutes if it sees like there's no need, really no value enough to go forward. So that's a good thing, to be honest. So yeah, and that's going to be our approach. And how can we use AutoML, right? I mentioned that I'm going to tell you a little bit about the code, and this is as far as we go. Let me have a sip and see if there are any questions. No. Okay. In that case, I'm doing a beautiful job explaining the whole thing, right? So we got two different paths at this point: code or no code. No code means we're going to use Azure ML Studio. We will be creating our automated ML runs there. Code, which means we can use Azure ML Python SDK to consume the platform. Azure ML still. The Azure ML will still be the infrastructure that we will be using, but we're going to be able to configure and run that from the Azure ML Python SDK. So the only difference is, you're either doing it from a UI on the ML Studio or doing it through code, maybe in a notebook or something. Again, you are not going into the ML process and writing code to implement the AutoML process itself. No, that's not what you're doing. That's baked into the product or the service. So what you're doing is the way you consume AutoML can either be from the portal, which is what I'm going to do because it's much easier, to be honest, and it's much more friendly, not necessarily easier. I mean, if you write the code once, it's, if you got it in a notebook, it's still easy to run. But it's just more friendly visually, I guess. So that's the way I'm going to go. But keep in mind that if you wanted to make it part of a notebook or consume or, kick an AutoML run through Python, you can definitely do that using Azure ML Python SDK. Okay, cool. So, and we got different tasks, right? We got different tasks that we can do in Azure AutoML. I mean, in this case, these three are, for example, classification, regression, and time series forecasting. The example that I'm going to go, the demo that I'm going to do is going to be time series forecasting. So let's go through this for a moment, right? The main goal, and for example, for classification models, is to predict which categories new data will fall into based on learning from our training data, right? Common classification examples might be, fraud detection, like I have on the slide, marketing prediction, I have it all as well. Handwriting recognition is one of them as well, or object detection, right? Do we have an apple in this picture or not? So that's kind of the classification. And the regression obviously differs from that, different from classification, where the predicted output values are categorical, right? Regression models predict numerical output values based on independent predictors, right? In regression, for example, the objective is to help establish the relationship, the independent predictor variables between the independent predictor variables by estimating how one variable impacts the other, right? That relationship is what we work on when it comes to the regression. And predicting pricing is one of those. For example, for the car example, this would be a nice, this would be the right way to go. And finally, AutoML, when it comes to time series experiment, is treated pretty much a multi-iterative regression problem. Past time series values are provided and pivoted to become additional dimensions for the regressor together with the other predictors to come out with a potentially the good result that you want to get to. So this kind of the high level, but I guess the a little bit higher level, if you try to go a little bit higher level, what we need to understand here is, do you want to classify things? Do you want to predict a numerical number? Or do you want to forecast something based on historical data? Okay. Back from all that geek speech that I did, a little bit geeky, not that much. If you're not into ML at all, I guess this final description of, because at the end of the day, when we go into the AutoML UI, you're going to see that we're going to need to pick one of those. So the system will not be picking automatically which one you want to do. So you're going to need to pick one of those. And the high level, way to pick which one is the best is, think from, perspective of, am I kind of trying to classify things? Am I trying to predict a numerical number simply based on other attributes? Or am I trying to predict something based on historical data on the data lays on a timeline, essentially. That's what it is. Okay. And with that, I was thinking I had the demo title, and I do have the demo title, Data Scientist in a Box, but it looks like I did put it into the wrong slide. Okay. So now I'm going to go out of presentation mode because I want to show you the whole story from scratch. Okay, here we are. Beautiful Azure portal. So the first thing I'm going to do is to click on create. Hopefully it's going to work. Okay. Oops. Okay. AutoML. I will create everything from scratch for you guys. The first thing I'm doing is obviously creating a resource group. It's going to be easy. Then I'm going to go into the resource group and create a Azure ML machine learning workspace for myself. Click plus, create a new resource, search for machine learning. Okay. Create. Nice. So now I'm going to scroll down a little bit, give this workspace a name, AutoML Azure, Azure Conf. Okay, the name is not taken. That's nice. It's going to be deployed into East US, and that's pretty much it. The container registry, we don't need it right now. It's going to be created when we deploy our model. Okay, let's go and create this. Okay, once you're done with the AutoML process, you can actually go and deploy your model for consumption. You can either deploy it. I mean, you can deploy it wherever you want, but the portal helps you if you want to deploy to a Kubernetes cluster or ACI, Azure Container Instances. It does the deployment automatically without you doing anything. But you can definitely get your model out of here and deploy it wherever you want. Even export a model that is mobile compatible and run the model locally on a mobile device or something. So those are all the options that you have. There's nothing that limits you. Okay, let's wait for this. It's gonna take just a minute. Not a lot. Come on. And then we're going to start creating our AutoML experiment. I have another environment that is ready. I mean, we're not going to be doing the whole training thing because, like I've said, it takes hours. I have another subscription where I have a full environment ready to go. I just wanted to show you the whole process of setting up things from scratch. That's why I wanted to deploy the workspace as well. Okay, there we go. It didn't take a lot, 2 or 3 minutes. Okay, let's go to the resource. And this subscription that I'm using right now doesn't have a lot of core counts. It's not a problem for this case because I'm not be running the ML experiment on this subscription. I will bring another workspace from another subscription onto the stage in a moment. Okay, it's coming. Beautiful. Cool. So as you can tell, this is Azure ML Studio. Okay. And the button that we're going to click is this big plus. No, this one, create new. Actually, we can go into AutoML and do it from there because that's the section that we're going to work on. AutoML and go into new automated ML1. You might think like, hey, we don't have any data. Yeah, there's going to be a wizard that's going to ask us for data. And that's where we're at. See, so this is where we're going to select a data set, but we don't have a data set. So we're going to need to create a data set. So I will click this one and say, hey, I'm going to create one from local files. And the data set name will be bike data. It's going to be tabular. Okay, next. And upload files. So I will be uploading some files from my machine here. Let's see where it goes. Okay, I got a CSV file in here. This is the one that I'm going to use. So let's click open. And here we go. The CSV file has been uploaded. Click next to see the data a little bit closer. It's parsing the file right now. And what? Okay, I'm going to try this again because this is kind of crazy. Murphy on my back. Come on. Okay, I'm going to skip data validation. Did I pick the wrong file? No. I picked the CSV file, right? Okay, I got the CSV file. What is the exact error? Authentication. You don't have permission to the specified parallel file if you want to proceed. Do I have that data file open right now? No, I don't. That's interesting. So what if I say skip data validation? I mean, we're not going to run this experiment anyway, so it's not going to cause any trouble. But, okay, these are going to be as they are. No schema to display. Okay, that's weird. Do you mind if I start this from scratch? Because I have no idea why this isn't working. From local files, sample data. This should work. Yes, this is the default, which is what I'm going to use. Okay, now, please, sir. Let me check something. I'm going to take a look at my notes. Nope. Okay, come on. Storage blob data reader role for... Oh, that's an interesting one. Okay, I can't fix this, but I'm looking at the timer. We don't have a lot of time. It's just about, I guess the workspace doesn't have the storage blob data reader role for this particular workspace. What if I take it kind of a different route? They're in simple data store. That work? Mm-hmm. Yes. Account key. Okay. I will give this a try. This is totally not planned. By default, when you create a workspace, those permissions are set up, so you don't have to worry. Trust me. Okay, let's see. Where's the storage account? And the keys. Oops. Where are the keys? Okay. Here you go. Yes. Create data store. Okay, let me try that. I think this error is left over from the previous execution. Hopefully. I guess so. Because I got the preview. Why do I have 3 rows? Oh, okay. No, I have more than that. Oh, and there was a scroll. It's just it's just that I'm not used to this screen resolution. Okay, cool. Okay, we got it. Next. I'm gonna remove casual and registered because those two are being combined into CNT field anyway, so we don't have to move this in. We can exclude those. I'm gonna say next. I'm gonna say create. Okay, problem solved. For some reason, the default didn't have the permission. Refresh. Okay, we got sample data. Great. So now we can select and say next. Cool. So now it's the time to create the experiment, right? I'm going to call it AutoML ASCOF experiment, whatever. Experiment. Okay. The target column that we're going to try to predict is going to be CNT and a compute cluster. So, okay. So this is where we have to create a compute cluster, which means we have to have some kind of a set of VMs and stuff so that we can use to run the experiment itself, right? That brute force will work in a compute layer. So for that, we have to create one. I'm going to click new, create compute cluster, and say, okay, I'm going to go with dedicated. I'm going to go with CPU, and this is the size that I want. General purpose D3. Okay, maybe we can use a little bit more RAM or whatever, and say next. So give a name for this compute cluster. They're in compute. Okay, here's what I'm not going to be able to do. 0 to 1 is not the best because you definitely want to parallelize the experiments. But in this case, I can't because my subscription has a limit of 6 cores because this is a very small subscription that I have here. But I ran this experiment somewhere else in a separate subscription. I will show you the results. So usually what I would do is I would go with something like 0 to 10 or 6 or whatever, right? And then you create it. So this is going to take a moment. So we are essentially creating, and because we started from 0, that means we're not going to pay for the cluster if the cluster is not being used, right? So if we don't have any experiments running, the cluster will not be used. The only drawback of that is, when you start running a new experiment, it's going to take a little bit of time to provision the initial node. And with that, okay, let's see. Let me look at the questions. Okay, I got a laugh on the chat. Things happen. Okay, this is not supposed to take this long as well. Any questions? Like I said, we're not going to run this experiment. Okay, there we go. Okay, I didn't have to fill the time. Okay, we got the compute cluster here, and we're going to select our own, the one that we just created, compute cluster, which has only one node if needed, and say next. And now this is where we select classification, regression, and time series. Time series has been already selected. It looks like the system kind of tried to predict what we want to do. And this is what we want to do. Time column will be date. Yes. Time series identifiers, we don't have to pick any for now. And auto detection, let's go with 14 for the time horizon. I don't want to go too much into the timeline. So reading the note from here, the forecast horizon is how many periods forward you would like to forecast. I'm going to limit it to 14. And then maybe we can go into additional configuration settings. And this is where, kind of the ML know-how can help you out, right? Because you can actually decide, what's going to be the primary metric for your experiment. Or do you want to block some algorithms, or are there some algorithms that you don't want to run? For example, in this case, again, we're not going to go into this, but I might want to block extreme random trees because it's not going to be helpful in this case. The other thing that we can do, and let me show you these other options as well. So again, we're not going to go into these options all because we simply can't cover it in this session, but this is where the ML know-how helps a little bit, kind of, fine-tune the experiment that you want to do. One thing that is critical to set up is the exit criterion, which is 6 hours in this case. So for 6 hours, I'm going to have one node. In max concurrent iterations is 1. So, oops, what happened? No, that's not what I meant. Okay. What's happening? Scroll down. All right. Max concurrent iterations is 1. If I had, for example, 10 nodes, I could increase max concurrent iterations to 10 and have it for 6 hours. So for 6 hours, 10 different experiments will be running, child experiments will be running to find out the best approach for this. In this case, we got 6 hours or 1 hour or whatever. And then you have max concurrent iterations. So this is definitely something that you should be setting up at minimum. So that you know how long you will be running the experiment and how much you're going to pay for it. So in this case, I know how much that particular VM is going to cost per hour, and I know how many hours I'm going to run the experiment. So I know pretty much how much money I'm going to be paying for this experiment, right? So I will save this one, and when I click finish right now, it's going to start running it. And let's do it. It doesn't matter. So let's do it. We're not going to be able to wait for it because I set it 1 hour, and I'm not sure what the minimum time is. I don't think you can set it for 5 minutes for sure. There is a minimum, but I don't remember what that was. So right now we are in the automated ML run page. It says not started, but if I refresh, it's going to say starting. The first step will be most probably provisioning. Okay, it says running, but setting up the run, preparing the Docker environment and stuff. So yes, and this is going to take a while to get going. Meanwhile, I can actually show you. I'm going to bring that in. Give me a second. Here we go. Please don't crash. Okay. So this is totally a different environment. A different subscription and stuff. And in this environment, I have an automated ML run with the same data set, the same settings and all that. The only difference is that this one had a bigger cluster. Let's see. When we go to the compute clusters, yes. Right now, this is 0 nodes. But if we go in there, where was that? Okay, the maximum number of nodes is 6. The VM is the one that we picked, but this is a much larger cluster that I used for this particular experiment. And I don't remember how long I've run this, but it didn't have to run the full length of the experiment that I set up. Let's go in it. Let's see what we have there. Okay, there you see it, right? So I gave this experiment too much time, and the Azure portal figured that, hey, no scores improved over the last 20 iterations, so experiment stopped early. That's good. That's good. You can definitely disable this if you want to. If you want the AutoML to keep going, you can definitely do that. But yeah, this is good. And if we look at here, you're going to see the best model summary. I mean, if we go to the models, the third tab, you can see all of the models and the different parameters that were tested. Let me try to make this a little bit smaller so that we can see all of the parameters in there. Okay, you can see here hyperparameters and the algorithm used, right? And I can scroll down and see. It looks like, considering the page sizes, okay, let's switch to 100 and see how many we have. Okay, it looks like 60 different configurations have been tested during this run, and then it came to the diminishing return point, and it stopped. And if we go into the child runs, you can see that some of these are canceled, some of them are completed, and so on and so forth. Cool. So, and if we go into the details here, we select the algorithm that won the best model. And I am assuming that you like the outcome of this. You might not, even the best that comes out of an AutoML might not be fulfilling your needs. And to be honest, it is kind of the case with this data as well, because I don't have a lot of data. So it's kind of tough. Anyways, voting ensemble, I'm going to click on it. So this is the model that we have, and what we can do. Obviously, you can see the download button, right? So click download, and you start downloading your model, and you got it. Okay. The other thing that we can do is to go and deploy. But before I do that, again, I'm not going to go into details of this because this session is not, is not supposed to go that deep. We can't do that with the time we have. But keep in mind that you can actually have explanations like which parameters are affecting the result higher compared to the others, and see and dig a little bit deeper into the details of this AutoML experiment, right? What else should I mention? Metrics. Yeah, you can definitely come in and get those metrics as well. Look into the metrics and try to understand what you can do to improve the results. And finally, yeah, let's stop looking into those. Let's say we're happy with what we have and we want to deploy it. And you can click this deploy button. And it's going to ask you for a name. Final model. There is never such thing. Anyways, final model. Okay, it didn't like my casing. Okay, interesting. Final model, I'm not going to be deploying to Azure Kubernetes service, but I will be loaded to Azure Container Instance. And I am going to be brave and not require authentication for now for the sake of the demo. And in the advanced tab, I can enable application insights for this, enable SSL, and I can, decide, how much CPU reserve capacity I want to have for this model to be executed when it's served, memory reserve capacity, so on and so forth. So we will all leave these default and say deploy. And while that deploys, let me scroll down and go to, where was that? Endpoints. Okay. So when I go to the endpoints, we are going to see that I already have another one previously deployed yesterday night, actually. Okay, so this is, if I go into the final model, the deployment state is transitioning because it's going to, it's going to go a little bit faster because this is not the first deployment done by this workspace. When you do your first deployment, it has to create a container registry for you as well. So it kind of takes a little bit of a time. But the second deployment will be much, much easier. So let's go back to the bike prediction, which I deployed yesterday night my time. It's healthy. And when we scroll down, you can see the REST endpoint. So I can start sending REST API calls to this one and get some predictions. And let's do that. For that, I'm going to do something different. And let's give this a test run. I'm going to bring in VS Code. Okay, great. Open up the HTTP request that we're going to send. Cool. I have to change this endpoint with the new one that I just copied from the portal. And if my plugin works, oh, come on. The plugin that I have in VS Code decided not to run. That's an interesting one. Let me see. See, this is the second problem in this demo. There is a beautiful plugin for, I guess that was this one. Was that I really like, because it helps you craft HTTP calls in VS Code. But this says install. I don't think. Can't I just search in the installed ones and let's see, scroll down. Okay, yeah, this is the one. Why isn't that working? It was working yesterday. So let's disable and enable again. Stop and start. Sometimes it works, right? Okay, let's see. .rest is the file extension that you can use, but I know there was another extension. Maybe it's in here somewhere. Oh, this is a link checker. This is not the right plugin I'm looking at. Okay, let's give this a different. No, that's not what I meant. Okay, REST client. This is the one. Great. What was the extension? Okay. See, there should be a send request button. Oh, it came in. Okay. I don't know why it was gone, but it came in. Okay, cool. So we will click this. You see this little send request button in here. I'm not sure if there's a shortcut for this button. Maybe if there's a shortcut that might work or might not. Anyways, let me click on send request, and we are sending this request to our ACI, Azure Container Instances Deployed model, and we got an answer. So here we go. Oops. Let me do this. To me, it feels like everything is going against me today. Can I close this? Okay, perfect. Okay, so we got HTTP 200, a good forecast result. So this is the result of this model. And if we look at the original CSV, I am going to open that one up. Okay, the original CSP, and remember, we are trying to predict the CNT, the count. This is the count of bicycles we expect to be rented on this particular date and time. And we got all this data to build our forecasting. And if we go to, and by the way, where is VS Code? Our request was, let's go. Okay, so what did we ask? We asked, how many bicycles do you think it's going to be rented on the 4th of August? Okay, based on this information that we have. 4th of August, 2021. So let me go to the end of this Excel sheet and see what the numbers were looking. So numbers were around 5,000, 4,000, 2,000. So somewhere between 1 to 10,000, I guess. Right? Somewhere between 1 to 10,000 would look kind of acceptable. At least it's going to give us an idea that, this whole thing is kind of working. And let's go back and see. Okay, we got 38,000. Wow, that's a little bit high, but again, not the topic of this presentation, to go a little bit deeper kind of and try to understand if, and by the way, this prediction that we had, we already seen on the Azure portal that it doesn't have a very good accuracy, to be honest. We definitely need more data because we have a couple of years of data that ends on 2012, and we are trying to predict something in 2021. So kind of trying to predict something that happens today based on historical data that ends 10 years ago. So obviously it's not gonna be a perfect predictor, but that's more of a data issue that we have here. Perfect. Okay. So that's as far as the demo goes. Hope you liked it. With that, I am actually done. So here are our partners for this conference. Thank you to all of them, helping us out, make the conference happen. And then the huge community that supports the event, obviously, that's important. And if you guys are interested in joining any of these communities, feel free to go out. If it's really a good motivator, and it's really fun to join the community, whether it's a software community or something else, doesn't matter. Just go out and join the community and contribute in your own way. With that, do we have any questions? No
Hi, Darren.
questions.
Thanks for a great question.
Hey.
Thanks for a great session. As of now, I don't see any questions. People, if you have any questions, please post on the YouTube comments. Darren will be around for a few minutes. He can answer.
Yep. And don't forget to fill in the feedback form as well. It's on the chat. I noticed it was already shared. So there's a link on the chat that you can use to give us feedback about the session and the conference overall. And finally, this is how you can reach out to me if you, like I will be here for a couple of minutes, obviously. But after that, if you still have questions after the session and you want to reach out, feel free to, get in touch on Twitter or LinkedIn. And if you want to grab the deck right now, go to this URL that you can see on the slide. And you can, there is a different version of this deck because this deck is now branded with the Azure Community Conference template. You're going to see a different version of this. I didn't upload this particular version, but the content is the same. So you're going to see a non-templated generic version of this slide. But again, the content is the same. So
If you want to share the URL of the slides, you can share it, Darren. You can put it on the chat window.
Oh,
it's
sure. It's in the slide, but I can definitely share it out on the chat too. Let me see. And copy. And I'm gonna put it on the private chat because it doesn't look like I have access to the public one. So if you can move it there, that would be great. Cool, thank you.
Okay, so thanks for the session, Darren. I think there are no questions.
Okay, yeah, thank you very much. Thank you for having me, and enjoy the rest of the conference, guys.
Thank you so much. Hi, Marius. Can you hear me? I think you're mute. Can you unmute
Yes.
yourself?
Hello. Can you hear me?
Yeah,
Is the
loud and
sound
clear.
good?
Good. Yeah, loud and clear. Good, clear.
Perfect.
Hi, everyone. Thanks for joining the session. The next session is going to be by Marius. It is on the journey of a company who made a transition from experimenting on cloud to making it a successful journey. So let's hear the journey from Marius. Please post all your queries on YouTube chat. Marius will be around here to answer them. And please provide the feedback for the session on the URL share. Thank you. The stage is all yours, Marius. Take it forward.
Thank you. Can you see my screen? Perfect. Okay. Hello, everyone, and thank you for being in this session. It's a very interesting, exciting conference you're part of, and so I'm happy to present you my experience and my feedbacks from onboarding a company in France, a historical one, as you will see on the cloud journey. So you see, I made a cool intro, but this has some symbolistics actually behind. So the idea is that it happens not long ago. It's still running. The view in front is cloudy in both senses, but it's so interesting, so exciting, and the story I will tell you is this journey, how it happens and how we'll go on. As being myself, the storyteller from inside the story, if you can see what I mean. And by the way, these intermediate pictures have a particular sense. I will let you understand over the session. So myself, I'm Mary Zaharia. I'm from France. I'm a public cloud tech lead at Societe Generale, which is one of the largest and most important financial companies worldwide, with a particular footprint in Europe, but not only, also in America, in Asia, and so on. I'm a Azure most valued professional and advisor, working with the French community on Azure, one of the managers of the French community in Azure. And you can contact me at any moment, of course, on cloud-related topics on LinkedIn or on Twitter. So the story is about a customer, which is a strategic actor in France in a particular field of public transportation. It's a company which is there for ages. I mean, I believe 100 something, more than 100 years. A large national coverage, a complete national coverage, if I could say. And it's at the root of the most transportation networks in France. Now, what is starting being interesting is that this company is part of a larger group, and you'll see some kind of denomination during the presentation. This is called the group. So you have a group, and inside you have this particular customer, which is maintains this transportation network in France. Okay, and of course, because the customer has an IT system, there are many business applications, also technical ones, mostly IT, mostly most guys working on maintaining these applications, they are IT professionals within the company for that. So the development is more or less outsourced, and also different tasks are outsourced, like managed services operations, production expertise, some consulting tasks coming as it happens typically in this kind of environments. So there are different departments inside, and I'll be focusing this presentation from it's called Engineering, Operations and Service department, which includes particularly two sub-departments, which are the technical architecture and the networking, right? And then there is an innovation pole, which has a pretty strategic role for the acceleration on the innovation path. And then the third important actor in all that is the security service in the company, which is the information security service transposed in English, right? So this is the service which actually drives all the validations from the both security and compliance perspective, right? This is an important actor in all these things. And of course, there are other departments inside, but they're more or less related to our story. And so the challenge for this customer, which is very historical and has a long, I would say, a number of years behind in working, has a certain system which became more or less, I would say, stuck, or I would say moving not at an expected pace to the future, right? So people in the key positions in the company started to see the need of accelerating the pace of innovation. Okay, how could we do that? Via experiments, via environments dedicated for that, and so on. In the same time, there was a particular occurrence of timing, which requires at that moment that the IT infrastructure be transformed, because it was more or less obsolete and so on. So this was also an important trigger or challenge, if you want. And the internal way of working, the culture, in the sense of this space of innovation, but also in the pace of delivery itself, wasn't agile enough at that moment for this innovation to come, but also for time to market and really delivery in a cost-effective way. So with that in mind, people seen the cloud coming out, right? I mean, the public cloud. And at that moment, they realized that may be a driver, that may be a gate to move on. And they took a close look to two particular actors in that, two CSPs, cloud service providers, which are Microsoft Azure and Amazon AWS. And so in a first step, it was, okay, let's first of all try to see and how it works really, because we don't understand at this moment how it works. And so there was something very important happening, and this is something maybe that differentiated the things from other places and other environments, is that the information security service itself was onboarded and also part as driver of that change from the very beginning. And this was very important, because it wasn't on the, I would say, like a blocking factor on that. And also the CIO of the company was very open to this, because as I said, one of the guys from the deciding boards, the CIO of the company, was there and was in that sense of moving to the public cloud. So the steps were first to start with one particular cloud. It was Azure selected in the first step, and an Azure Enterprise Agreement was opened with the subscription and more subscriptions coming out later. And the first subscription was used by the security team. And the several deployments were made, and they even started to experiment with a site-to-site VPN connection on that. And the first learnings were that some projects were needed to be interconnected, and some other ones, at least in the experimental stage, were totally separated from the internal system. And then the advancements slowed down, because the expertise was started to be really missing at this point. And also the VPN with this mis-expertise at that moment, wasn't put in place properly, maybe, and it was malfunctioning simply. Okay. One particular point in this organization is that not only this company but also the group itself finally took a similar decision and influenced, or it was communicating like communicating, I would say, conducts, and they also decided to move to Azure, and they started to do that in a more structured way with a view, long view, but still a view to the production. And they started to implement an express route circuit at that level. Express route is the MPLS connection, which make the communication between the connectivity between on-premises and cloud environment and Azure environment. But at this moment, the decision was to move to a real team. So the real team meaning that we initiate a dedicated Azure team for that, Azure Experiments, or EXP. And the team was directly attached to the Chief of Technical Architecture, which helped also a lot in this kind of environment, which was mostly inertial, to drive very fast decision and agile decisions when needed. And at the same time, this Azure team was marked to be the strong arm of the innovation pole to actually help implement things for the innovation pole itself, so that the innovation pole rely on Azure for that. At the beginning, 2 people, Azure experts, were hired. It was actually, there were subcontractors, and a small disclaimer, I was one of them. And it was more and more difficult to find experts in the public cloud, and this is also true today, actually. So this was starting, but new challenges come out. So actually, there was a missynchronization also in communication in the approaches. So this direct customer wanted to move to the cloud more quickly and to target already production workloads. But the group strategy wasn't in phase yet with that regarding the cloud. And there was once again a place of responsibilities. It's much of politics at this moment, between who will be responsible to drive this production grade environment. So the result was that this particular team will be strictly oriented on experiments at this moment, right? Which also helped in some way, because the scope was very clear and we could do many things from that perspective. And the challenge on the VPN part was solved first. Particular configurations were found. Actually, there were missing configurations in the equipment, and then we started put in place monitoring of the traffic, and that was done by putting 2 Palo Alto network virtual devices and VAs in Azure in order to route, detect, filter traffic, right? Remember, at that moment there weren't things like Azure Firewall existing, right? And there was once again this joint effort between the Azure team and the security team in that moment. Okay, so more and more steps coming. The governance and management rule for this kind of experiments was created, and the team is now ready to receive real projects to support them to the cloud. The communication was pushed internally, and the result was that the first project came out very quickly. And actually, it was like an expectation for that, and it was like a noise going out, and see that okay, we have something there, and let's go try and see how it works, and we need that. Okay, and so we were very surprised by that at that moment. So we started to really organize this project and put them in place. Of course, we weren't responsible for the projects, but we accompanied them on that onboarding to the public cloud. And so we had different projects of different sizes. We started experimenting with containers, with the virtual appliances, databases as PaaS, with file sharing. And really, this was something very interesting, very new for many people there. Speaking about containers at that moment, and even today, depending on the companies, it's not so obvious to transform applications, at least to the containerization. And this was very opportune. There was an opportunity for that with the cloud, with the public cloud there. Not to speak about past databases, which are already managed, and so you don't have to do all these managed service efforts, or even some DBA gestures. They are not anymore needed. Okay. So as an organization, two zones are in place. One is the internet one for the applications which are not connected with the core IT system, and for low level of the classified data, and the internet one, which is the hybrid part. So applications willing to connect with the core system and so on. And so bricks of connectivity and securitizations are in place. For the internet zone, all the projects are isolated from each other. The virtual networks are dedicated for each project. And going to those environments is done via RDP or SSH via jump machines in intranet. Okay. On the intranet zone, there was a more structured thing, in the sense of having commonly a shared space, network space, with one mutualized subnet, but also small subnets for other projects within this first virtual network. And working a lot with virtual net. If there were separate virtual networks at that moment, also for some projects bigger than ones, there were peer with the main virtual network, and everything was secured by these two Palo Altos. This is just a glimpse of how the structure of this infrastructure was put in place, with this hybrid part with the virtual network gateways, and with the two NVAs for the intranet zone and for the internet zone. This is the management zone, and then this is the real project space, right? When with some bastion or rebound machines here, right? And so what helped us a lot is that we leveraged very early the native meanings for industrializing the deployments with our Azure Resource Manager templates, with Packer for the OS images, and using CI/CD with Azure DevOps pipelines. Okay, so you have, as an example, you have a Packer gzone on the screen. This is a glimpse of the configuration itself, stored in Azure pipeline, Azure stored in Azure DevOps repo, and then built with pipelines. Okay, from the governance perspective, we also leveraged a lot Azure DevOps. As you also see in the next slide, this is a way of working with tasks and project organization in an agile Scrum template. Coming back to this stage, we have a minimum process of onboarding. The whole process for the project was the first stage, which was the onboarding one, as called, which was equivalent as a pre-sales step, and then the implementation one, where we started to implement real things. And yeah, actually, it really followed up this minimal but very I would say standardized process, like we sailed uh, services inside the company, and it was really structured like this. Okay. Yes, and also by the tooling, by speaking about the tooling, Azure DevOps a lot. We used Planner also as a dashboard for the tasks that were shared from not technical perspective, and we used a lot. We didn't have at that moment Teams yet, but we started already using the infrastructure of Teams, which is also Office 365 groups and SharePoint behind, and so on. All these was pretty intensely used. So this was the team, and this team enlarged. We started to have we started to be more structured inside with the team lead, which was also an Azure expert, one project manager, and also integrator with other infrastructure and processes, an infrastructure architect, a system engineer, and we have associated resources from other teams, from the security team and from the networking and architecture teams also. Yeah, so once again, the agility was very useful with this Scrum methodology and Azure DevOps, and with tooling given by Azure DevOps boards. We worked in 2 weeks sprints, which doesn't make necessarily a lot of sense from in the team which delivers, which deploys infrastructure, but still has this advantage of forcing you to have real deployment results for these small projects which are there. So 2 week sprints were good to really ensure deployments at this level. Yeah, I will move a bit faster because we're getting to the end of time. But now the things are more and more, I would say, requested. So the team enlarges, more responsibilities are coming with more projects onboarding, more services delivered around identity, authentication, other paths. The serverless came into play, and so on. So the results are actually I believe it's the most important thing, is that the way of this Azure AXP team work infused the culture of agility to the other teams, and they started sequentially to apply the same rate of delivery and the same mechanism, but even the same tooling at the end of the day. So this is how the things helped the culture of the company to change. So as a conclusion, the cloud is not anymore a taboo subject, and this is once again a public transportation company. It's a public sector. Normally, the public sectors, once again, are more or less structured, or I would say fixed in their approaches. But yeah, I can tell you that at least in France, even the public companies go that way, and they really take the road and of change on that. The cloud is a very strong innovation driver because of the fact that you have this agility of the infrastructure. Let's remind us that before, the infrastructure was a blocker from the agility perspective. Now it's a driver. It becomes a driver, and that's absolutely a big change. And so what I would like to say in addition to that is the driver is not only for the innovation itself, but also for all the culture inside the teams and the using of DevOps methodologies and the agile patterns. Okay. And so what do you really need at the end of the day to have success in the cloud? You need to have a strong technical competency on that, because the public cloud in particular and the cloud include a lot of specific services, and the approach is different, and there are many features coming out and many services. You need to have a strong technical competency focus on that. You need to gain your maturity and experience in the way of deploying and pushing things in the cloud and developing for the cloud also. Okay, and really this has to work not as an individual. You should not have individual pieces in your company which are, yes, say, successful experts, but you need to be able uh, to put that as a team and to make this team work very closely together, because actually as an agile team it's impossible to do that in a disparate steps. So this must to be coherent and powerful as a team. So you need to build that consistency within the team. Yes. So this is the message I wanted to share you. So yes, at the end of the day, I would say the enigma is raised. So I spoke about the company called SNCF Réseau, which is the owner of the railway network in France. Yeah, and I'm ready to have questions from your part if you have any. And of course, I'm sorry of not having put the sponsors and community slides at the end, but once again, from my part, also I'm really thankful for the conference and its sponsors. It's impossible to do this kind of things without them. I really want to thank not only to sponsors but to people, the guys who are presenting, organizing, many guys behind the scenes who you don't even see. It's a huge effort this conference was made with. Thanks a lot.
Thanks for the session, Marius. It was nice to hear the journey. Let's wait for a few minutes. If there are questions, we'll take it. Else, people or Marius will be around. You can reach out to him on a social media, or you can post your questions on YouTube. We'll answer.
Absolutely. Thank you.
Okay, Marius, I don't think there's any questions.
Okay.
Thanks for your time.
Thank you. I would really like to just one thing to tell me what was the audience? How many people were online?
You want to know the number?
Yes, if possible.
Okay, there's one question before that from Amar. If you can answer, I'll just pop it up. He wants to know what were the major challenges faced during the transition.
I'm still online or not? Or you want me to?
Yeah. No, you're still online. I'm still having your video on. You can probably answer the question. Can you see the question?
So what are the major challenges faced? I don't see the last part of the question.
No, that is it. Like during the transition, probably he wants to know during the transition, what were the challenges faced, if there were any?
Yes. Yeah, there are challenges, definitely. For example, the differences between the rhythm of these innovation teams and the rhythm of deployments and of deliveries from the other teams. So this is a particular challenge that I saw. The time of aligning this delivery cadences is important to be shorter. So the culture needs to be accelerated. Yes, and of course there are other things that are important, like having in mind that you have the idea that at the beginning the cloud is very simple, as you can see. You deploy a thing in 10 minutes, but actually there are many other particular aspects which are more or less hidden, which are, for example, around how to secure this cloud, how to make it compliant with your internal requirements or regulatory requirements. So these are also aspects that are on the road, and you need to address them as you move to the maturity and as moving to the production stage with sensitive applications. You have to take that into account.
Thanks for your answer, Marius.
Absolutely.
I hope that answers your question, Amar. Thanks for your time, Marius.
Thank
We are
you.
also short on time, so thanks for the session.
See you. Thank you all.
Hi, Prashant. Can you hear me?
Yes, I can hear you. How are you?
Good, Prashant. Thanks for joining in early.
So we will start in 3 minutes, right?
Yes, Prashant. Yeah, it's time. You can probably start. We have about a minute and a half left. You can probably start. Not a problem. I just give an intro and you can start.
Okay.
So thanks for joining in, everyone. The next session is going to be very interesting. It is one of which I'm also looking forward to. Like, what are the use cases? What are the cases where it is between comparison between Logic Apps, Power Automate, and uh, it is called Microsoft. It was previously called Microsoft Flow. So, what are the use cases for both? Like, where has to be used? What has to be used where? Okay. So the stage is all yours. Please post your questions on YouTube chat, and the session feedback will be URL will be posted. Please provide the session feedback on the URL. Stage is all yours, Prashant. Thanks. Take it
All
forward.
right. Thanks, Rebirth. Let me start sharing my screen here. And let me know if you can see it, my audio, and also if you can see it, the subtitles as well.
Yes, Prashant. Everything is
All
clear.
right.
You can start off.
All right, thank you. So, good morning, good evening, good afternoon, depending on your time zone. Thanks for joining us today at Azure Community Conference 2021. It is India's largest Azure Community Conference. We would like to thank the sponsors, EY, Microsoft, and community partner Elastic. Without their generous support, the conferences like this are not possible. And also, would like to give a big shout out to the organizing team. To organize a conference like this, it takes a humongous effort, not only from the people who will be receiving emails, but a lot of people need to work at backstage as well. And this is one of the best run community conference I have seen in many, many years. So huge kudos to the organizing team and volunteers. So I will be talking about the key differences between Azure Logic Apps and Microsoft Power Automate. Especially, we'll be focusing on Microsoft Flow or Cloud Flows. Who am I? My name is Prashant G. Boyer. I was born and raised in India. Came to the United States in 2007 for studies. I'm University of Maryland College Park alumni. I co-authored a book, PowerShell for Office 65. I also uh, acted as a technical reviewer for the book Pro SharePoint 2030 Administration. I am from Washington, D.C. area of United States, and pre-COVID-19 pandemic, we used to organize a lot of community in-person conferences. Ever since the COVID-19 pandemic has started, we have converted all our conferences to virtual only. So if you are interested, you can either check us out on meetup.com, or you can just go to this slide, azurecloudevents.com, where we typically post the latest and greatest information about upcoming conference. One conference is coming up on 12th of November, where if you go, the registration link is live, and that conference is going to be focused on Azure Synapse. We have like a day-long tutorials focus on Azure Synapse in that conference. I am recipient of Antarctic Service Medal. I got this award from US government for the work I did in Antarctic continent back in 2008. I'm also recipient of Microsoft MVP award since 2017, and my current category is AI. And I right now work as cloud solution architect at Applied Information Sciences, where I focus on intelligent business process automation, where we use a variety of the products and services in Microsoft ecosystem, such as Azure, Azure AI, bots, Microsoft 65 Teams, SharePoint, and also Microsoft Power Platform like Power Automate, Power Apps, Power Virtual Agents, and Power BI. And I work at AI's Reston, Virginia headquarters. And we as AIS is providing services in Microsoft ecosystem from last 40 years, and we have been recipient of multiple times Microsoft Partner of the Year award. And AIS is growing, and we are looking for talented folks. And you can reside either in India, USA, Canada, and UK, and we have offices there, and we are actively looking for team members there. So if you are interested, definitely check us out, the open position on AIS.com, or you can also connect with me on LinkedIn, or just directly send me an email that I will be sharing later in the conference. So this is going to be the agenda. We'll start with maybe a minute or two description about Power Automate. Same thing we'll do with Logic Apps. And the bulk of the time we will be spending is talking about the key differences between these two products. Like what are the use cases? Where shall we use one over the another? And also what are some of the key differences that you especially when it comes to implementing automation, should keep into mind, because that will influence your decision which product you should go versus the other one. And we'll also talk about how we can extend Cloud Flows or Microsoft Flow using Logic Apps, key takeaways, and Q&A. So feel free to post your questions in the chat window. I am having dual monitor here, so I'm also monitoring the questions, and also the organizers are there as well, where they can help us with the questions as well. All right, so let's talk about what is Power Automate. Majority of you may have already been familiar with, but if you are the one of few many who are not familiar, then this is just a quick overview of Power Automate. So Power Automate is part of Microsoft Power Platform, and Microsoft Power Platform is a low-code platform that spans Microsoft 65, Dynamics 65, Azure, and standalone application. And we use Power Automate for the workflow automation. And it has more than 300 connectors, and we can build our own custom connectors as well. And in that connectors, we have some connectors from Microsoft, some other SaaS vendors, and also you can have your on-premise applications as well. And there is a growing list of templates available where, let's say, if you're totally new to this product and you would like to start building automation, there's a really good template library available which can help you to get started with. Now, what are Logic Apps? So Logic App is a cloud service that help you to schedule, automate, orchestrate tasks, business process, and workflows. And it is a de facto automation or workflow engine in Microsoft Azure. It's built on serverless principle, and it uses containerized runtime in the backend. And it scales up automatically to meet the demands. And also, one of the key advantage of using Logic App is it allows developers to not worry about building, hosting, scalability, availability, and all other backend stuff. All you have to do is just go to the Logic Apps portal or Azure portal and start configuring your business logic. Just like Power Automate, there are many connectors available across the cloud and also on-premise, and you can also build your own custom connectors as well. And just like Power Automate, everything begins with a trigger. And these are like the triggers available, and these are some of the popular connectors are there. And the list is more like, I don't have all the connectors listed in the screenshot, but if you go to the Microsoft documentation, just like Power Automate, there is like more than 300 connectors are available for Logic Apps as well. So if you see the description of Power Automate and Logic Apps sounds kind of similar. So let's see how we can how these two products are related. So if you look at that, Azure is Microsoft public cloud offering, and Logic App is one of the de facto workflow engine in Microsoft Azure. Now, when Microsoft Power Automate or Microsoft Flow, that it used to call that time, was announced or launched back in spring of 2016, it was built on the top of Logic Apps, and pretty much everything we could do in Flow was available with Logic App as well. But over the course of last 5 years now, like Power Automate also had added its own unique set of features. So if I had to visualize the relation between these two products, so Power Automate or Cloud Flows are still are based on logic apps, and you'll see there is a big overlap between those. And when it comes to the overlap, what's still common between logic apps and Power Automate is designer, a lot of actions and trigger. However, over the course of last 5 years, Power Automate has also added its own unique features which are only available in Power Automate and not in logic apps. For example, business process flows, desktop flows, additional actions like SharePoint approvals, and many more, which are only available in Power Automate and not in Logic Apps. However, if you see, Logic App is pretty broad, has pretty broad offering, and it has a very tight integration across Microsoft Azure. That's why I use, and whenever a Cloud Flow runs, it still uses a Logic App runtime in the backend. So for example, if you are interested to know how the backend works, so whenever a Microsoft Flow instance starts, behind the scene, it uses Logic App runtime, and it uses the data connectors, and it's constantly communicate with your external external service. But you as a developer don't have to worry about it. Everything happens in the backend. So the point here is, even if you are executing a Power Automate behind the scene, it's still using the Logic App runtime. Now here I have the screenshot where I have implemented similar business logic, and on right hand side and left hand side I have used a different product. One is Logic App, one is Power Automate. And if you look at the screenshots here, it's really difficult to tell from just if you focus on the business logic, like which one is built with using Logic App and which one is built using Power Automate. Like, of course, if I remove the ribbon and if I unhide the left-hand navigation, then it will give you a clue which one is done with Logic Apps or Power Automate. But if you would really want to quick take a guess, you can just take a guess and see whether your guess is correct or not. So the business logic is exactly the same. Both sides, the automation is starting whenever something is getting created in SharePoint. Then we are initializing a bunch of variables, and there is a condition. Now let me take out this thing, and you can see here the one on the left hand side is created using Logic App. The one on right hand side is created using Power Automate. However, if you focus on the designer part, it's still the same. Like, what does that mean is, if you are familiar with Power Automate and how exactly it works, then automatically you're also familiar with Logic App, because the design is pretty much the same, and the actions or the way you go about development is pretty much the same. And same is the case vice versa. If you're familiar with Logic Apps, then that means you're pretty much familiar with how the Power Automate or Cloud Flows work. So let's talk about the key differences between these two products. So Logic Apps is part of Azure Group, and Power Automate is part of the Power Platform or Business App groups. Now you may be wondering why I have listed this as a key difference. The reason for that is, if you see historically, if any product is part of a big product group, then that product will have a really good integration story with other related products. For example, since Logic App is part of Azure Group, it has a really tighter integration with other Azure products such as Azure DevOps and other related services. Same case with Power Automate. Since Power Automate is part of Power Platform, it has a really tighter integration with Power Apps, Power BI, and also Power Virtual Agents as well. So Logic Apps is an infrastructure iPaaS offering, whereas Power Automate is a software as a service offering. The way the pricing work is, in Logic Apps, you pay per the usage, whereas Power Automate is a subscription based. And the target audience for Logic Apps is IT professionals, whereas Power Automate, when the product was launched, it was more designed for the power users and people who would like to spend more time in low code, no code toolset. So when it comes to Logic Apps, if you go to the Logic Apps in Azure portal, all you can do is create a Logic App, whereas with Power Automate, we can create Cloud Flows, which are nothing but the Microsoft Flow. We can create business process flows. We can create desktop flows. When it comes to the run duration, now this may be a key differentiator between to decide a key parameter or key point that you'll decide which one you'll use or another. So the maximum run duration for Logic App is 90 days, whereas for Power Automate is 30 days. Now, what does the run duration mean? Is if my instance of Logic App starts today, then it should finish in the next 90 days. And same thing, if my instance of Power Automate starts today, then it should finish in next 30 days. Now, you may be wondering why automation needs to run for this much longer duration, right? Because typically if automation start, let's say you have a trigger, then that automation should finish within a few milliseconds. Now, only reason that you will have this longer running instances is if you are having any human interaction in your automation. For example, if I am implementing automation where once something gets triggered, I have approval process in between where a human or has to go and take the action manually. If that's the case, then unless that approval happens, the automation will not go forward, or the instance of Logic Apps or Power Automate will not go forward. In that case, if you have multi-stage approval, then the maximum run duration for your Logic App is 90 days. And let's say you have a 3-stage approval and two steps are done, but we are waiting for the third person to approve a request. However, that person is no longer available, or he or she may be on vacation. And if the duration of your Logic App instance is 90 days, the Logic App instance will automatically get terminated. Same goes with the Power Automate as well. When it comes to the application lifecycle management, we can use Azure DevOps, source control, testing. We can also do automation, and there is a really good tighter integration available with other Azure products. So when it comes to the application lifecycle management story with Power Automate, it's not that really fully baked, just like you can see with other Azure products. However, it is getting there. When it comes to the PowerShell commandlets, we have to use Azure rm.logic app module, and you can find more information by going to this link. When it comes to the PowerShell modules or commandlets for Power Automate, you have to install 2 modules. One is for the maker and one is for the administrator. And you can go to this link to find more information about the PowerShell for that. Now, when it comes to the trigger, most of the triggers are pretty similar. Like both has manual trigger. That means I can manually trigger a Logic App or Power Automate. Both has event-based, where something happens like created, updated, or deleted event. Schedule, you can run both Power Automate and Logic Apps on the schedule as well. However, Power Automate has an additional trigger which is not available in Logic App, which is a location-based. There's a lot of interesting use case you can do with that. I'd highly recommend to check out the Microsoft documentation on how we can use location-based trigger in Power Automate and what are some of the business scenarios you can capture that way. Now, when it comes to the setup and installation, all you need for the Logic App is you need a modern browser, and there is a code view available. And what does a code view means is along with the designer, we can also use code view, where if you are familiar with JSON, then you can use a JSON editor to quickly add implementation of your Logic App. We can also use Visual Studio for development as well. However, for Power Automate, the only supported scenario is a modern browser, and we don't have a code view available. Now, there is a latest offering from Microsoft called Dataverse for Teams, where we can use Microsoft Teams client as well to configure and create a Power Automate, with only caveat that Power Automate will only work in the context of the team only. When it comes to the integration with SharePoint, so there is no direct integration of Logic App with SharePoint. However, there is a direct integration of SharePoint and Power Automate. So if I have to create automation or workflow using Logic App that is integrated with SharePoint, then I have to go to Logic App Designer and then configure my business logic over there. So if I compare that with Power Automate, I have 2 options. I can either go to SharePoint's modern UI, and from there itself I can configure automation, or I can go to the Power Automate Designer and start configuring the implementation. I can also use Microsoft Teams as a client as part of Dataverse for Teams. So what does that mean is if I go to the SharePoint UI and if I go to modern SharePoint UI, there I can directly have links where I can just start creating my flows and start implementing my business logic. Same of like the built-in integration with Logic App is not available. So when it comes to consuming on-premise data, let's say you have on-premise data that you would like to consume in Logic Apps and Power Automate. So both of these products support on-premise gateway, where you have to install on-premise gateway, configure some additional settings, and that way you can expose your on-premise data. For example, if you have on-premise SQL Server and you would like to use data from that SQL Server in your business logic, you can do that using on-premise gateway. Both products support that. However, there is one caveat, and that can be a major deciding factor which product you use over another. So when you go with Logic App, since everything is based on consumption, you don't need an additional license to use on-premise connectors or on-premise gateway. Whereas if you go with Power Automate, you need additional premium license. When it comes to the pricing, right? So Logic App is pretty straightforward. Just like Azure, everything is consumption based, and you pay as you go. And if you open Azure pricing calculator, they are very cheap. Not as cheap as, let's say, Azure Function, but they are still relatively cheap. And let's say for typical automation scenario, let's say if you're running automation that starts maybe get executed 10 times a day or 20 times a day, and you're not doing a lot of steps in that, then you're looking at like a fraction of $1 per day or maybe less than that as a cost. Whereas Power Automate is subscription based, and this may be a deciding factor which one you will use over another. So there are multiple versions of Power Automate available. We also have Power Automate free. Now, not many people know that, but you can use Power Automate free as long as you have a valid Microsoft Live account. What does that mean is if you have account with Outlook.com or MSN.com or Live.com, then using that account, you can use Power Automate free. That means you can implement some automation without paying a single money over there. Whereas Logic Apps, there is no free version available. Everything is based on pay as you go. You can also get Power Automate as part of your Microsoft 365 subscription. In most of the subscription, Power Automate is already bundled with some limitations. We can also get Power Automate as part of your Dynamics 365 subscription as well. Or you can also sign up for the premium plan for Power Automate, and those are available as per user plan and per flow plan as well. And there is an additional option available, Power Automate per user plan with attended RPA. Now, what I mentioned, Power Automate is also included as part of your Microsoft 365 subscription. Now, if it's something is already included, that means you don't have to pay for it to use it because it's part of your monthly subscription fee. And with Microsoft 365, you get Microsoft Teams, you get Office, you get Exchange, Planner, and some other services as well. So where you need to use some kind of premium options, so there is a trigger called HTTP trigger or action, which is a premium action and which is not part of your Microsoft 365 subscription. That means if I'm using Power Automate through my Microsoft 365 subscription, and there are some scenarios where I would like to use HTTP action or trigger, then I had to have a premium license over there. Now, what are some of the scenarios where you will be using HTTP action or trigger? One is if you had to call Microsoft Graph APIs from your Power Automate. Now, Microsoft Graph APIs are a single endpoint available to us. And using Microsoft Graph APIs, you can access the data that is there in Microsoft 365 services and also in Windows 10 services as well. In Microsoft 365 services, we can access the data in Exchange, Teams, SharePoint, OneDrive, Planner, etc. And there are a lot of use cases where you would like to use Microsoft Graph API. However, if you would like to use Microsoft Graph API through Power Automate, then you need to use HTTP action. And that HTTP action is a premium action and is not covered under your typical Microsoft 365 license plan. If you had to call any external APIs, for example, if you had to call any external service or your own enterprise API, then you will be using HTTP action. If you had to call Azure functions from your Power Automate, for that you had to use HTTP action. If you had to call Logic Apps from your Power Automate, for that you had to use HTTP action. And HTTP action is not available as part of your Microsoft 365 subscription. You can use it, but you just have to go with one of the premium plans. So this may be a deciding factor, which one you go with versus another, because if you compare that with Logic App, since everything is based on consumption, you don't have to like pay additional license to use HTTP action or trigger. as long as your automation is not, let's say, running multiple times a day and not doing some crazy computation in the backend, chances are the price that you're paying is a lot cheaper as compared to some of the premium plans for Power Automate. Now, let's say you start with Power Automate and you implemented, let's say, 60% of your business logic, and later on you realize that I may have to use some premium connectors, and instead of signing for Power Automate per app, per flow, or per user license, you figure out that if you use Logic App, then it will be cheaper. So there is a good story available here. Is if you have a Power Automate, you can import that and deploy that as you can export that and deploy that as a Logic App. So all you have to do it is go to your Power Automate portal, open the Power Automate, and if you click on the more, there in the export option, you will see that you can export that flow as a Logic App template, and then you can go to the Azure portal and deploy that as a Logic App. However, if any action that is not available in Logic App, you have to delete that action and add any a similar action, or you have to just rework your business logic. And also you will need to reconfigure your connectors and some other stuff. But that you should always keep in that mind. Like, let's say if you are using an action which is there in Power Automate, and you export that as a Logic App template, you went to Azure portal and you start deploying that as a Logic App. Then let's say a specific action is not available in Logic App, you have to basically remove that action and then add a similar action, or you just have to rework your business logic. Now, when it comes to the integration between those two products, so I can call a flow from Logic App using HTTP action. I can call a Logic App from a flow or Power Automate using HTTP action. I can also export flow and deploy that as a Logic App. However, reverse is not possible. So if I start with Logic App, I cannot really export that. If I had to convert that into Power Automate, I had to basically manually do that. Now, when it comes to the integration with other Power Platform products, Power Virtual Agent is one of the latest offering in Microsoft Power Platform, and we can use Power Virtual Agents to write no-code chatbots pretty quickly. If I had to call a Logic App from a Power Virtual Agent, the way I had to do it is I had to first call a Power Automate, and from Power Automate, then I had to call a Logic App. Whereas there is a really good integration story available between Power Automate and Power Virtual Agent, where there is action available right in the Power Virtual Agent that I can just use to call a Power Automate. And the reason you have this like seamless integration between a couple of products, because those products are belong to the Microsoft Power Platform. So let me quickly show you a quick demo. I think we're just running out of time, so maybe I will not be covering demo. But if I had to compare these two products, right? This is my personal opinion. So Logic Apps versus Power Automate. So when it comes to the licensing, the Logic Apps licensing is very straightforward. Everything is based on the consumption, whereas Power Automate, you had to know or do some reading and find out information, because depending on how you're accessing Power Automate, whether it's a free version or whether it's through Microsoft 365 license or whether it's through Dynamics 365 license or based on per app, per flow or per user, there may be some different feature sets and options you'll get. When it comes to the personal automation, Power Automate wins hands down. The reason I'm saying it wins hands down because it comes with a free version as well. That means without paying a single fee to Microsoft, I can use Power Automate for my personal automation. And to do that, you just have to have a live Microsoft account, just like live.com, outlook.com, or msn.com. Whereas with Logic App, you can do a lot of personal automation scenarios, but everything you do, you have to pay for it. When it comes to the power user friendly, Power Automate wins hands down here, because to create Logic Apps, you have to go to the Logic Apps portal and start configuring that. Now, let's say if you are a power user and you're more comfortable using Power Automate, and now you have to implement the similar business logic using Logic App, and you're not comfortable navigating around Logic Apps. So what you can do is you can work with your company's IT team or maybe architects and ask them to create a Logic App for you, like a blank Logic App, and then just share the URL with you, and you just have to go to the designer and start implementing your business logic. So that way you don't have to worry about navigating around the Azure portal, because for power users, sometimes Azure portal can be quite intimidating and scary. When it comes to developer friendly, Logic App wins hands down here. Integration with third party, those two products are pretty similar. So overall, both products are really good, but depending on your use case and depending on how you are getting the license, you can decide which one to go over another. Now, if you would like to get your hands dirty with Microsoft Power Automate and you don't have access to it, what you can do is you can go to this link and sign up for Microsoft 365 Developer Program. So once you go to this link, you will get an email, and through that email, you have an option to create your personal Microsoft 365 subscription for free. And that subscription will come with 25 users with E5 license. Now, E5 is the highest category of license you can get in Microsoft 365. And that subscription will be valid for 90 days and you will be a global admin. And after 90 days, if you're still using this subscription for personal training and development, Microsoft will graciously increase the trial period for additional 90 days. And they will keep on doing it as long as this program is active and you're not violating any license terms. You can also sign up for the 1 month trial. And with this Microsoft 365 subscription, you get Exchange, SharePoint, Teams, Power Apps, Power Automate, and you can also sign up for the free version of or trial version of Power Virtual Agents as well. Now, when it comes to Logic Apps, the best way to learn anything in Azure is to get your personal Azure subscription. There are multiple ways to get that. The recommended one is to via your MSDN subscription, where you just have to go to your MSDN portal and depending on what type of subscription you have, you may get some free credits per month for free. And to use the credits through MSDN, you don't need to use your credit card. You can also sign up for a free trial where you need to use credit card, and depending on your country, the credit you receive may vary. There is also another program from Microsoft called Azure for Students, where you don't need a credit card. All you need is a valid educational account. And depending on your country, you get some predefined credits for free. And you can go to this link to find more information about Azure for Students. So hopefully the contents we covered today made you familiar with the key differences between these two products. And if you don't have access to Microsoft 365, definitely check out this link and get your own personal tenant for free. So these are the things we covered today. And these are my contact details. Thank you very much for joining us today. If you have any further questions, feel free to contact me on LinkedIn, or my email address is also here. With that, stay safe and stay healthy, and we'll be taking any questions if you have.
Thanks a lot for a great session, Prashant. It was very good, very informative. Let's wait for a few questions.
Okay. All right, I see there is a comment, but not a question. Thanks, Amar. Thanks for joining us today.
Thanks, Amar. Yes, thank you, people, for joining. Prashant will be around. If you have any questions, you can reach out to him on his social media, or you can. Okay, Amar has one question. I'll just pop
there is
it.
a question, yes. Whether
I'll
low
just pop
code,
it
no. Okay, so the question is whether low code, no code will replace the traditional development in future. I think no. Both will have its own use case. You'll see more and more enterprises, especially, will be using low code, no code for their business app. However, there is still tremendous demand or need for the professional development. However, low code, no code will give you a really good or return on investment on short time. So both will be there. However, in the enterprise space, you will see more adoption of low code, no code. In the product development space, you'll see they will still be preferring using the professional development over there. Okay. Sorry.
There's one more.
Yeah.
We just have a minute of time left. Probably you can take this up.
So there is another question. Can you please give a short briefing on major points? I'm a bit late. All right. So it will be hard for me to cover the entire session. What I would recommend you is just watch the recording and just email me or just connect me on LinkedIn, and we can have a side chat, and I can answer any specific questions, because I know like there are other speakers also waiting for us to end this session. So really appreciate you joining us. And I think now we are at time and we had to conclude here. So thanks for joining, and stay safe and stay healthy.
Thanks a lot. People, all the sessions will be recorded and you can all go watch that back on YouTube anytime you want. Thank you so much. Thanks for joining. Hi, Ananda. Can you hear me? Hello?
Hello? Oh, wait.
Hello? Can you hear me? Hello? Ananda, can you hear me?
Hello? Can you hear my voice? Here in Indonesia and great for the
Hi, Nanda. Can you hear me?
Okay, I'm hear you. You can hear my voice.
Yes, clear, loud and clear.
Okay, okay.
Okay, thank you, people. Thanks everyone for joining. The next session is going to be by Ananda. The topic is going to be continuous delivery using Spinnaker on Azure. Ananda is an undergrad student. She's a Flash enthusiast. She has worked on containers. She has worked on multiple cloud platforms. While doing her undergraduate, she has taken interest to learn a lot of technologies, which she's going to share about a few today. Please provide the feedback for the sessions on the link provided, and you can post your questions on YouTube chat. The stage is all yours. Take it away, and thanks.
Thank you.
You can start, and please share your presentation screen.
Okay, thank you. I will share my presentation. Okay, okay. Thank you for all of you. Good evening, maybe good afternoon or good morning for all of you from every time zone. Okay, today I will sharing with you in Azure Community Conference. This is my first conference related Azure technology, and I'm very thank you with committee and okay, welcome to my session. Continuous delivery using Spinnaker on Azure. My name is Ananda Dwi Rahmawati, and you can call me Nanda or Dwi. I'm cloud engineer at BTech or Poor Technology in Indonesia since around 2 until 3 years ago. And with a lot experience and knowledge related cloud, DevOps, and open source too. I'm open source enthusiast. And now I'm still learning about development things, especially in serverless. You can keep in touch with me by this link. I attach my LinkedIn, my blog, social media there. Feel free to contact me for question or feedback or anything else. All right. This quick session, this lightning talk session, will equip you with a basic understanding of Spinnaker, about intro, what is Spinnaker, features, component, about data flow, related application management and application deployment of Spinnaker, Spinnaker integration with Azure, and automating with Spinnaker. Next, okay, first with intro. But when you want to use Spinnaker for continuous delivery tool, there are some prerequisites when you want to use it for DevOps environment in your own production maybe and or development or staging. And first, you should know about continuous delivery. Uh, Continuous delivery and maybe continuous deployment and continuous integration too, so you can make sure it and then understanding about cloud computing, because as Spinnaker was built with a cloud first philosophy and integrates with a large number of cloud provider like Azure. And then we can go on in with Spinnaker. This pronunciation is Spinnaker, open source multi-cloud container delivery platform. You can find the official website in spinnaker.io. So spinnaker.io and a small mental sail to the main sail, especially a triangular one is on yacht for running before the wine. And it initially developed by Netflix Ascot in 2014, open source in 2015, and built for releasing software chains with high velocity and confidence, and designed with pluggability in mind. Uh, Support for all major cloud providers such as App Engine in GCP, Azure, AWS, DCOS, Oracle Cloud, Cloud Foundry, and cluster management. And also, no surprise, manage application deployment, and it's capable of handling blue-green deployment, rolling update, and canary deployment. We will explain the detail in next slide. Spinnaker advantage. There are many advantage when we use Spinnaker for container continuous delivery tool. First, multi-cloud CI/CD. We can integrate Spinnaker with Jenkins for continuous integration and Spinnaker for continuous delivery, and it deploy across multi-cloud provider, especially in Azure. Variable pipeline types, easy rollback. We can create and deploy immutable image for faster rollout and easier rollback and the elimination of hard to debug configuration drift issues. And leverage an immutable infrastructure as maybe we can using deployment canary deployment or blue green rolling red black canary variable deployment strategy. And then hybrid cloud VM or container, and next CI integration. We can listen to the events, collect artifact, and trigger pipelines from Jenkins or Travis CI. Triggers via Git, cron, or a new image in a Docker registry are also supported. Or maybe you want to use a private container registry too, it'll also supported. And then Halyard CLI is the core feature, maybe, and core service. I mean, we can use Halyard CLI for install, configure, and update your Spinnaker instance, and it based with CLI or command line interface. And other advantage is airbag, role-based access control. It can restrict access to project or account or maybe cluster by hooking into your internal authentication system using OAuth, SAML, LDAP, Google Group, Azure Group, and GitHub Teams maybe. And for sure you can grade it with Azure Group or Active Directory. And notification for pipeline, maybe we can use email, Slack, even SMS, supported by Twilio, HipChat, and others. I'm using Slack, so we can get notification from Spinnaker environment. And self-deployment judgment, we can create specific pipeline with require a manual approval prior to releasing, maybe from staging to production, where it require a manual approval, so it not automatic. So it need human intervention, right? And then Charles monkey integration, it will test that your apps or microservice they can survive instant failure by terminating them on purpose. And then rustic execution windows, it can restrict Spinnaker can restrict the execution of stage of to certain windows of time, making sure deployments happen during peak traffic or when the right people are on hand to monitor the rollout. It just maybe there are other advantage too that I know attached here. You can see it in official documentation, and there are lots many advantage we can get. Okay. Okay, next we will going to Spinnaker architecture. First, deck protect until Halyard. There are several surfaces that make Spinnaker environment go reach its mission. We can uh, make delivery the application seamlessly and fully integrate. First is deck, our browser web UI. We can configure a pipeline, for example, from UI. We can just using browser, and the browser or the service that make it accessible from browser is deck. And then get is our API gateway and Spinnaker, and all the other services depend on it either directly or indirectly. And then Orca, orchestration engine, it is responsible for taking and execution definition in managing the stages and tasks, coordinating the other speaker services. And then Cloud Driver for indexing and caching. This service is the main integration point for Spinnaker cloud provider like AWS, GCP, Cloud Foundry, and especially Azure. And then from 50 for metadata service, it's the system of record for all Spinnaker metadata, including application pipeline, microservice, cluster, service group, and service account configuration. And then Roscoe for VM image. Roscoe picks our image for the major cloud providers, and it's exposed via RESTful API and relies on Hacker. And then Azure is a service that provides a single point of integration with continuous integration. For example, maybe you use Jenkins with source control management for Spinnaker, and then Echo eventing bus is our router for events. For example, a new build is detected by Azure, which should trigger a pipeline, and it is also a scheduler for cron triggered pipelines. And then we have flight out service is the authorization service for the Spinnaker system. It is exposed via a RESTful interface requiring all the access permission for a particular user or account. And then Kayenta, one of the new service with Kill. Kayenta provide automated canary analysis for Spinnaker, and Kill provide managed delivery, and Halyard is Spinnaker configuration service. And then Halyard manages the lifecycle of each of the above service. It only interacts with the service during Spinnaker startup, updates, and rollback. Okay. I take this diagram or architecture from spinnaker.io, the latest architecture. And these are dependencies for Spinnaker surface if get API gateway doesn't start well, it is probably still crummy day because nothing to going work because it connecting all those service each other. You will notice that Spinnaker consider tag external component, and that because it can run without a Spinnaker environment. And you will also notice that there is a run when configuring Spinnaker service called Halyard CLI. I mentioned it before. And this configuration tool recommended for deploying Spinnaker. And Halyard configuration service is a custom Java tool where to manage the provisioning of all services associated with Spinnaker. It is the current recommended way to installing Spinnaker, especially not only in Azure, but maybe you use Kubernetes environment. And a successor to Halyard is being developed, and it is called Clit, and lightweight tool written in Go. It's similar to kubectl in Kubernetes environment. And like maybe you write kubectl get nodes or kubeadmin in it, and Halyard you just write in how deploy apply like that. And Halyard get its name from the movie. It's just not main information. Maybe you doesn't hear it yet. 2001: A Space Odyssey, in which a computer named HAL 9000 causes issues for the main protagonist. Okay. And then application management of Spinnaker architecture. First, we have our project. So maybe in Spinnaker environment, we have multiple project. And what is a project? Project is a logical grouping and configuration of application. This is optional. Project is not required, but highly recommended when you use Spinnaker as a continuous delivery tool. The applications are grouped into respective project, and then we use application. Yeah, we deploy the application by Spinnaker, and application is a microservice or app for short. And best practice is designing a one-to-one parity for each application, meaning you don't overlap existing application under a different parent application. And then cluster here. We have a cluster. So we have one project here, for example, and I will explain by the diagram in the next slide. Cluster to application and specific 5 cluster, and cluster is logical grouping or server group. So one cluster maybe have uh, 2 or 3 server group. This is the command center, and the Spinnaker UI and cluster are where you can gain insight into when or what your server grouping are doing, what's their health, and various other metadata for your deployment. And then server group, our base level resource. This is the lowest level of our Spinnaker environment. Server group is where your artifact resides and hooks into various cloud providers for persistence and to run the software deployed. And then we have load balancer. They balance traffic among instance in the server group with the ability to health check and define health criteria for checks on endpoint. Its specific route and ingress protocol and port range. And last but not least, we have a firewall which defines network access. Firewalls are defined by an IP address range inside a notation, communication protocols such as HTTP, and port range. And this is a lot of information, and then this scenario I found from Spinnaker.io too. We have 2 applications, application 1 and application 2, which denotes that we are likely under a project that groups them, narrowing in our yellow square. Gray square, I mean, in application 2 server group in cluster D. It contains one load balancer and firewall, and in each server group have applications. Maybe the applications use canary deployment as a strategic deployment. Blowing up the cluster to get an inside view, we see that firstly there is a required load balancer. So when we want to access the start application, it requires a load balancer here. The traffic income and outcome must pass by a load balancer service to directing traffic to the appropriate server group. The load balancer will send traffic through an optionally configured firewall to the server groups of 1 or 2, depending on your strategic deployment strategy. And this diagram especially use blue and green deployment or red or black deployment is currently happening as it's the load balancer is moving traffic to a new server group, maybe server group 1 and server group 2. Okay, next application deployment consists of pipeline, stage, task, and deployment strategies. Application deployment or a set of features to construct and manage for our continuous delivery workflows. Application deployment all begins with the pipeline. Is our sequence of actions. We define the action there. The pipeline in the application configuration is what the server group are to the application management. It serves as the fundamental resource for the deployment and consists of several stages that can pass of parameters to one another upon completion. They can be run manually or triggered by another source. And then we have stage or collection of tasks to perform. Tasks here are divided as an automatic function abstraction away cloud specific action. Currently, there exists a wide variety of stage depending on your provider. Maybe we can use Azure Cloud Platform, which is defined by you in the setup of Spinnaker. This can range from a generic script to be run, scaling a Kubernetes object via manifest to creating a whole suite infrastructure in Azure. Stage can be performed linearly or in parallel. Here the example. There also is the ability to create custom stage to suit your needs with REST API provided. And then we have our deployment strategies. Deployment strategies are exactly what they sound like, a strategy. They determine how our deployment is going to be fulfilled. Should it require a health check or use a canary to determine success rate, or should a manual operation be involved? And in this pipeline blueprint I found in Spinnaker.io too. We have 7 defined stage with 2 additional stage running in parallel to their parallel partner. At the beginning of our pipeline, we have a trigger that starts the whole process. Triggers can be time-based triggers, manual, or you can use cron, or event-based triggers such as git, CI tool, or push to a Docker repo. Pipeline or traditional pub and sub. In our second stage, we are finding an artifact named image from an account called test. This image is then deployed as canary deployment where only a percent of user or services will consume it. From the canary deployment, we reach our first parallel stage in our pipeline. And now there are two things happening in this parallel stage. First, there's a manual approval process requiring human intervention, likely maybe analysis. And second, 30 minutes has to have elapsed from the previous stage. And both of these must be met in this example pipeline before moving on to next stage. And after previous stage is completed, the deployment shifts into a red-black deployment. This means that we are standing up an exact replica of our prod environment with a new code to make sure that it's going to work. From there, we are moving to our next parallel stage. This will tear down our canary and wait 2 hours to ensure that our red-flag deployment is sufficient before moving forward and destroying the old prod environment. Once the above stage are met, our pipeline is completed. This completes the cycle of life for this Spinnaker pipeline, and as we did with cluster, let's take a deeper look at pipeline UI here. And before we go to this UI, we can refresh this development strategies that natively support and recommend when we use Spinnaker, red, black, or blue, green, rolling red, black, and canary. First, we have a red-black deployment or blue-green, where we are standing up an exact replica of our environment to slowly direct traffic towards branding to old one. We have our rolling red-black deployment. This will begin to stand up exact replica over time with an optional validate step between the two. After we validate the deployment, the rolling will begin slowly and the new production environment will take on new traffic. And next we have canary deployment. Canary deployment employs whatever deployment you specify in the end, but force a small percentage of traffic to go towards the next deployment before committing to it. With canary deployment, it is typical to wait and analyze the results from a canary to make sure that a new deployment with the new code calling or not it's production ready. Okay. Here is Spinnaker UI by Dex Service. There's a lot going on this single pane, this single dashboard, but we'll just be covering fundamental, the basic. First, in the left corner, MDS service, or microservice or application that we created. Everything else using this page, we are holding to this application, and consequently, the project that we make the application is under.
Hi,
We have
Ananda.
pipeline.
Sorry to interrupt. No, sorry to interrupt, Ananda. The time is almost complete. Try
Okay,
to go to your closing notes. Thank you.
okay. Okay, this is assessing UA. When you create new application and create pipelines for dev staging and production with manual approval in staging. Okay, this I use this reference from official documentation ebook, and you can join this Winaker Slack. Thank you. With Q&A, and maybe you can give the feedback.
Thanks for the session, and that is very informative. The
Thank
feedback
you.
will be provided on the URL. In the interest of time, let's take the questions offline, as it is already time. Thank you so much. Thanks for the session.
Thank you. Thank you.
Hello, everyone. Thanks for joining. It was a wonderful session.